ಹೆಲೋ ಆಲ್. ಇವತ್ತು ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ನಲ್ಲಿ ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ನಲ್ಲಿ ಉಳಿದ ಪಾಠನ ನೋಡಿ ಅದಾದ ನಂತರ ಅಯಾನಿಕ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀನಿ. ಈಗ ಕೆಮಿಕಲ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ನಲ್ಲಿ ನಿನ್ನೆ ನಾನು ಕ್ಯಾರೆಕ್ಟರಿಸ್ಟಿಕ್ಸ್ ಆಫ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಇವಾಗ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ನಲ್ಲಿ the first application is to predict direction of a reaction. ಡೈರೆಕ್ಷನ್ ಆಫ್ ಅ ರಿಯಾಕ್ಷನ್ ಅನ್ನು ಯಾವ ತರಹ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದನ್ನು ನೋಡೋಣ ಯೂಸಿಂಗ್ ಕೆ. ಈ ಡೈರೆಕ್ಷನ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನು ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ನಮಗೆ ಕ್ಯೂ ಆ್ಯಂಡ್ ಕೆ ಎರಡು ಇಂಪಾರ್ಟೆಂಟ್ ಪ್ಯಾರಾಮೀಟರ್ಸ್ ಬೇಕಾಗ್ತವೆ. ಕ್ಯೂ ಇಸ್ ಕಾಲ್ಡ್ ರಿಯಾಕ್ಷನ್ ಕೋಶಂಟ್. ಕ್ಯೂ ಅಂದರೆ ರಿಯಾಕ್ಷನ್ ಕೋಶಂಟ್, ಕೋಎಫಿಷಿಯಂಟ್ ಅಲ್ಲ, ರಿಯಾಕ್ಷನ್ ಕೋಶಂಟ್. ಕೆ ಅಂದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟ್. ರಿಯಾಕ್ಷನ್ ಕೋಶಂಟ್ಗೂ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ಗೂ ಏನು ಡಿಫರೆನ್ಸ್, ಆ ಎರಡು ಏನು ಅನ್ನೋದು ಒಂದ್ಸಲ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ, ಫಾರ್ ಅ ರಿಯಾಕ್ಷನ್ ಲೈಕ್ ಎ ಮೋಲ್ಸ್ ಆಫ್ ಎ, ಬಿ ಮೋಲ್ಸ್ ಆಫ್ ಬಿ ಗಿವ್ಸ್ ರೈಸ್ ಟು ಸಿ ಮೋಲ್ಸ್ ಆಫ್ ಸಿ ಪ್ಲಸ್ ಡಿ ಮೋಲ್ಸ್ ಆಫ್ ಡಿ. ಈ ತರಹದ ಒಂದು ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್ ಏನಿದೆ, ಈ ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್ಗೆ ಕ್ಯೂ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಿದರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಸಿ ಟು ದ ಪವರ್ ಸಿ ಡಿ ಟು ದ ಪವರ್ ಡಿ ಡಿವೈಡೆಡ್ ಬೈ ಎ ಟು ದ ಪವರ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಟು ದ ಪವರ್ ಬಿ ತಗೋಬೇಕಾಗತ್ತೆ. ಅದೇ ನಾನು ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಅನ್ನು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಬೇಕು ಕೆ ಅಂತ ಅಂದರೂ ಕೂಡ ಸಿ ಟು ದ ಪವರ್ ಸಿ ಡಿ ಟು ದ ಪವರ್ ಡಿ ಎ ಟು ದ ಪವರ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಟು ದ ಪವರ್ ಬಿ ತಗೋಬೇಕಾಗತ್ತೆ. ಅಂದರೆ ಕ್ಯೂಗೂ ಕೆಗೂ ಈಕ್ವೇಷನ್ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಒಂದೇ ತರಹ ಬರಿತೀವಿ, ಸೇಮ್ ವೇ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಬಿ ರಿಟನ್. ಬಟ್ ದ ಡಿಫರೆನ್ಸ್ ಈಸ್ ಕ್ಯೂ ಇಸ್ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟೆಡ್ at any point during the reaction, whereas K is calculated only after attaining the equilibrium. ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಬಂದ ನಂತರ ಮಾತ್ರ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಿದರೆ ಅದು ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗುತ್ತೆ. ಕ್ಯೂ ಅನ್ನೋದು ಒಂದು ವೇರಿಯಬಲ್ ಆಗಿರುತ್ತೆ, ಅದು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಲ್ಲ. ಒಂದು ಪಾಯಿಂಟ್ ಆಫ್ ಟೈಮ್ನಲ್ಲಿ ಬೇರೆ ಬೇರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಇರ್ತವೆ ಅಂಟಿಲ್ ವಿ ಅಟೈನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್. ಅದಕ್ಕೆ ಕ್ಯೂ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಈಚ್ ಪಾಯಿಂಟ್ ಆಫ್ ಟೈಮ್ನಲ್ಲಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರುತ್ತೆ. ಸೊ ಅದು ಕ್ಯೂ ರಿಯಾಕ್ಷನ್ ಕೋಶಂಟ್, ಕೆ ಈಸ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕಾನ್ಸ್ಟೆಂಟ್. ಈಗ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದ ವಿಷಯ ಏನು ಅಂತಂದರೆ, ಕ್ಯೂ ಆ್ಯಂಡ್ ಕೆ ಯೂಸ್ ಮಾಡಿ ಯಾವ ತರಹ ನಾವು ಒಂದು ಡೈರೆಕ್ಷನ್ ಆಫ್ ರಿಯಾಕ್ಷನನ್ನು ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ನೋಡೋಣ. ಅದರಿಗೋಸ್ಕರ ಫಸ್ಟ್ ಒನ್ ನಾನು ಕ್ಯೂ ಅನ್ನೋದು, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಒಂದು ಡೇಟಾ ಕೊಡ್ತೀನಿ, ಅದರ ಪ್ರಕಾರ ಕ್ಯೂ ಕೆ ಮಧ್ಯದಲ್ಲಿ ರಿಲೇಷನ್ ಒಂದ್ಸಲ ನೋಡೋಣ, ಅನಂತರ ನಾನು ಇದು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡ್ತೇನೆ. ಸೊ ನನ್ನ ಹತ್ತಿರ ಒಂದು ರಿಯಾಕ್ಷನ್ ಇದೆ, ಎ ಪ್ಲಸ್ ಬಿ ಗಿವ್ಸ್ ರೈಸ್ ಟು ಸಿ ಪ್ಲಸ್ ಡಿ ಅನ್ನುವ ಒಂದು ರಿಯಾಕ್ಷನ್. ಈ ರಿಯಾಕ್ಷನ್ನಲ್ಲಿ 5 moles ಆಫ್ ಎ 5 moles ಆಫ್ ಬಿ ತಗೊಂಡಿದ್ದೀನಿ. ಆವಾಗ ಸಿ ಆ್ಯಂಡ್ ಡಿ 0 0 ಅದಾವೆ. ಈ 5 moles ನೆಕ್ಸ್ಟ್ ಟೈಮ್ 4 moles ಆಗಿದೆ, ಅಂದರೆ ಇದು 1 mole ಈಚ್ ಫಾರ್ಮ್ ಆಗಿದೆ ಅಂತ ಅನ್ಕೋಬೋದು. ಅನಂತರ ಇದು 3 moles, ಅದು 2 moles ಆಗಿದೆ. ಅನಂತರ ಇದು 2 moles, ಅದು 3 moles ಆಗಿದೆ. ಆ್ಯಂಡ್ ಅಲ್ಲಿಂದ 2 moles 3 moles ಕಂಟಿನ್ಯೂ ಆಗಿದೆ. ಅಂದರೆ ಈ ಪಾಯಿಂಟ್ ಆಫ್ ಟೈಮ್ನಲ್ಲಿ ನಮಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅನ್ನು ಸಿಸ್ಟಮ್ ಅಟೈನ್ ಮಾಡಿದೆ ಅಂತ ಹೇಳ್ಕೋಬೋದು. ಈಗ ನೆಕ್ಸ್ಟ್ ಪಾರ್ಟ್ನಿಗೆ ನಾವು ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ, ಇಲ್ಲಿಗೆ ಈಗ ನಾನು ಈ ಫಾರ್ಮುಲಾ ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸಿ ಪವರ್ ಸಿ ಇಂಟು ಡಿ ಪವರ್ ಡಿ ಡಿವೈಡೆಡ್ ಬೈ ಎ ಪವರ್ ಎ ಆ್ಯಂಡ್ ಬಿ ಪವರ್ ಬಿ ಫಾರ್ ಎವ್ರಿ ಡೇಟಾ ದಟ್ ಐ ಹ್ಯಾವ್ ಅಟ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಇನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಟೈಮ್. ಇದನ್ನು ನಾನು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಿದಾಗ 0 ಇಂಟು 0 ಡಿವೈಡೆಡ್ ಬೈ 5 ಇಂಟು 5 ಈಸ್ 0. And then 1 into 1 divided by 4 into 4, that is 1 by 16. 2 into 2 divided by 3 into 3, that is 4 by 9. 3 into 3 divided by 2 into 2, that is 9 by 4. ಸೊ ಈ ಡೇಟಾ ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ನಮಗೆ ಅರ್ಥ ಆಗುವ ವಿಷಯ ಏನಂತಂದರೆ ಫಸ್ಟ್ ಟೈಮ್ 0 ಬಂದಿದೆ, ಎರಡನೇ ಇನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಟೈಮ್ನಲ್ಲಿ 1/16 ಬಂದಿದೆ, ಮೂರನೇ ಇನ್ಸ್ಟೆಂಟ್ ಆಫ್ ಟೈಮ್ನಲ್ಲಿ 4/9 ಬಂದಿದೆ, ನೆಕ್ಸ್ಟ್ 9/4 ಬಂದಿದೆ. ಅಲ್ಲಿಂದ ಯಾವಾಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದರೂ ಕೂಡ ಅದು 9/4 ಬರುತ್ತೆ. ದೇರ್ ಫೋರ್ ಇದನ್ನು ನಾವು ಕೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸ್ಟೆಂಟ್ 9/4 ಅನ್ನು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ತಗೋಬೇಕು. 4/9 1/16 0ಗಳನ್ನು ಕ್ಯೂ ಅಂತ ತಗೋಬೇಕು. 9/4 ಕೂಡ ಕ್ಯೂನೇ ಆಗತ್ತೆ. ಆದರೆ 9/4ನಲ್ಲಿ ಕ್ಯೂ 9/4 ಬಂದಾಗ ಕ್ಯೂ ಆ್ಯಂಡ್ ಕೆ ವಿಲ್ ಬಿಕಮ್ ಈಕ್ವಲ್. ಅಂದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಹತ್ತಿರ ಕ್ಯೂ ಆ್ಯಂಡ್ ಕೆ ಈಕ್ವಲ್ ಆಗ್ತವೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಇನ್ನೊಂದು ವಿಷಯ ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಬೇಕಾಗಿದೆ ಏನಂತಂದರೆ 9/4 ಅಂದರೆ ಸುಮಾರು 2 ಪಾಯಿಂಟ್ ಸಮಥಿಂಗ್ ಬರುತ್ತೆ. ಅದೇ ನಾನು 4/9 ಅಂದರೆ 0 ಪಾಯಿಂಟ್ ಸಮಥಿಂಗ್ ಬರುತ್ತೆ. ಅಂದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಟೈನ್ ಮಾಡಲಿಕ್ಕಿಂತ ಮುಂಚೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಏನಿದೆ, ಕ್ಯೂ ವ್ಯಾಲ್ಯೂ ಏನಿದೆ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಹತ್ತಿರ ಕ್ಯೂ ಈಕ್ವಲ್ಸ್ ಕೆ ಆದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬರೋಕ್ಕಿಂತ ಮುಂಚೆ ಕ್ಯೂ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಕೆ ಅನ್ನುವ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ದೇರ್ ಫಾರ್ ಕ್ಯೂ ಇಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಕೆ ಇದೆ ಅಂತ ಅಂದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಇನ್ನೂ ಬಂದಿಲ್ಲ, ಇನ್ಮೇಲೆ ಬರಬೇಕದು. ಆ ಥರ ಬರಬೇಕು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂತಂದರೆ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಸ್ ದ ರಿಯಾಕ್ಷನ್ ಹ್ಯಾಸ್ ಟು ಸ್ಟಿಲ್ ಗೋ ಫಾರ್ವರ್ಡ್ ಅಂತ ಅರ್ಥ. ಸೊ ವೆನೆವರ್ ಕ್ಯೂ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಕೆ, if Q is less than K, then what we need to understand is the reaction goes from left to right side, which means it has to still go forward anta artha. ಒಂದು ವೇಳೆ Q is greater than K ಆದರೆ, if Q is greater than K, then the reaction has to go from right to left side, which means it has to go backward. Whereas if Q equals K, then the reaction is at ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅನ್ನುವ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗತ್ತೆ. ಸೊ ಈ ಕಂಡೀಷನ್ಸನ್ನು ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತಾ ವಿ ಹ್ಯಾವ್ ಟು ಸಾಲ್ವ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ದ್ಯಾಟ್. ಅದು ಮಾಡೋಣ. ವಿ ಹ್ಯಾವ್ ಅ ಕ್ವೆಶ್ಚನ್ ಇನ್ ದಿ ಅಸೈನ್ಮೆಂಟ್ ದಟ್ ಐ ಗೇವ್ ಯು yesterday. We will solve questions from there, but still we have to cover a little more content to solve those questions. We will understand the content and then get back to the assignment. ಇಲ್ಲಿ ನೋಡಿ ಇನ್ನೊಂದ್ಸಲ, Q less than K ಆದರೆ the reaction goes forward, Q greater than K ಆದರೆ the reaction goes backward, and Q equals K ಆದರೆ the reaction stays at equilibrium ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟ್ ಹೋಗೋಣ, ಅಂದರೆ ಸೆಕೆಂಡ್ ಅಪ್ಲಿಕೇಶನ್. ಇದನ್ನು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತಾ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ ನೋಡಿ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಕೆ ವ್ಯಾಲ್ಯೂ ಬಂದ್ಬಿಟ್ಟು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸ್ಟೆಂಟ್ ಕೆ ವ್ಯಾಲ್ಯೂ ಬಂದ್ಬಿಟ್ಟು ಸಮ್ 2.5 into 10 to the power minus 2 ಇದೆ. ಆ್ಯಂಡ್ ರಿಯಾಕ್ಷನ್ A plus B gives rise to 2C plus D ಅಂತ ಒಂದು ಈಕ್ವೇಷನ್ ಇದೆ. At a particular instant of time, concentration of A at a time t, concentration of A equals 1 molar, concentration of B equals 2 molar, concentration of C equals 1 molar, and concentration of D equals 2 molar ಆಗಿದೆ ಅಂತ ಅನ್ಕೋ. Then we will substitute at a particular instant of time ಅಂದರೆ ಅದನ್ನು Q ತಗೋಬೇಕಾ K ತಗೋಬೇಕಾ, ಡೇಟಾ ಎದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು ಅನ್ನೋದು ಡೌಟ್ ಬರಬೇಕು. ಟೈಮ್ ಟಿ ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಹತ್ತಿರನ ಇಲ್ಲ ಅನ್ನೋ ವಿಷಯ ಹೇಳಿಲ್ಲ, ಅಂದರೆ ನಮಗೆ ಬರೋದು Q ಮಾತ್ರ. ಯಾಕೆಂದರೆ ಟೈಮ್ ಪರ್ಟಿಕ್ಯುಲರ್ಲಿ ಓನ್ಲಿ ಅಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಮೆನ್ಷನ್ ಮಾಡಿದರೆ ಮಾತ್ರ ನಮಗೆ ಇದನ್ನು ನಾವು ಕೇದಲ್ಲಿ ಹಾಕೊಳ್ಳೋಕ್ಕಾಗತ್ತೆ. ಇಲ್ಲ ಅಂದರೆ ಇವು ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಅಲ್ಲ. ಆವಾಗ ನಮಗೆ ಇರುವ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ರಿಂದ ಆ ಫಾರ್ಮುಲಾದಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ ಬರೋದು Q ಮಾತ್ರ. ದೇರ್ಫೋರ್ ಇದರಿಂದ Q ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋಣ. Q ಈಕ್ವಲ್ಸ್ C² into D divided by A into B. When I take C² 1 square, D is 2 divided by A value 1, B value 2, 2 and 2 gets cancelled, and finally we get 1. So equilibrium constant Q value, reaction quotient in a value 1 bandide, equilibrium constant in a value 2.5 into 10 power minus 2 bandide. Andre Q is greater than K. Q is greater than K ಇದೆ ಅಂತಂದರೆ ರಿಯಾಕ್ಷನ್ ಗೋಸ್ ಬ್ಯಾಕ್ವರ್ಡ್, ರೈಟ್ ಟು ಲೆಫ್ಟ್ ಹೋಗುತ್ತೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಲೆಟ್ಸ್ ಗೋ ಟು ದ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. ಈಗ ಸೆಕೆಂಡ್ ಅಪ್ಲಿಕೇಶನ್ ಅನ್ನು ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ದ ಸೆಕೆಂಡ್ ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ equilibrium constant is we can predict the extent of reaction, predict the extent of reaction. We can predict the extent of reaction using the reaction quotient. So how do we predict the extent of reaction using equilibrium constant ಅನ್ನೋದು ನೋಡೋಣ. ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನ ಪ್ರೆಡಿಕ್ಟ್ ಮಾಡಲಿಕ್ಕೆ ನಮಗೆ 3 ಕಂಡೀಷನ್ಸ್ ಅದಾವೆ. ಎಕ್ಸ್ಟೆಂಟ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ ಅಂದರೆ ಏನು? ರಿಯಾಕ್ಷನ್ ಎಲ್ಲಿವರೆಗೂ ಆಗಿದೆ ಅಂದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬಂದಿಲ್ವಾ, ಒಂದು ವೇಳೆ ಬಂದರೆ ಅದು ಎಲ್ಲಿದೆ ಅಂದರೆ ಸ್ಟಾರ್ಟಿಂಗ್ನಲ್ಲಿದೆಯಾ, ಆಮೇಲೆ ಎಂಡಿಂಗ್ ಬಂದಾಗ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬಂದಿದೆಯಾ, ರಿಯಾಕ್ಷನ್ ಇನ್ನು ಸ್ಟಾರ್ಟ್ ಆಗಿದ್ಕೊಳ್ಳೇ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬಂದಿದೆಯಾ, ಇಲ್ಲ ಅಂದರೆ ಇನ್ನು ಮಿಡಲ್ ಪಾಯಿಂಟ್ನಲ್ಲಿ ಸಮ್ವೇರ್ ಇನ್ ದ ಟೈಮ್ ಬಿಟ್ವೀನ್ ದ ಕಂಪ್ಲೀಷನ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್ ಆ್ಯಂಡ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಆಫ್ ದ ರಿಯಾಕ್ಷನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬಂದಿದೆಯಾ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಮಗೆ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಥಿಂಗ್ ಹೇಳುತ್ತೆ. Therefore, if Kc or Kp, whatever it is, greater than 10 to the power minus 3, 10 power, I mean less than 10 power minus 3, less than 10 power minus 3 Kc ಇದೆ ಅಂತಂದರೆ 10 power minus 3 is a very low value, ತುಂಬ ಕಮ್ಮಿ ವ್ಯಾಲ್ಯೂ ಇದು, ಅದಕ್ಕಿಂತ Kc ಕಮ್ಮಿ ಇದೆ ಅಂದರೆ ರಿಯಾಕ್ಷನ್ ಜಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ಆದಕೊಳ್ಳೇನೆ ನಮಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬಂದಿದೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ಇದು ಹೇಳ್ತಾ ಇದೆ. ಅಂದರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಕೆ ಅನ್ನೋದು ಯಾವ ಥರ ಬರೀತೀನಿ, ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಡಿವೈಡೆಡ್ ಬೈ ರಿಯಾಕ್ಟೆನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಬರೀತೀನಿ. ಈ ಥರ ಬರೆದಿದ್ದಾಗ ನಾನು ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಬ್ಸರ್ವ್ ಮಾಡಿದರೆ ಇದು ನ್ಯೂಮರೇಟರ್ನಲ್ಲಿದೆ, ಇದು ಡಿನಾಮಿನೇಟರ್ನಲ್ಲಿದೆ, ಇದು 10 to the power minus 3 ಇದೆ. ಈ 10 power minus 3 ಅಂದರೆ ಬಹಳ ಕಮ್ಮಿ ವ್ಯಾಲ್ಯೂ ಬರಲಿಕ್ಕೆ ಕಾರಣ ಏನು? ಕಮ್ಮಿ ವ್ಯಾಲ್ಯೂ ಬರಲಿಕ್ಕೆ ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಇದೆ, ರಿಯಾಕ್ಟೆನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಇದೆ ಅಂತ ಅರ್ಥ. ಡಿನಾಮಿನೇಟರ್ ಜಾಸ್ತಿ ಇದೆ ಅಂದರೆ ರಿಯಾಕ್ಟೆನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತುಂಬ ಜಾಸ್ತಿ ಇದೆ ಅಂದರೆ ರಿಯಾಕ್ಷನ್ ಜಸ್ಟ್ ಸ್ಟಾರ್ಟ್ ಆಗಿದೆ, ಅಷ್ಟೊತ್ತರಲ್ಲೇ ನಮಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬಂದುಬಿಟ್ಟಿದೆ, ಇನ್ಮೇಲೆ ರಿಯಾಕ್ಷನ್ ಮುಂದಕ್ಕೆ ಹೋಗಲ್ಲ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. Therefore Kc is less than 10 to the power minus 3 ಅಂದರೆ ರಿಯಾಕ್ಟೆನ್ಸ್ ಪ್ರಿಡಾಮಿನೇಟ್, ರಿಯಾಕ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಅದಾವೆ, ಪ್ರಾಡಕ್ಟ್ಸ್ ಕಮ್ಮಿ ಅದಾವೆ. ಸೊ ರಿಯಾಕ್ಟೆನ್ಸ್ ಪ್ರಿಡಾಮಿನೇಟ್ ಅಂದರೆ ತುಂಬ ಜಾಸ್ತಿ ಅದಾವೆ, ಡಾಮಿನೇಟ್ ಮಾಡ್ತಿದ್ದಾವೆ ಅಂತ ಅರ್ಥ. ಅಂದರೆ ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಬಹಳ ಡಾಮಿನೇಟ್ ಮಾಡ್ತಿದ್ದಾವೆ, ಆಲ್ಮೋಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ನೆಗ್ಲಿಜಿಬಲ್ ಇದೆ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ದೇರ್ಫಾರ್ ರಿಯಾಕ್ಟೆನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ they predominate ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಅನ್ನೋ ವಿಷಯವನ್ನು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಎರಡನೇದು, ದ ಸೆಕೆಂಡ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕಂಡೀಷನ್ ಇಸ್ if Kc is greater than 10 to the power 3, then what do we understand from that? If Kc is greater than 10 power 3, it means that the value is very high. The value of K is very, very high. Therefore, what we need to understand is, if value of K is very high, it means the concentration of products is very high and the concentration of reactants is very low. Therefore the concentration of reactants is almost negligible. ಅಂದರೆ ಅರ್ಥ ಏನು? ಪ್ರಾಡಕ್ಟ್ಸ್ ತುಂಬ ಜಾಸ್ತಿ ಅದಾವೆ, ರಿಯಾಕ್ಟೆನ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತುಂಬ ಕಮ್ಮಿ ಇದೆ. ಅಂದರೆ ಆಲ್ಮೋಸ್ಟ್ ಕಂಪ್ಲೀಷನ್ಗೆ ಬಂದಾಗ ನಮಗೆ ಕಂಪ್ಲೀಟ್ಲಿ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ರೇಷಿಯೋ ಅನ್ನೋದು 10 power 3 ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ವ್ಯಾಲ್ಯೂ ಬಂದಿದೆ ಅಂತ ಅರ್ಥ. Therefore ರಿಯಾಕ್ಷನ್ ಆಲ್ಮೋಸ್ಟ್ ಕಂಪ್ಲೀಷನ್ಗೆ ಬಂದಾಗ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಬಂದಿದೆ ಅಂತ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. Therefore Kc is greater than 10 power 3 ಅಂದರೆ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ಪ್ರಾಡಕ್ಟ್ಸ್ ಪ್ರಿಡಾಮಿನೇಟ್, ಅವು ಜಾಸ್ತಿ ಅದಾವೆ, ಪ್ರಿಡಾಮಿನೇಟ್ ಓವರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟನ್ಸ್ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಇದರಲ್ಲಿ ಇನ್ನೊಂದು ಪಾಯಿಂಟ್, ಇದರ ಮೇಲೇ ಕೆಲವು ಸತ ಕ್ವೆಶ್ಚನ್ ಯಾವ ಥರ ಕೊಡ್ತಿರ್ತಾರೆ, ದೇ ಗಿವ್ ಯು ಡಿಫ್ರೆಂಟ್ ಟೈಪ್ಸ್ ಆಫ್ ರಿಯಾಕ್ಷನ್ಸ್ and they ask you to calculate, ask you to predict which of the reactions might go to completion at the earliest ಅಂತ ಕೇಳ್ತಾರೆ. So for example, ನಾನು ಇಲ್ಲಿ ಕ್ವೆಶ್ಚನ್ ಅನ್ನು ಬರೀತಾ ಇದ್ದೀನಿ. We have a few equations like A plus B gives rise to C plus D is one equation. The second equation is a plus 2b gives rise to c plus d. The third equation is a plus b gives rise to 2c plus d, and the fourth equation is a plus b gives rise to c plus 2d ಅನ್ನೋ ಈ ತರಹ 4 ಈಕ್ವೇಷನ್ಸ್ ಅದಾವೆ. ಈ ಈಕ್ವೇಷನ್ಸ್ ನಲ್ಲಿ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ A is 1 molar, concentration of B is 1 molar, concentration of C is 1 molar, and also D is 1 molar at equilibrium. Equilibrium ಬಂದಾಗ ಇವೆಲ್ಲ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ ಆವಾಗ ಈ 4 ರಿಯಾಕ್ಷನ್ಸ್ ನಲ್ಲಿ ಯಾವುದು ಆರ್ಡರ್ ಆಫ್ ಕಂಪ್ಲೀಷನ್ ಬರೀರಿ ಅಂತ ಕೇಳಬಹುದು ನಮಗೆ. ಆರ್ಡರ್ ಆಫ್ ಕಂಪ್ಲೀಷನ್ ಅಂದರೆ ಯಾವುದು ಬೇಗ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಯಾವುದು ಬೇಗ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ? ಕೆ ವ್ಯಾಲ್ಯೂ ಎದರಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ ಅದು ಬೇಗ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಕೆ ವ್ಯಾಲ್ಯೂ ಎದರಲ್ಲಿ ಜಾಸ್ತಿ ಇದೆ ಅನ್ನೋದು ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. therefore k equals 1 into 1 by 1 into 1. ಸೊ ಕೆ ವ್ಯಾಲ್ಯೂ 1 ಇದೆ ಇದರಲ್ಲಿ. ಎರಡನೇದರಲ್ಲಿ k equals 1 into 1 divided by 1 into 1, ಅದು ಕೂಡ ಈ ಥರ 1 ಆಗುತ್ತೆ. therefore ನಾನು I'll just change the data a bit. C equals 3 molar ಮಾಡ್ತೀನಿ. then if you observe this data we will get the variation. K equals C is 3 into 1 divided by 1 into 2 ಅಂದರೆ 3 by 2 1.5 ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ K ವ್ಯಾಲ್ಯೂ. ಎರಡನೇದರಲ್ಲಿ K ವ್ಯಾಲ್ಯೂ ನಾನು ತಗೊಂಡಿದ್ದಾಗ C plus D ತಗೊಂಡಿದ್ದಾಗ 3 into 1 divided by 1 into 4 2 ಸ್ಕ್ವೇರ್ ಅಲ್ವಾ, ಇದು B ಸ್ಕ್ವೇರ್ ತಗೋಬೇಕು. 3 by 4 ಅಂದರೆ 0.75 ಬರುತ್ತೆ. ಎರಡನೇದು K ಈಕ್ವಲ್ಸ್ ನೆಕ್ಸ್ಟ್ 2C ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂದರೆ 2C ಅಂದರೆ 3 ಸ್ಕ್ವೇರ್ ತಗೋಬೇಕು. 9 into 1 divided by 9 into 1 divided by 1 into 2 ಅಂದರೆ 9 by 2 is 4.5. ನೆಕ್ಸ್ಟ್ ಒನ್ ಬಂದ್ಬಿಟ್ಟು K ಈಕ್ವಲ್ಸ್ C into D square. C is 3, D square is 1 divided by 1 into 2 ಅಂದರೆ ಇದು 1 into 2 ತಗೋಬೇಕು. that means which is again 1.5. ಸೊ ಈ ಡೇಟಾವನ್ನು ನಾವು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಆರ್ಡರ್ ಆಫ್ ಕಂಪ್ಲೀಷನ್ ಅನ್ನು ಬರೆದಿದ್ದಾರೆ. ಹೈಯೆಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕೆ ಇದ್ದಿದ್ದು ಥರ್ಡ್ನಲ್ಲಿ. ಸೊ 3 ಫಸ್ಟ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಸೊ ಬೇಗ ಕಂಪ್ಲೀಟ್ ಆಗಲಿಕ್ಕೆ ಅವಕಾಶ ಯಾವುದಕ್ಕಿದೆ ಅಂತಂದರೆ 3ಗಿದೆ. ನೆಕ್ಸ್ಟ್ ಹೈಯೆಸ್ಟ್ ಡೇಟಾ 1 and 4ಗಿದೆ. 1 and 4 ಈಕ್ವಲ್ ಟೈಮ್ನಲ್ಲಿ ಕಂಪ್ಲೀಟ್ ಆಗಲಿಕ್ಕೆ ಅವಕಾಶ ಇದೆ. ಆ್ಯಂಡ್ ದೆನ್ ವಿ ಹ್ಯಾವ್ ದ ಲೀಸ್ಟ್ ವ್ಯಾಲ್ಯೂ ದಟ್ ಈಸ್ 2. ಈ ತರಹ ಪ್ರೆಡಿಕ್ಷನ್ ಡೈರೆಕ್ಷನ್ ಎಷ್ಟುವರೆಗೂ ರಿಯಾಕ್ಷನ್ ಅನ್ನೋದು ಎಲ್ಲಿವರೆಗೂ ಕಂಪ್ಲೀಟ್ ಆಗಿದೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ಕೆ ಯೂಸ್ ಮಾಡಿ ತಿಳ್ಕೋಬೋದು. ದಟ್ ಈಸ್ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಹಿಯರ್. ಲೆಟ್ಸ್ ಪ್ರೊಸೀಡ್ ಟು ದ ನೆಕ್ಸ್ಟ್ ಒನ್. The third important thing is this particular value of K is used for calculating equilibrium concentrations. The third application is to calculate equilibrium concentrations. ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು ಇದನ್ನು ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಇನ್ನೆರಡು ಕಂಡೀಷನ್ಸ್ ಹೇಳಬೇಕು ನಾನು ಪ್ರೆಡಿಕ್ಷನ್ ಆಫ್ ಡೈರೆಕ್ಷನ್ನಲ್ಲಿ. ರಿಮೆಂಬರ್ 10 to the power k, if k value is greater than 10 to the power 3, then what we need to understand is products predominate over reactants. Products predominate over reactants. If Kc is less than 10 to the power minus 3, then reactants predominate over products concentration. And if the value of K lies in between 10 to the power minus 3 and 10 power 3, then we need to understand that products and reactants concentrations are appreciable. ಅಂದರೆ ಯಾವುದು ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡೋ ತರಹ ಇಲ್ಲ, ಎಲ್ಲ ಕೂಡ ಕನ್ಸಿಡರಬಲ್ ಅದಾವೆ. ಅಪ್ರಿಷಿಯಬಲ್ ಅಂದರೆ ಇಲ್ಲಿ ಕನ್ಸಿಡರಬಲ್ ಅಂತ ಅರ್ಥ. ಈ ಕಂಡೀಷನ್ಸನ್ನು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಈಗ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಯೂಸ್ ಮಾಡಿ ಅಂದರೆ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಕಾನ್ಸಂಟ್ರೇಷನ್ಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಕೆ ವ್ಯಾಲ್ಯೂ ನಾವು ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತೀವಿ. ಸೊ ಹೌ ಡು ವಿ ಡೂ ದ್ಯಾಟ್ ಅನ್ನೋದು ನೋಡೋಣ. ಅದರಿಗೋಸ್ಕರ ವಿ ಹ್ಯಾವ್ ಸರ್ಟನ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಬೇಸ್ಡ್ ಆನ್ ದಿಸ್ ಇನ್ ದಿ ಅಸೈನ್ಮೆಂಟ್ that I provided you yesterday. We will solve questions from there. So we have this question ಫಸ್ಟ್ ಕ್ವೆಶ್ಚನ್ ನಾನು ಗಿಬ್ಸ್ ಫ್ರೀ ಎನರ್ಜಿ ಕಂಡೀಷನ್ ಕೂಡ ಹೇಳಿದ ಮೇಲೆ ಹೇಳ್ತೀನಿ. ಸೊ ವಿಲ್ ಡಿಸ್ಕಸ್ ದ್ಯಾಟ್ ದೆನ್, ಆ್ಯಂಡ್ ಅಂಟಿಲ್ ದೆನ್ ವಿ ನೀಡ್ ಟು ಸಾಲ್ವ್ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 3. ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಲೆವೆಲ್ ಕ್ವೆಶ್ಚನ್ಸ್ ಅದಾವೆ ಇಲ್ಲಿ, ಬಟ್ ಸ್ಟಿಲ್ ವಿಲ್ ಟ್ರೈ ಟು ಸಾಲ್ವ್ ದ ಕ್ವೆಶ್ಚನ್ಸ್ ಹಿಯರ್. Question number 3 in the assignment that I provided yesterday, we have ammonium hydrogen sulfide. It is a solid actually. Information kodbeku. Ammonium hydrogen sulfide is a solid introduced in 3-liter evacuated flask at 327 degrees Celsius. 30% of the solid ammonium hydrogen sulfide decomposed to ammonia and H2S gases. The Kp for the reaction has to be calculated. ನಮಗೆ Kp ಯಾವಾಗ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಂದ್ರು the sequence is first moles ತಗೋಬೇಕು, moles ಅನಂತರ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಆಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ತಗೋಬೇಕು, ಟೋಟಲ್ ಪ್ರೆಷರ್ ಆಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ತಗೊಂಡು ಆ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಆಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮನ್ನು ಅದರಿಂದ ನಾವು Kp ಅನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ದೇರ್ಫೋರ್ ಅಮೋನಿಯಂ ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೈಡ್ ಗಿವ್ಸ್ ರೈಸ್ ಟು ಅಮೋನಿಯಾ ಗ್ಯಾಸ್ ಇಂಟು H2S ಗ್ಯಾಸ್. ಈ ಎರಡು ಕೂಡ ನಮಗೆ ಬಂದಿದ್ದಾವೆ, ಈ ಎರಡು ಗ್ಯಾಸಸ್ ಈ ರಿಯಾಕ್ಷನ್ನಲ್ಲಿ. ಸೊ ಫಸ್ಟ್ ಮೋಲ್ಸ್ ತಗೊಂಡು ಆಮೇಲೆ ನಾನು ಅದನ್ನು ಎಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗಿದೆ ನೋಡಿ, ಎಷ್ಟು ಉಳಿದಿದೆ ನೋಡಿ, ಅದರಿಂದ ನಾನು ಪಾರ್ಷಲ್ ಪ್ರೆಷರ್ಸನ್ನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಆವಾಗ Kp ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಬೋದು. ಆದರೆ ಇಲ್ಲಿ ಟೋಟಲ್ ಪ್ರೆಷರ್ ಆಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅವರು ಕೊಟ್ಟಿಲ್ಲ. ಟೋಟಲ್ ಪ್ರೆಷರ್ ಆಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಕೊಟ್ಟಿಲ್ಲಲ್ವಾ, ಅದಕ್ಕೆ ನಾನು ಫಸ್ಟೇ ಅದರಲ್ಲಿ ವಾಲ್ಯೂಮ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ PV ಈಕ್ವಲ್ಸ್ NRT ಅಪ್ಲೈ ಮಾಡಿ ಪ್ರೆಷರನ್ನು ಡೈರೆಕ್ಟ್ಲಿ ಮೊದಲೇ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ನಮಗೆ ಸ್ವಲ್ಪ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅನ್ನೋದು ಈಸಿ ಆಗುತ್ತೆ. ದೇರ್ಫೋರ್ PV ಈಕ್ವಲ್ಸ್ NRT ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. PV ಈಕ್ವಲ್ಸ್ NRT ಅಪ್ಲೈ ಮಾಡ್ತಾ ಪ್ರೆಷರ್ ಅನ್ನೋದು ಎಷ್ಟಿದೆ ಅನ್ನೋದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಅದರಿಗೋಸ್ಕರ NRT/V ಹಾಕ್ತಾ ಇದ್ದೇನೆ. ಇದರಲ್ಲಿ ಹಾಕಲಿಕ್ಕೆ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಬೇಕು ನಮಗೆ. ಈ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ಆಫ್ ದ ಸಬ್ಸ್ಟೆನ್ಸ್ ಅಮೋನಿಯಂ ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೈಡ್ ಎಷ್ಟು ಮೋಲ್ಸ್ ಬರುತ್ತೆ ಅಂತ ಗೊತ್ತಾಗಬೇಕು ಅಂತಂದರೆ ನಮಗೆ ಫಸ್ಟ್ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದ್ದು ಅದರ ಮೋಲಾರ್ ಮಾಸ್. Molar mass of nitrogen is 14 and that of this is 5 and that of that is 32, which means it is 51. ಇದು 51 ಬರ್ತಾ ಇದೆ. So number of moles equals 5.1 by 51, which is 0.1. 0.1 into 0.082 into temperature. ಎಷ್ಟು ಟೆಂಪರೇಚರ್ ಕೊಟ್ಟಿದ್ದಾರೆ ಅವರು? ಟೆಂಪರೇಚರ್ ವ್ಯಾಲ್ಯೂ ಬಂದ್ಬಿಟ್ಟು 327. 327 into 273, I mean 327 plus 273 ಎಷ್ಟಾಗತ್ತೆ? 600 ಕೆಲ್ವಿನ್ ಬರುತ್ತೆ. ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಫ್ಲಾಸ್ಕ್ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 3 ಲೀಟರ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ಇದು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. ಸೊ ಇಫ್ ವಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ದ್ಯಾಟ್ 0.1, let us make it 82 into 10 to the power minus 4 into 600, or 6 into 10 to the power 2 divided by 3, which is double of 82. Double of 82 andre 164. 164 is what we get here. 3 in 6 for 2 times. ಅಂದರೆ 1.64 ಮೋಲ್ಸ್ ಬರ್ತಾ ಇದೆ ಇದರಲ್ಲಿ. 1.64 moles is what we get. So ಇದು what we get is 51 ಇದರಲ್ಲಿ. So 5.1 by 51 is 0.5. ಆ 0.1 ಅದು ಹಾಕಿದ್ದೀನಿ. R ವ್ಯಾಲ್ಯೂ 0.082 ಹಾಕಿದ್ದೀನಿ. ಇಂಟು 600 ಹಾಕಿದ್ದೀನಿ. 600 is 327 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಪ್ಲಸ್ 273. ಆ ಸಮ್ ಏನಿದೆ ಅದು 600 ಆಗುತ್ತೆ. ಡಿವೈಡೆಡ್ ಬೈ ವಾಲ್ಯೂಮ್ ಆಫ್ ದ ಫ್ಲಾಸ್ಕ್ ಈಸ್ 3 in liters. Therefore 3 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದ್ದೀನಿ. 3 in 6 is for 2 times. Then 82 into 2 is 1.64. ಈ 1.64 ಮೋಲ್ಸ್ ತಗೊಂಡಿದ್ದಾಗ ಈ 1.64 ಮೋಲ್ಸ್ನಲ್ಲಿ ಎಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗ್ತಾ ಇದೆ ಅನ್ನೋ ವಿಷಯವನ್ನು ಅವರು ಕೊಟ್ಟಿದ್ದಾಗ 30% ಆಫ್ ದ ಸಾಲಿಡ್ ಡಿಕಂಪೋಸಸ್. 30% ಆಫ್ 1.64 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಎಷ್ಟಾಗತ್ತೆ ಅಂತ ನಾವು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. 30% into of 1.64, which is 1.64 into 0.3, it is 0.492. So the taken amount is 1.64, reacted is 0.492, taken is this, reacted is this, remaining calculate ಮಾಡಿ 1.64 minus 0.492 ದಲ್ಲಿ ಇಷ್ಟು ಉಳಿದಿರುತ್ತೆ. ಈ 1.64 ಏನಿದೆ ಇಷ್ಟು number of moles. Okay, just give me a second. We have to, because this is a solid, it cannot exert pressure. I need to take 0.1 mole first. ಇದು 0.1 mole ಇದೆ and ಅದರಲ್ಲಿ 0.03 ರಿಯಾಕ್ಟ್ ಆಗಿದೆ. reacted is 0.03, remaining is 0.07. 0.1 ತಗೊಂಡಿದ್ವಿ, 30% 0.03 ರಿಯಾಕ್ಟ್ ಆಗಿದೆ, 0.07 ಉಳಿದಿದೆ. ಅನಂತರ ಇಲ್ಲಿ ಬಂದಿದ್ದು 0.03 ಮತ್ತು H2S ಗ್ಯಾಸ್ ಕೂಡ 0.03 ಬರುತ್ತೆ. ಅಂದರೆ ಈ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ ತಗೊಂಡು ನಾನು ಟೋಟಲ್ ಪ್ರೆಷರ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀನಿ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ ದಿಸ್. ಸೊ ಇವಾಗ ನಾನು ಪ್ರೆಷರ್ 0.06 ಮಾತ್ರ ತಗೋಬೇಕು. ಟೋಟಲ್ ಮೋಲ್ಸ್ ನಾನು 0.06 ಮಾತ್ರ ತಗೋಬೇಕು. ಯಾಕೆ ಆ ಥರ ತಗೋಬೇಕು ಅಂತಂದರೆ ಇದು ಗ್ಯಾಸ್ ಅಲ್ಲ. So that's a mistake here. So P equals 0.06 into 0.082 into 600 divided by volume of the vessel. When we consider the volume of the vessel 3 ide, this is what we need to take here. Then when we consider all of this, idanna 82 into 10 to the power minus 3 into 6 into 10 to the power minus 2 into 6 into 10 to the power 2 divided by 3. This is this and this gets cancelled. Idu idralli 2 times 2 6 are 12. 82 into 12 ಮಾಡೋಣ. That is 984 into 10 to the power minus 1 is what I get, which means 82 into 12 is what we get. So that is 0.984. 0.984 ಬರ್ತಾ ಇದೆ. ಇದರಲ್ಲಿ 0.984 ಟೋಟಲ್ ಪ್ರೆಷರ್ ಯಾರ್ಯಾರದು? ಅಮೋನಿಯಾದು, ಹೈಡ್ರೋಜನ್ ಸಲ್ಫೈಡ್ದು. ಇದು ಎಷ್ಟು ಮೋಲ್ಸ್ ಇದೆ? ಹಾಫ್ ಇದೆ. ಅದೆಷ್ಟು ಮೋಲ್ಸ್ ಇದೆ? ಹಾಫ್ ಇದೆ. ಅಂದರೆ ಟೋಟಲ್ 0.984ನಲ್ಲಿ ಇದು ಹಾಫ್, ಅದು ಹಾಫ್ ಅದಾವೆ. ಅಂದರೆ ಅದನ್ನು ಹಾಫ್ ಮಾಡಿಕೊಂಡ್ರೆ 0.492 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಇದು, 0.492 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಇದು ಬರುತ್ತೆ. ಇದನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು KP ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಈ ಪ್ರೆಷರ್ಸ್ ಹಾಕಿ ದೆನ್ ವಿಲ್ ಗೆಟ್ ದ ಫೈನಲ್ ಆನ್ಸರ್. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಹೌ ವಿ ಸಾಲ್ವ್ ದಿಸ್ ಕ್ವೆಶ್ಚನ್ ಫಾರ್ ಕ್ಯಾಲ್ಕುಲೇಟಿಂಗ್ KP. ದೆನ್ ವಿ ವಿಲ್ ಗೋ ಟು another question after this. The next question that we are trying to understand is question number 6. Okay, question number 6 alla, question number 7. So question number 7 nalli what we have is CO2 gas is taken with a pressure of 0.05 atmospheres. and then it is mixed with carbon. 0.05 atmospheres ತಗೊಂಡು some of carbon dioxide is converted into CO on addition of graphite ಕೊಟ್ಟಿದ್ದಾರೆ. ಗ್ರಾಫೈಟ್ ಅಂದರೆ ಕಾರ್ಬನ್, ಕಾರ್ಬನನ್ನು CO2ಗೆ ಆ್ಯಡ್ ಮಾಡಿದರೆ ನಮಗೆ 2 moles of CO ಬರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ದಿ ಇಕ್ವೇಷನ್. ಇದರಲ್ಲಿ ಏನು ಮಾಡಬೇಕು ಅಂದರೆ ಇಟ್ಸ್ ಇಸ್ ಅ ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್, ಸೊ ಐ ಆಮ್ ಯೂಸಿಂಗ್ ಅ ರಿವರ್ಸಿಬಲ್ ಆರೋ. ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ ತಗೊಂಡಿದ್ದು 0.05, ಕಾರ್ಬನ್ ಹಾಕಿರುವುದರಿಂದ ಕಾರ್ಬನ್ರಿಂದ ಏನು ಪ್ರೆಷರ್ ಬರಲ್ಲ, ಸೊ CO2ದೇ ಇನಿಷಿಯಲ್ ಪ್ರೆಷರ್ ತಗೋಬೇಕು. And some of carbon dioxide is converted into CO on addition of graphite. If the total pressure at equilibrium is 0.8, then Kp is how much ಅಂತ ಕೇಳ್ತಿದ್ದಾರೆ. ಸೊ ಇದನ್ನು ಕೂಡ ಸಾಲ್ವ್ ಮಾಡಲಿಕ್ಕೆ ನಾವು 0.05 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಇದನ್ನು ತಗೊಂಡಿದ್ವಿ, 2 moles of CO ಬಂದಿದೆ, ಅಂದರೆ ಇದರಲ್ಲಿ X ರಿಯಾಕ್ಟ್ ಆಗಿದೆ ಅಂತ ಅಂದ್ಕೊಳ್ಳೋಣ. X ರಿಯಾಕ್ಟ್ ಆಗಿದರೆ 0.05 ಮೈನಸ್ X ಉಳಿದಿರುತ್ತೆ. ಆಮೇಲೆ ಇಲ್ಲಿ 1 mole ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದಾಗ ಇಲ್ಲಿ 2 moles ಬರ್ತಾ ಇದೆ, ಅಂದರೆ X moles ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದಾಗ 2 moles ಬರುತ್ತೆ, ಅಂದರೆ 2X moles ಬರುತ್ತೆ. ದೇರ್ಫೋರ್ ಟೋಟಲ್ ಪ್ರೆಷರ್ 0.05 ಮೈನಸ್ X ಪ್ಲಸ್ 2X ಹಾಕಿದರೆ ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು, ಅಲ್ಲಿ ಡೇಟಾದಲ್ಲಿ ಒಂದು ಮಿಸ್ಟೇಕ್ ಇದೆ, 0.05 ಅಲ್ಲ, ಅದು 0.5 ತಗೊಳ್ಳಿ, 0.5 ಮೈನಸ್ ಎಕ್ಸ್ ತಗೊಳ್ಳಿ. ಸೊ ಇದು ಕೂಡ 0.5 ಮೈನಸ್ ಎಕ್ಸ್ ಮಾಡಿ ಅದನ್ನು, ದೇರ್ ಫಾರ್ ಪ್ಲಸ್ 2X ಬರುತ್ತೆ, ವಿಚ್ ಈಸ್ ಈಕ್ವಲ್ ಟು 0.8 atmospheres which is given there. Therefore total pressure at equilibrium is 0.8 atmospheres. 0.5 plus X is equal to 0.8 ಬಂದಿದೆ, X is equal to 0.8 minus 0.5 ಬರುತ್ತೆ, X is equal to 0.3 atmospheres ಬರುತ್ತೆ. ಅಂದರೆ ಎಷ್ಟು ರಿಯಾಕ್ಟ್ ಆಗಿದೆ ಅನ್ನೋದು ನಮಗೆ ಆಲ್ರೆಡಿ ಬಂದಿದೆ. ತಗೊಂಡಿದ್ದು 0.5, ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದು 0.3, ಉಳಿದಿರೋದು 0.5 minus 3 which is 0.2, and then what we have here is 2X. ಅಂದರೆ X ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದಾಗ 2X ಬರ್ತಾ ಇದೆ, ಅಂದರೆ 0.3 ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದಕ್ಕೆ 0.6 ಬರುತ್ತೆ. ಸೊ ಡಬಲ್ ಆಫ್ ದ್ಯಾಟ್. ಈಗ ನಾವು ಮಾಡಬೇಕಾಗಿದ್ದೇನು, ಅದರಲ್ಲಿ Kp ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. Kp ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಲಿಕ್ಕೆ ಈಕ್ವೇಷನ್ ಏನು, ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು CO ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು CO2 ಹಾಕಬೇಕು. ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು CO ಸ್ಕ್ವೇರ್ ಅಂದರೆ 0.6 ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಡಿವೈಡೆಡ್ ಬೈ ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು CO2 ಅಂದರೆ 0.2 ಹಾಕಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ವಾಟ್ ವಿ ಗೆಟ್ ಇನ್ ದಿಸ್. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, CO2 ಪ್ಲಸ್ C ಗಿವ್ಸ್ ರೈಸ್ ಟು 2CO ಇದೆ, ಅದರಲ್ಲಿ 0.5 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ತಗೊಂಡಿದ್ದಾರೆ, ಅಂದರೆ 0.05 ಮಿಸ್ಟೇಕ್ ಆಗಿದೆ, 0.5 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಅದು. ಈ 0.5 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ನಲ್ಲಿ X ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ರಿಯಾಕ್ಟ್ ಆಗಿದೆ ಅಂತ ಅಂದ್ಕೊಂಡ್ರೆ ನಮಗೆ ಉಳಿದಿರೋದು 0.5 ಮೈನಸ್ ಎಕ್ಸ್. ಪ್ರತಿ 1 ಅಟ್ಮಾಸ್ಫಿಯರ್ ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದಾಗ ಅದಕ್ಕೆ ಡಬಲ್ CO ಬರ್ತಾ ಇದೆ, ಅಂದರೆ 2X ಅಷ್ಟು ಬರುತ್ತೆ. ಈ ತರಹ ಬಂದಿದ ಮೇಲೆ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದೇನು, 0.5 ಮೈನಸ್ ಎಕ್ಸ್ 0.5 ತಗೊಂಡಿದ್ವಿ, ಎಕ್ಸ್ ರಿಯಾಕ್ಟ್ ಆಗಿದೆ, 0.5 ಮೈನಸ್ ಎಕ್ಸ್ ಬಂದಿದೆ, ಆಮೇಲೆ ಎಕ್ಸ್ಗೆ 2X ಬರ್ತಾ ಇದೆ, ಅದಕ್ಕೆ ಇದೆಲ್ಲ ಬರ್ದಿದ್ವಿ. ಈಗ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದ್ದು ಟೋಟಲ್ ಪ್ರೆಷರ್ ಅಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅವ್ರು ಕೊಟ್ಟಿದ್ದು ಸಮ್ ಆಫ್ ದೀಸ್ ಟು ಆಗತ್ತೆ, ಅದು 0.8ಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ. ದೇರ್ ಫಾರ್ 0.5 ಪ್ಲಸ್ ಎಕ್ಸ್ ಈಕ್ವಲ್ 0.8 ಆದರೆ ಎಕ್ಸಿನ ವ್ಯಾಲ್ಯೂ 0.3 ಬರುತ್ತೆ. ಅಂದರೆ ತಗೊಂಡಿದ್ದು 0.5, ರಿಯಾಕ್ಟ್ ಆಗಿದ್ದು 0.3, ಉಳಿದಿದ್ದು 0.2 ಬರುತ್ತೆ. ಈಗ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಏನು, 1ಗೆ 2 ಬರ್ತಾ ಇದೆ, ಅಂದರೆ ಎಕ್ಸ್ಗೆ 2X ಬರ್ತಾ ಇದೆ, ಅಂದರೆ 0.3ಗೆ 0.6 ಬರುತ್ತೆ. ದೇರ್ ಫಾರ್ ಪಾರ್ಷಿಯಲ್ ಪ್ರೆಷರ್ ಡ್ಯೂ ಟು CO at equilibrium is 0.6 whole square divided by pressure due to CO2 is 0.2. ಅದರಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ ನಮಗೆ ಫೈನಲ್ ಆನ್ಸರ್ 0.36 ಡಿವೈಡೆಡ್ ಬೈ 0.2 ಬರುತ್ತೆ, ಅಂದರೆ 1.8 ಅಟ್ಮಾಸ್ಫಿಯರ್ಸ್ ಬರುತ್ತೆ. ಈಗ ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾರ್ಟಿಗೆ ಹೋಗೋಣ. ವಾಟ್ ವಿ ಆರ್ ಟ್ರೈಂಗ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ನೆಕ್ಸ್ಟ್ ಆಫ್ಟರ್ ದಿಸ್ ಈಸ್ We are talking about the next important part, which is delta G and K relation. Relation between delta G and K ಅನ್ನು ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ಡೆಲ್ಟಾ ಜಿ ಆ್ಯಂಡ್ ಕೆಗೆ ಯಾವ ತರಹದ ರಿಲೇಷನ್ ಇರುತ್ತೆ? ಡೆಲ್ಟಾ ಜಿ ಈಕ್ವಲ್ಸ್ ಆ್ಯಕ್ಚುಲಿ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಕ್ವಲ್ಸ್ -2.303 ಆರ್ ಟಿ ಲಾಗ್ ಕೆ ಅನ್ನುವ ಈಕ್ವೇಷನನ್ನು ನಾವು ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. ಬೇಸಿಕಲ್ಲಿ ಇದು ಎಲ್ಲಿಂದ ಬಂದಿದೆ ಅಂತಂದರೆ ಡೆಲ್ಟಾ ಜಿ ಈಕ್ವಲ್ಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಪ್ಲಸ್ ಆರ್ ಟಿ ಎಲ್ ಎನ್ ಕೆ ಎಲ್ ಎನ್ ಕ್ಯೂ ಅನ್ನುವ ಈಕ್ವೇಷನ್ದಿಂದ ಬಂದಿದೆ. ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಹತ್ತಿರ ನಮಗೆ ಕ್ಯೂ ಅನ್ನೋದು ಕೆಗೆ ಈಕ್ವಲ್ ಆಗುತ್ತೆ, ಡೆಲ್ಟಾ ಜಿ ಅನ್ನೋದು 0 ಆಗುತ್ತೆ. ಈ ಕಂಡೀಷನ್ಸನ್ನು ನಾನು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದರೆ 0 ಈಕ್ವಲ್ಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಪ್ಲಸ್ ಆರ್ ಟಿ ಎಲ್ ಎನ್ ಕೆ ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಮಾಡಿದರೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ ಆರ್ ಟಿ ಎಲ್ ಎನ್ ಕೆ ಆಗುತ್ತೆ. ಎಲ್ ಎನ್ ಬದಲು ನಾನು ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ ಆರ್ ಟಿ ಎಲ್ ಎನ್ ಬದಲು 2.303 ಲಾಗ್ ಕೆ ಅಂತ ಬರೆದ್ರೆ ನನಗೆ ಈ ಈಕ್ವೇಷನ್ ಬರ್ತಾ ಇದೆ. ಈ ಈಕ್ವೇಷನನ್ನು ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ಲಿ ವೇರಿಯಸ್ ಫಾರ್ಮ್ಸ್ನಲ್ಲಿ ಬರೆಯಬಹುದು. ಅವು ಯಾವುದು ಅನ್ನೋದು ನೋಡೋಣ ಇಲ್ಲಿ. When we consider delta G naught equals minus 2.303 RT log K, ಇದರಲ್ಲಿ delta G naught divided by 2.303 RT minus which equals log K ಅಂತ ಬರೀತಾ ಇದ್ದೀನಿ. ಇದಕ್ಕೆ ಆಂಟಿ ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿದರೆ 10 to the power minus delta G naught divided by 2.303 RT equals K ಅಂತ ಬರುತ್ತೆ. ಇದೇ ಈಕ್ವೇಷನ್ ಅನ್ನು ನಾನು ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ ಆರ್ ಟಿ ಎಲ್ ಎನ್ ಕೆ ಅಂತ ಕೂಡ ಬರೆಯಬಹುದು. ಬರೆದಿದ್ದಾಗ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಬೈ ಆರ್ ಟಿ ಈಕ್ವಲ್ಸ್ ಎಲ್ ಎನ್ ಕೆ ಅನ್ನೋ ಈಕ್ವೇಷನ್ ಬರ್ತಾ ಇದೆ. ಇದಕ್ಕೂ ಕೂಡ ಆಂಟಿ ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿದರೆ ಇ ಪವರ್ ಮೈನಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್ ಟಿ ಈಕ್ವಲ್ಸ್ ಕೆ ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಈ ಥರ ಬರುತ್ತೆ ನಮಗೆ, ಅಂದರೆ ಎಲ್ ಎನ್ ಕೆ ಬದಲು ಕೆ ಬರ್ತಾ ಇದೆ. ಈ ಈಕ್ವೇಷನ್ಸನ್ನು ನಾವು ಅಬ್ಸರ್ವ್ ಮಾಡಿದಾಗ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಸ್ ಇಫ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 0, ಯಾವುದಾದ್ರೂ ರಿಯಾಕ್ಷನ್ಗೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಲೆಸ್ ದ್ಯಾನ್ 0 ಅಂದರೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಸ್ ನೆಗೆಟಿವ್, ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಸ್ ಲೆಸ್ ದ್ಯಾನ್ 0, ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಸ್ ನೆಗೆಟಿವ್ ಅಂತ ಅಂದ್ಕೊಂಡ್ರೆ ರಿಯಾಕ್ಷನ್ ಬಿಕಮ್ಸ್ ಸ್ಪಾಂಟೇನಿಯಸ್. ರಿಯಾಕ್ಷನ್ ಸ್ಪಾಂಟೇನಿಯಸ್ ಆಗಿದ್ದಾಗ ಇಲ್ಲಿ ನಾನು ಮೈನಸ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕಾಗತ್ತೆ. ಇ ಪವರ್ ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಡಿವೈಡೆಡ್ ಬೈ ಆರ್ ಟಿ ಈಕ್ವಲ್ಸ್ ಕೆ. ಇ ಪವರ್ ಮೈನಸ್ ಆಫ್ ಮೈನಸ್ ಎಷ್ಟಾಗತ್ತೆ? ಪ್ಲಸ್ ಆಗತ್ತೆ, ಅಂದರೆ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್. ಇ ಪವರ್ ಪಾಸಿಟಿವ್ ಬರ್ತಾ ಇದೆ. ಇ ಪವರ್ ಪಾಸಿಟಿವ್ ಅಂತಂದರೆ ಇ ಪವರ್ 0 ಆದರೆ 1, ಇ ಪವರ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ಆದರೆ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1, ಇ ಪವರ್ ಲೆಸ್ ದ್ಯಾನ್ 0 ಆದರೆ ಲೆಸ್ ದ್ಯಾನ್ 1 ಬರುತ್ತೆ. ಪ್ಲಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಬೈ ಆರ್ ಟಿ ಅಂದರೆ ಇ ಪವರ್ ಇಸ್ ಪಾಸಿಟಿವ್, ಪಾಸಿಟಿವ್ ಅಂದರೆ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ಅಂದರೆ ಕೆ ವ್ಯಾಲ್ಯೂ ಬಿಕಮ್ಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 1. ಹಾಗೆ ಇಫ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ 0 ವಿಚ್ ಮೀನ್ಸ್ ದ ರಿಯಾಕ್ಷನ್ ಈಸ್ non-spontaneous. If the reaction is non-spontaneous, then what we need to understand here is e to the power minus delta G naught by RT equals K. e power ಇದು ಪಾಸಿಟಿವ್ ಆಗಿದೆ, ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಬೈ ಆರ್ ಟಿ ಈಕ್ವಲ್ಸ್ ಕೆ ಆಗಿದೆ. ಆವಾಗ e to the power minus into plus is minus, therefore minus delta G naught by RT equals K ಆಗಿದೆ. which means e power ನೆಗೆಟಿವ್ ಆಗಿದೆ ಅಂದರೆ e power less than 0 ಆಗಿದೆ ಅಂದರೆ K becomes less than 1. ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕಾಗಿದ್ದು, ಇಫ್ ದ ರಿಯಾಕ್ಷನ್ ಈಸ್ ಅಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಂಡರ್ ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಕಂಡೀಷನ್ಸ್, at equilibrium if delta G naught equals 0 ಆವಾಗ e ಪವರ್ ಮೈನಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಬೈ ಆರ್ ಟಿ ಈಕ್ವಲ್ಸ್ ಕೆ, e ಪವರ್ ಮೈನಸ್ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಆರ್ ಟಿ 0 ಆಗಿದೆ, ದೇರ್ ಫೋರ್ ಇದು 0 ಆಗುತ್ತೆ, ವಿಚ್ ಮೀನ್ಸ್ ಕೆ ಬಿಕಮ್ಸ್ 1. ಸೊ ಈ ಕಂಡೀಷನ್ಸನ್ನು ನಾವು ಅರ್ಥ ಮಾಡಿಕೊಂಡ್ರೆ ವಾಟ್ ವಿ ನೀಡ್ ಟು ಕನ್ಕ್ಲೂಡ್ ಇಸ್, for a reaction, for a spontaneous reaction, delta G naught is less than 0 under standard conditions and K is greater than 1. Whereas for a non-spontaneous reaction, delta G naught is greater than 0 and K is less than 1. Whereas for reaction which is at equilibrium, delta G naught becomes equal to 0 where K equals 1. ಇವು ಇಷ್ಟು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು ಈ ಕಂಡೀಷನ್ಸ್. ಈ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಕೆ ಕಂಡೀಷನನ್ನು ಇನ್ಕ್ಲೂಡ್ ಮಾಡ್ತಾ ವಿ ಹ್ಯಾವ್ ಎ ಕ್ವೆಶ್ಚನ್ ಇನ್ ದಿ ಅಸೈನ್ಮೆಂಟ್ ವಿಚ್ ಈಸ್ ಕ್ವೆಶ್ಚನ್ ನಂಬರ್ 1. ಆ ಕ್ವೆಶ್ಚನನ್ನು ಸಾಲ್ವ್ ಮಾಡೋಣ. Question number 1. The standard Gibbs free energy change at 300 Kelvin for the reaction 2A gives rise to B plus C is 2494 kilojoules is what we have there. Therefore, the standard free energy change delta G naught equals 2494.2 joule, and the reaction is 2A gives rise to B plus C. ಇಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿದ್ರು ಮಾಡಿಲ್ಲ ಅಂದರೆ ಎಲ್ಲ ಗ್ಯಾಸಸ್ಸೇ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಏನು ಮೆನ್ಷನ್ ಮಾಡಿಲ್ಲ ಅಂದರೆ ಎಲ್ಲ ಗ್ಯಾಸಸ್ಸೇ ಆಗ್ತವೆ. ಅಟ್ ಎ ಗಿವೆನ್ ಟೈಮ್ ಅಂದರೆ ನಮಗೆ ಕೊಡೋದು ಕೆ ಡೇಟಾ ಅಲ್ಲ, ಕ್ಯೂಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಡೇಟಾ. Therefore, the composition of the reaction mixture is half, 2 and half again. The reaction proceeds in the direction, ಅಂದರೆ ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ಪ್ರೊಸೀಡ್ ಆಗುತ್ತೆ, ಯಾವ ಡೈರೆಕ್ಷನಲ್ಲಿ ರಿಯಾಕ್ಷನ್ ಪ್ರೊಸೀಡ್ ಆಗುತ್ತೆ ಅಂತ ಗೊತ್ತಾಗಬೇಕಂದ್ರೆ ನಮಗೆ ಬೇಕಾಗಿದ್ದು ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಅಲ್ಲ, ಆ್ಯಕ್ಚುಲಿ ನಮಗೆ ಬೇಕಾಗಿದ್ದು ಕೆ ಬೇಕಾಗಿದೆ. ಸೊ ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ರಿಂದ ಕೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಡೆಲ್ಟಾ ಜಿ ನಾಟ್ ಈಕ್ವಲ್ಸ್ -2.303 ಆರ್ ಟಿ ಲಾಗ್ ಕೆ ಅನ್ನು ತಗೋಬೇಕು. ಈ ಈಕ್ವೇಷನ್ನಲ್ಲಿ -2.303 ವ್ಯಾಲ್ಯೂ ಆಫ್ ಆರ್ ಜೂಲ್ಸ್ನಲ್ಲಿ 8.314 ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. ಟೆಂಪರೇಚರ್ ವ್ಯಾಲ್ಯೂ, ವಾಟ್ ಇಸ್ ದ ಟೆಂಪರೇಚರ್ ವ್ಯಾಲ್ಯೂ ಗಿವನ್ ದೇರ್? ಇಟ್ ಈಸ್ 300 ಕೆಲ್ವಿನ್. ಇದನ್ನು ಕೂಡ ತಗೋಬೇಕು. ಲಾಗ್ ಕೆ ಇದು 2494 ಜೂಲ್ಸ್, 0.2 ಜೂಲ್ಸ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಆ್ಯಕ್ಚುಲಿ ನಾವು ಇದನ್ನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದರೆ ಕೂಡ 2494 ಬರುತ್ತೆ. ಒಂದ್ಸಲ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ನೋಡೋಣ. 2.303 ಆರ್ ಇಂಟು ಆರ್ ವ್ಯಾಲ್ಯೂ 8.314 ಇಂಟು 300. This becomes 19.147 into 300. What we will do is, ನಾನು ಈ 2.303 ಅನ್ನು ಇಗ್ನೋರ್ ಮಾಡ್ತಾ ಲಾಗ್ ಕೆ ಬದಲು ಎಲ್ ಎನ್ ಕೆ ಬರೀತಾ ಇದ್ದೀನಿ. ಎದಕ್ಕೆ ಆ ಥರ ಬರೀತಾ ಇದ್ದೀನಿ ಅಂದರೆ, ಅಲ್ಲಿ ಡೇಟಾದಲ್ಲಿ ಇ ಕೊಟ್ಟಿದ್ದಾರೆ, ಇ ಈಸ್ 2.718, ಈ ವ್ಯಾಲ್ಯೂ 2.718 ಕೊಟ್ಟಿದ್ದಾರೆ ಅಂತಂದರೆ ನಮಗೆ ಎಲ್ ಎನ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಡೇಟಾ ತಗೊಳ್ಳಿಕ್ಕೆ ಹೇಳ್ತಿದ್ದಾರೆ. ಆ ಥರ ಎದಕ್ಕೆ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ ಅನ್ನೋದು ನಿಮಗೆ ಈಸಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ಗೋಸ್ಕರ ಅನ್ನೋದು ಇವಾಗ ಅರ್ಥ ಆಗುತ್ತೆ. ಸೊ 2.303 ಲಾಗ್ ಕೆ ಬದಲು 8.314 ಇಂಟು 300 ಎಲ್ ಎನ್ ಕೆ ಅಂತ ಬರೀತಾ ಇದ್ದಾನೆ. ಈಗ ಈ 8.314 ಅನ್ನು 300ರಿಂದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿ ನೋಡೋಣ. You get 2494.2 ಅದರಿಗೋಸ್ಕರ. ಸೊ 2494.2 ಈಕ್ವಲ್ಸ್ -2494.2 ಬಟ್ ಎಲ್ ಎನ್ ಕೆ ಅಂದರೆ ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ, ಅಂದರೆ 1 ಬರುತ್ತೆ ನಮಗೆ. ಈ 1 ಬಂದಿದ್ದಾಗ 1 ಈಕ್ವಲ್ಸ್ ಮೈನಸ್ ಎಲ್ ಎನ್ ಕೆ ಅಂದರೆ ಎಲ್ ಎನ್ 1/k ಈಕ್ವಲ್ಸ್ 1. lnಗೆ ಆಂಟಿ ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿದರೆ e ಬರುತ್ತೆ, e ಪವರ್ 1 ಈಕ್ವಲ್ಸ್ 1/k ಅಂದರೆ k ಈಕ್ವಲ್ಸ್ 1/e. 1/e ವ್ಯಾಲ್ಯೂ ಎಷ್ಟು ಕೊಟ್ಟಿದ್ದಾರೆ? 2.7 ತಗೋ ಸಾಕು k ವ್ಯಾಲ್ಯೂ. 1/2.7 k ವ್ಯಾಲ್ಯೂ ಅಂದರೆ k ವ್ಯಾಲ್ಯೂ ಎಷ್ಟಿದೆ ಅಂತ ಅಂದರೆ k ವ್ಯಾಲ್ಯೂ ಈಸ್ 2.8 or 2.7 ಅಂದ್ಕೊಂಡ್ರೆ 10 and then 2.7 it is 0.4 3 times ಬರುತ್ತೆ. 2.7 into 3 yes and then approximately 6 ಬರುತ್ತೆ. 0.36 ಬರ್ತಾ ಇದೆ ವ್ಯಾಲ್ಯೂ k ವ್ಯಾಲ್ಯೂ. ಸೊ k ವ್ಯಾಲ್ಯೂ 0.36 ಇದೆ. ಈಗ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದು ಅದರಲ್ಲಿ a ಹಾಫ್ b2 c ಹಾಫ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ಅದನ್ನು ಯೂಸ್ ಮಾಡಿ q ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡೋಣ. q ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡಿದರೆ q ಈಕ್ವಲ್ಸ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ b ಇಂಟು c ಡಿವೈಡೆಡ್ ಬೈ a ಸ್ಕ್ವೇರ್. ವಾಟ್ ಈಸ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ b? 2. ವಾಟ್ ಈಸ್ ದ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ c? ಹಾಫ್. And what is the concentration of a? Half square. 2 into half divided by half square. C value half ide, B value 2 ide, and then this value is half square. Therefore, what we get is 2 and 1/2 gets cancelled. 1/2 whole square andre namage 1/4 barutte. 1/1/4 ಅಂದರೆ 4 ಬರುತ್ತೆ. ಸೊ q ವ್ಯಾಲ್ಯೂ ಇಸ್ 4. ಈ ವ್ಯಾಲ್ಯೂ ಬಂದ್ಬಿಟ್ಟು 0.36 ಅಂದರೆ q is greater than k. q greater than k ಇದ್ದರೆ the reaction proceeds in the reverse reaction. So that is what we need to understand, which means option number 1 is correct answer. ಇನ್ನೊಂದ್ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ, just try to observe here. ನಾನಿಲ್ಲಿ 2.303 RT ಕೂಡ ತಗೊಂಡು ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡ್ಬೋದು, ಬಟ್ ನನಗೆ ಕ್ಯಾಲ್ಕ್ಯುಲೇಷನ್ ಜಾಸ್ತಿ ಆಗಿಬಿಡುತ್ತೆ. ಅಲ್ಲಿ 2494 ಕೊಡಲಿಕ್ಕೆ ಕಾರಣ ಆರ್ ಎನ್ ಟಿ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದಾಗ 2494.2 ಬರ್ತಾ ಇದೆ. ಅದರಿಗೋಸ್ಕರ ನಾನು 2.303 ಲಾಗ್ಗೆ ತೆಗೆದು LNK ಬರೆದಿದ್ದೀನಿ. ಬರೆದು 8.314 300 ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ದೀನಿ. ಮಾಡಿದ್ದಾಗ 2494.2 ಬಂದಿದೆ. ಇದು ಕ್ಯಾನ್ಸಲ್ ಆಗಿದೆ, ಆದರೆ ಮೈನಸ್ ಉಳಿದಿದೆ. ಮೈನಸ್ ಆ ಕಡೆ ಕಳಿಸಿದ್ದೀನಿ. 1/k ಬಂದಿದೆ. ln 1/k ಅಂದರೆ ಆಂಟಿ ಲಾಗ್ ಅಪ್ಲೈ ಮಾಡಿದ್ದಾಗ e ಪವರ್ 1 ಈಕ್ವಲ್ಸ್ 1/k ಬರುತ್ತೆ. ಅಂದರೆ k ಈಸ್ 1/e ಅಂದರೆ k ಈಸ್ ಅಪ್ರಾಕ್ಸಿಮೇಟ್ಲಿ 0 ಪಾಯಿಂಟ್ ಸಮಥಿಂಗ್. k ಬಂದಿದೆ, q ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ಮಾಡ್ಕೋಬೇಕು. q ಈಕ್ವಲ್ಸ್ b ಇಂಟು c ಡಿವೈಡೆಡ್ ಬೈ a ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ 2 ಇಂಟು ಹಾಫ್ ಡಿವೈಡೆಡ್ ಬೈ ಹಾಫ್ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ದೀನಿ. ಸೊ ದೇರ್ ಫಾರ್ 2 and half ಕ್ಯಾನ್ಸಲ್ ಆಗಿ 4 ಉಳಿದಿದೆ. 4 goes to the numerator ಅಂದರೆ 4 ಅಂದರೆ q is greater than k ಆಗಿದೆ. q greater than k ಆಗಿದ್ರೆ ರಿಯಾಕ್ಷನ್ ರಿವರ್ಸ್ ಡೈರೆಕ್ಷನಲ್ಲಿ ಹೋಗುತ್ತೆ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಲಾಸ್ಟ್ಲಿ ನಮಗೆ ಈ ಪಾರ್ಟ್ನಲ್ಲಿ ಲೀ ಚಾಟ್ಲಿಯರ್ಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಅದರ ಅಪ್ಲಿಕೇಶನ್ಸ್ ಉಳಿದಿದ್ದಾವೆ, ಅವು ಕ್ವಿಕ್ಲಿ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. ನಾನು ಪ್ರಿನ್ಸಿಪಲ್ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಅಪ್ಲಿಕೇಶನ್ಸನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ವೆನ್ ವಿ ಕನ್ಸಿಡರ್ effect of concentration of reactants and products on a particular equilibrium, concentration of reactants and products. Concentration of reactants and products ಅನ್ನೋವು ಯಾವ ತರಹ ರಿಯಾಕ್ಷನ್ನ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅನ್ನು ಎಫೆಕ್ಟ್ ಮಾಡ್ತವೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಒಂದು ಸಿಸ್ಟಮ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ಗೆ ಆಲ್ರೆಡಿ ಬಂದಿದೆ. a plus b gives rise to c plus d ಅನ್ನುವ ರಿಯಾಕ್ಷನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ಗೆ ಆಲ್ರೆಡಿ ಬಂದಿದೆ. ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಬಂದಾಗ q ಈಕ್ವಲ್ಸ್ k ಆಗುತ್ತೆ. ಇವಾಗ ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ನಾನು ರಿಯಾಕ್ಟೆಂಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಅಂದರೆ q ಇರಲಿ k ಇರಲಿ, ದ್ಯಾಟ್ ಬಿಕಮ್ಸ್ p ಡಿವೈಡೆಡ್ ಬೈ r. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ p ಡಿವೈಡೆಡ್ ಬೈ r ಆಗತ್ತಲ್ವಾ. ಸೊ ಇದನ್ನು ನಾವು ತಗೊಂಡಿದ್ದಾಗ ನಾನು ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಅನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಚೇಂಜ್ ಮಾಡಿದರು, ಪ್ರಾಡಕ್ಟ್ಸ್ ಚೇಂಜ್ ಮಾಡಿದರು, ಕೆಗೆ ಯಾವ ತರಹದ ಎಫೆಕ್ಟ್ ಬರಲ್ಲ. ಎಫೆಕ್ಟ್ ಬರೋದು ಕ್ಯೂ ಮೇಲೆ. ದೇರ್ ಫಾರ್ ರಿಯಾಕ್ಟೆನ್ಸ್ನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ದಕ್ಕೆ ಕ್ಯೂ ಅನ್ನೋದು ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಕ್ಯೂ ಯಾವುದಕ್ಕಿಂತ ಡಿಕ್ರೀಸ್ ಆಗುತ್ತೆ ಅಂತಂದರೆ ಕ್ಯೂ ಮೊದಲು ಕೆಗೆ ಸಮಾನ ಇತ್ತು, ಇವಾಗ ಕ್ಯೂ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಇದೆ, ಅಂದರೆ ಕ್ಯೂ ಬಿಕಮ್ಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಕೆ. ಕ್ಯೂ ಅನ್ನೋದು ಲೆಸ್ ದ್ಯಾನ್ ಕೆ ಆಗ್ತಾ ಇದ್ರೆ ನಾವೇನಂತ ತಿಳ್ಕೋಬೇಕು? ಇಫ್ ಕ್ಯೂ ಬಿಕಮ್ಸ್ ಲೆಸ್ ದ್ಯಾನ್ ಕೆ, ದಟ್ ಮೀನ್ಸ್ ದ ರಿಯಾಕ್ಷನ್ ಗೋಸ್ ಫ್ರಮ್ ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಸೈಡ್, ದ ರಿಯಾಕ್ಷನ್ ಗೋಸ್ ಫಾರ್ವರ್ಡ್ ಅನ್ನೋ ವಿಷಯವನ್ನು ತಿಳ್ಕೋಬೇಕು. Therefore, if concentration of reactants is increased, then the reaction goes from left to right side. ಅದೇ ತರಹ if concentration of reactants is decreased, ಒಂದು ವೇಳೆ ನಾನು concentration of reactants ಅನ್ನು ಡಿಕ್ರೀಸ್ ಮಾಡಿದರೆ ಆವಾಗ ಆರ್ ವ್ಯಾಲ್ಯೂ ಡಿಕ್ರೀಸ್ ಆಗಿದೆ, ಅಂದರೆ ಡಿನಾಮಿನೇಟರ್ ಡಿಕ್ರೀಸ್ ಆಗಿದೆ, ಅಂದರೆ ಕ್ಯೂ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ಕ್ಯೂ ಯಾವುದಕ್ಕಿಂತ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ? ಕೆ ಗಿಂತ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ಆವಾಗ ರಿಯಾಕ್ಷನ್ goes from right to left side. Therefore, the reaction goes from right to left side ಅನ್ನೋದು ನಾವು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್, ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅನ್ನು ನಾನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ, ಪ್ರಾಡಕ್ಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಕ್ಯೂ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಆ್ಯಂಡ್ ಕ್ಯೂ ಆ್ಯಕ್ಚುಲಿ ಬಿಕಮ್ಸ್ ಗ್ರೇಟರ್ ದ್ಯಾನ್ ಕೆ, ದೆನ್ ದ ರಿಯಾಕ್ಷನ್ ಗೋಸ್ ಫ್ರಮ್ ರೈಟ್ ಟು ಲೆಫ್ಟ್ ಸೈಡ್. If products concentration is increased, if products concentration is increased, then Q also increases. Therefore, the reaction goes from right to left side. And if the product's concentration is decreased, the reaction goes from left to right side. ಈ ಥಿಂಗ್ಸ್ ನಮಗೆ ಆಲ್ರೆಡಿ ಗೊತ್ತಿದ್ದಾವೆ. ನಾನಿವಾಗ ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಎಕ್ಸಾಂಪಲ್ಸ್ ಅನ್ನು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೀನಿ to make you understand how does this equilibrium or the change of concentration of reactants and products affect the equilibrium. Fe plus 3 plus SCN minus gives rise to FeSCN plus 2 ಅನ್ನೋದು ಈಕ್ವೇಷನ್. ಈ ಈಕ್ವೇಷನ್ ಅನ್ನು ನಾವು ತಗೊಂಡಿದ್ದಾಗ ಇದು ಬ್ಲಡ್ ರೆಡ್ ಕಲರ್ ಕಾಂಪ್ಲೆಕ್ಸ್, ಇದು ರಿವರ್ಸಿಬಲ್ ರಿಯಾಕ್ಷನ್. ಈಗ ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ವಿ ಅಂತಂದರೆ, ಇಫ್ ವಿ ಆ್ಯಡ್ Fe plus 3 ಆರ್ FeCl3, FeCl3 ಅನ್ನು ಈ ರಿಯಾಕ್ಷನ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ಗೆ ಆ್ಯಡ್ ಮಾಡಿದ್ದಾಗ, FeCl3 ಅನ್ನು ಈ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ಗೆ ಆ್ಯಡ್ ಮಾಡಿದ್ದೀನಿ ಅಂತ ಅನ್ಕೋ, FeCl3ನ ಆ್ಯಡ್ ಮಾಡಿದ್ದಾಗ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ Fe plus 3 ಏನಾಗುತ್ತೆ? ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ Fe plus 3 ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ. ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ Fe plus 3 ಅಂದರೆ ಏನು? ರಿಯಾಕ್ಟೆಂಟ್ಸ್ನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ರಿಯಾಕ್ಟೆಂಟ್ಸ್ನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದ್ರೆ ರಿಯಾಕ್ಷನ್ ಯಾವ ಸೈಡ್ಗೆ ಹೋಗುತ್ತೆ? ಇಟ್ ಗೋಸ್ ಫ್ರಮ್ ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಸೈಡ್. ಎರಡನೇ ಕಂಡೀಷನ್, ಇಫ್ NaSCN ಈಸ್ ಆ್ಯಡೆಡ್, ನಾನು NaSCN ಅನ್ನು ಆ್ಯಡ್ ಮಾಡಿದರೆ Na ಇಲ್ಲೆಲ್ಲಿ ಇಲ್ಲ, ಅಂದರೆ Na ಸಂಬಂಧ ಇಲ್ಲ. ಇದು Na ಡಸ್ ನಾಟ್ ಹ್ಯಾವ್ ಎನಿ ಕನೆಕ್ಷನ್ ಹಿಯರ್. ಮತ್ತೇನಿದೆ? SCN ಮೈನಸ್ಗೆ ಕನೆಕ್ಷನ್ ಇದೆ. ನಾನು ಇದನ್ನು ಆ್ಯಡ್ ಮಾಡಿದರೆ SCN ಮೈನಸ್ ಅಯಾನ್ಸ್ ಆ್ಯಡಪ್ ಆಗ್ತವೆ. SCN ಮೈನಸ್ ಆ್ಯಡಪ್ ಆಗಿದರೆ ಏನಾಗುತ್ತೆ? SCN ಮೈನಸ್ ಅಯಾನ್ಸ್ ಆ್ಯಡಪ್ ಆಗಿದ್ದಕ್ಕೆ, ಇನ್ಕ್ರೀಸ್ ಆಗಿದ್ದಕ್ಕೆ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದೆ. ರಿಯಾಕ್ಟೆಂಟ್ಸ್ನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಇನ್ಕ್ರೀಸ್ ಆಗಿದರೆ ಆ ರಿಯಾಕ್ಷನ್ ಯಾವ ಸೈಡ್ಗೆ ಹೋಗುತ್ತೆ? ಮತ್ತೆ ಫಾರ್ವರ್ಡ್ ಡೈರೆಕ್ಷನ್ಗೆ ಹೋಗುತ್ತೆ. ದೇರ್ಫೋರ್ ದ್ಯಾಟ್ ಆಲ್ಸೋ ಲೀಡ್ಸ್ ಟು ಲೆಫ್ಟ್ ಟು ರೈಟ್ ಸೈಡ್ ಶಿಫ್ಟ್ ಆಫ್ ದಿ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್. ನೆಕ್ಸ್ಟ್ ಒನ್, ಇಫ್ mercury plus 2 ions or mercury chloride is added, ಒಂದು ವೇಳೆ ಮರ್ಕ್ಯುರಿ ಕ್ಲೋರೈಡ್ ಅನ್ನು ಆ್ಯಡ್ ಮಾಡಿದರೆ ಅವಾಗ ಏನಾಗುತ್ತೆ? ಈ ಮರ್ಕ್ಯುರಿ ಪ್ಲಸ್ 2 ಅಯಾನ್ಸ್ ರಿಲೀಸ್ ಆಗ್ತವೆ. ಮರ್ಕ್ಯುರಿ ಪ್ಲಸ್ 2 ಅಯಾನ್ಸ್ ಏನು ಮಾಡ್ತವೆ? ಇಲ್ಲೆಲ್ಲಿ ಮರ್ಕ್ಯುರಿ ಇಲ್ಲ, ಆದರೆ ಮರ್ಕ್ಯುರಿ ಅಯಾನ್ಸ್ ಏನು ಮಾಡ್ತವೆ ಅಂತಂದರೆ ಈ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ನಲ್ಲಿರುವ SCN ಮೈನಸ್ ಅಯಾನ್ಸ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತವೆ. ಈ SCN ಮೈನಸ್ ಅಯಾನ್ಸ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ದೇ ಫಾರ್ಮ್ ಅ ಕಾಂಪ್ಲೆಕ್ಸ್ HgSCN 4 times -2 ಅನ್ನುವ ಕಾಂಪ್ಲೆಕ್ಸನ್ನು ಫಾರ್ಮ್ ಮಾಡ್ತವೆ. ಈ ತರಹ ಕಾಂಪ್ಲೆಕ್ಸ್ ಫಾರ್ಮ್ ಆಗಿದರೆ SCN- ಅಯಾನ್ಸ್ ಎಲ್ಲ ಈ ರಿಯಾಕ್ಷನ್ಗೆ ಹೋಗ್ಬಿಡ್ತವೆ. ಅಂದರೆ ಇಲ್ಲಿ SCN- ಅಯಾನ್ಸ್ನ ನಂಬರ್ ಕಮ್ಮಿ ಆಗತ್ತೆ ಈ ಈಕ್ವಿಲಿಬ್ರಿಯಂನಲ್ಲಿ. SCN- ಅಯಾನ್ಸ್ನ ನಂಬರ್ ಕಮ್ಮಿ ಆಗಿದರೆ ಪ್ರಾಡಕ್ಟ್ಸಿನ ರಿಯಾಕ್ಟೆಂಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಆಗಿದೆ. ರಿಯಾಕ್ಟೆಂಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಆಗಿದರೆ ರಿಯಾಕ್ಷನ್ ಗೋಸ್ ಫ್ರಮ್ right to left side. Therefore, reaction goes in the reverse direction. Last condition, if ಈ reaction ನಲ್ಲಿ ನಾನು ಇವೆಲ್ಲ ಬದಲು if I am applying or if I am actually adding oxalic acid, if oxalic acid is added, oxalic acid add ಮಾಡಿದರೆ ಏನಾಗುತ್ತೆ? ಆಕ್ಸಲಿಕ್ ಆಸಿಡ್ ಆ್ಯಡ್ ಮಾಡಿದರೆ ಆಕ್ಸಲೇಟ್ ಅಯಾನ್ಸ್ ಬರ್ತವೆ. ಈ ಆಕ್ಸಲೇಟ್ ಅಯಾನ್ಸ್ ಈ ರಿಯಾಕ್ಷನ್ನಲ್ಲಿ ಎಲ್ಲಿ ಇಲ್ಲ. ಬಟ್ ವಾಟ್ ದೇ ಡೂ ಇಸ್ ಆಕ್ಸಲೇಟ್ ಅಯಾನ್ಸ್ ರಿಯಾಕ್ಟ್ ವಿತ್ Fe+3. Fe+3 ಜೊತೆಗೆ ಆಕ್ಸಲೇಟ್ ಅಯಾನ್ಸ್ ರಿಯಾಕ್ಟ್ ಆಗ್ತವೆ. ರಿಯಾಕ್ಟ್ ಆಗಿ ದೇ ಫಾರ್ಮ್ ಅ ಕಾಂಪ್ಲೆಕ್ಸ್. ಈ ಕಾಂಪ್ಲೆಕ್ಸಿನ ಸ್ಟ್ರಕ್ಚರ್ ಏನು ನಾವು ನೆನಪಿಟ್ಕೊಳ್ಳುವ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಬಟ್ ರಿಯಾಕ್ಟ್ ಆಗ್ತವೆ ಅಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು. ಸೊ Fe+3 ಇರಲ್ಲ ಇದರಲ್ಲಿ. ಅಂದರೆ ರಿಯಾಕ್ಟೆಂಟ್ಸ್ ಕಮ್ಮಿ ಆದವು. ರಿಯಾಕ್ಟೆಂಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಕಮ್ಮಿ ಆದರೆ ರಿಯಾಕ್ಷನ್ ಯಾವ ಸೈಡ್ಗೆ ಹೋಗುತ್ತೆ? ಬ್ಯಾಕ್ವರ್ಡ್ ಹೋಗ್ಬಿಡುತ್ತೆ. ಈ ವಿಷಯವನ್ನು ನಾವು ತಿಳ್ಕೋಬೇಕು. 4 ಕಂಡೀಷನ್ಸ್ ಅದಾವೆ. ಇದು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಎಕ್ಸಾಂಪಲ್, ನೆನಪಿಟ್ಕೋಬೇಕು. ಇನ್ನೊಂದು ಸಲ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನು ಕಾನ್ಸಂಟ್ರೇಷನ್ಸ್ ಯಾವ ಥರ ಎಫೆಕ್ಟ್ ಆಗ್ತವೆ ಅಂತ. ನಾನು FeCl3 ಫೆರ್ರಿಕ್ ಕ್ಲೋರೈಡನ್ನು ಅಥವಾ ಫೆರ್ರಿಕ್ ಸಲ್ಫೇಟನ್ನು ಆ್ಯಡ್ ಮಾಡಿದರೆ ಫೆರ್ರಿಕ್ ಅಯಾನ್ಸ್ ಬರ್ತವೆ. ಅಂದರೆ ರಿಯಾಕ್ಟೆಂಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ತುಂಬ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ರಿಯಾಕ್ಟೆಂಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಜಾಸ್ತಿ ಆದರೆ ರಿಯಾಕ್ಷನ್ ಫಾರ್ವರ್ಡ್ ಹೋಗುತ್ತೆ. ಸೋಡಿಯಂ ಥಯೋಸಯನೇಟ್ ಆರ್ ಪೊಟ್ಯಾಷಿಯಂ ಥಯೋಸಯನೇಟನ್ನು ನಾವು ಆ್ಯಡ್ ಮಾಡಿದ್ದಾಗ ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಥಿಂಗ್ ಏನು ಮಾಡುತ್ತೆ ಅಂತಂದರೆ ರಿಯಾಕ್ಟೆಂಟ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಅಂದರೆ ಥಯೋಸಯನೇಟ್ ಅಯಾನ್ಸಿನ ಕಾನ್ಸಂಟ್ರೇಷನನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ತಾ ಇದೆ. ಅದು ಇನ್ಕ್ರೀಸ್ ಆಗಿ ರಿಯಾಕ್ಷನ್ ಫಾರ್ವರ್ಡ್ ಹೋಗಿಬಿಡುತ್ತೆ. ಇದು 2ನೇ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. ಈಗ 3rd ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದೆ ಏನಂತಂದರೆ ಮರ್ಕ್ಯುರಿಕ್ ಕ್ಲೋರೈಡನ್ನು ಆ್ಯಡ್ ಮಾಡಿದರೆ ಇಲ್ಲೆಲ್ಲಿ ಮರ್ಕ್ಯುರಿ ಇಲ್ಲ ಆದರೂ ಕೂಡ ಆ ಮರ್ಕ್ಯುರಿ ಅಯಾನ್ಸ್ ಬಂದು SCN- ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಆ SCN- ಈ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ರಿಂದ ತೊಗೊಂಡು ಹೋಗ್ತವೆ. ಆವಾಗ ಈ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ನಲ್ಲಿ SCN- ಅಯಾನ್ಸ್ ಕಮ್ಮಿ ಆಗ್ತವೆ. ಆ ಥರ ಆಗಿರೋದ್ರಿಂದ ನಮಗೆ Fe+3 ಅಯಾನ್ಸ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನೋದು ಬ್ಯಾಕ್ವರ್ಡ್ ಬರುತ್ತೆ. ಬಿಕಾಸ್ SCN- ಅಯಾನ್ಸ್ ಹ್ಯಾವ್ ಕಮ್ reduced. Next one, ಒಂದು ವೇಳೆ ನಾನು ಮರ್ಕ್ಯುರಿಕ್ ಕ್ಲೋರೈಡ್ ಬದಲು ಆಕ್ಸಲಿಕ್ ಆಸಿಡ್ ಆ್ಯಡ್ ಮಾಡಿದರೆ ಆಕ್ಸಲಿಕ್ ಆಸಿಡ್ ಆ್ಯಡ್ ಮಾಡಿದ್ದಕ್ಕೆ Fe+3 ಅಯಾನ್ಸ್ ಎಲ್ಲ ಕೂಡ ಆಕ್ಸಲೇಟ್ ಜೊತೆಗೆ ರಿಯಾಕ್ಟ್ ಆಗಿ FeC2O4 ಥ್ರೈಸ್ -3 ಅನ್ನೋದು ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಅಂದರೆ Fe+3 ಅಯಾನ್ಸ್ ಎಲ್ಲ ಕಮ್ಮಿ ಆಗ್ತವೆ. ಸೊ ರಿಯಾಕ್ಷನ್ ಗೋಸ್ ಇನ್ ದ ರಿವರ್ಸ್ ರಿಯಾಕ್ಷನ್. ಅಂದರೆ ಬ್ಲಡ್ ರೆಡ್ ಕಲರ್ ಅನ್ನೋದು ಕಮ್ಮಿ ಆಗುತ್ತೆ. ಇದು ಅಪ್ಲಿಕೇಶನ್ಸ್ ಆಫ್ ಲೀ ಚಾಟ್ಲಿಯರ್ ಪ್ರಿನ್ಸಿಪಲ್ ಫಾರ್ ಕಾನ್ಸಂಟ್ರೇಷನ್ ಆಫ್ ರಿಯಾಕ್ಟನ್ಸ್ ಆ್ಯಂಡ್ ಪ್ರಾಡಕ್ಟ್ಸ್. ಈಗ ಸೆಕೆಂಡ್ ಇಂಪಾರ್ಟೆಂಟ್ ಥಿಂಗ್ ಅನ್ನು ನೋಡೋಣ ನಾವು. ಸೆಕೆಂಡ್ ಇಂಪಾರ್ಟೆಂಟ್ ಫ್ಯಾಕ್ಟರ್ ಬಂದ್ಬಿಟ್ಟು ಟೆಂಪರೇಚರ್. ಯಾವ ತರಹ ಟೆಂಪರೇಚರ್ ಅನ್ನೋದು ಎಫೆಕ್ಟ್ ಮಾಡುತ್ತೆ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಅನ್ನು ನೋಡಿದರೆ, ಇಫ್ ಯು ಡಿಕ್ರೀಸ್ ಟೆಂಪರೇಚರ್, if temperature is decreased, then it favors exothermic reaction. If temperature is increased, temperature increase ಆದರೆ it favors endothermic reaction. ಅದು ಎಂಡೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನು ಫೇವರ್ ಆಗುತ್ತೆ. ಈ 2 ಪಾರ್ಟ್ಸ್, ಈ 2 ಥಿಂಗ್ಸ್ ನೆನಪಿಟ್ಕೊಂಡ್ರೆ ಇಟ್ಸ್ ಈಸಿಯರ್. A+B gives rise to C+D ಈಸ್ ಆನ್ ಎಕ್ಸೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್. ಕೆಲವು ಸತ ಎಕ್ಸೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅನ್ನು ಈ ಥರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡಲ್ಲ, ಕೆಲವು ಸತ ಈ ಥರ ರೆಪ್ರೆಸೆಂಟ್ ಮಾಡ್ತಾರೆ. A+B + C+D + Q ಅಂತಾರೆ. ಅಂದರೆ ಹೀಟ್ ಅನ್ನೋದು CD ಜೊತೆಗೆ ರಿಲೀಸ್ ಆಗಿದೆ, ಪ್ರಾಡಕ್ಟ್ಸ್ ಜೊತೆಗೆ ಹೀಟ್ ಕೂಡ ಬಂದಿದೆ, ಅಂದರೆ ಅದು ಎಕ್ಸೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅಂತ ತಿಳ್ಕೋಬೇಕು. ಇದು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕಾಗಿದ್ದ ವಿಷಯ. ದೇರ್ಫೋರ್ ಈ ಥರ ಕೊಟ್ಟಾಗ ಫಾರ್ವರ್ಡ್ ಎಕ್ಸೋಧರ್ಮಿಕ್ ಇದೆ ಬ್ಯಾಕ್ವರ್ಡ್ ಎಂಡೋಧರ್ಮಿಕ್ ಇದೆ. ಇದು ತಿಳ್ಕೊಂಡು ನಾನು ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದ್ದೀನಿ ಅನ್ಕೋ, ಟೆಂಪರೇಚರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಎಂಡೋಧರ್ಮಿಕ್ ಫೇವರ್ ಆಗುತ್ತೆ, ಅಂದರೆ ಬ್ಯಾಕ್ವರ್ಡ್ಗೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸ್ ಮಾಡಿದ್ದೀನಿ ಅಂತ ಅನ್ಕೋ, ಟೆಂಪರೇಚರ್ ಡಿಕ್ರೀಸ್ ಮಾಡಿದರೆ ಎಕ್ಸೋಧರ್ಮಿಕ್ ಫೇವರ್ ಆಗುತ್ತೆ, ಅಂದರೆ ಫಾರ್ವರ್ಡ್ಗೆ ಶಿಫ್ಟ್ ಆಗುತ್ತೆ. ಇಷ್ಟು ವಿಷಯ ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ನೆಕ್ಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ನೋಡೋಣ. ಟೆಂಪರೇಚರ್ ಅನಂತರ ನಾನು ಒಂದು ವೇಳೆ ಎಂಡೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ತಗೊಂಡ್ರೆ ಯಾವ ಥರ ಇರುತ್ತೆ. P plus Q gives rise to R plus S ಅಂತ ಒಂದು ರಿಯಾಕ್ಷನ್ ಇದೆ. ಈ ರಿಯಾಕ್ಷನ್ನಲ್ಲಿ ಡೆಲ್ಟಾ H ಈಕ್ವಲ್ಸ್ ಪ್ಲಸ್ Q ಅಂದರೆ ಫಾರ್ವರ್ಡ್ ಎಂಡೋಧರ್ಮಿಕ್ ಆಗಿದೆ, ಬ್ಯಾಕ್ವರ್ಡ್ ಎಕ್ಸೋಧರ್ಮಿಕ್ ಆಗಿದೆ. ಈ ಪಾಯಿಂಟ್ನಲ್ಲಿ ನಾವು ಏನು ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು ಅಂತಂದರೆ, ನಾನು ಟೆಂಪರೇಚರನ್ನು ಇನ್ಕ್ರೀಸ್ ಮಾಡಿದರೆ ಎಂಡೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಫೇವರ್ ಆಗುತ್ತೆ. ಎಂಡೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಫೇವರ್ ಆಗೋದು ಅಂತಂದರೆ ಇಟ್ ಗೋಸ್ ಫಾರ್ವರ್ಡ್. ಅದೇ ನಾನು ಟೆಂಪರೇಚರನ್ನು ಡಿಕ್ರೀಸ್ ಮಾಡಿದರೆ ಎಕ್ಸೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಫೇವರ್ ಆಗುತ್ತೆ, ಅಂದರೆ ದ ರಿಯಾಕ್ಷನ್ ಗೋಸ್ ಬ್ಯಾಕ್ವರ್ಡ್. ಈಗ ಈ ಕಾನ್ಸೆಪ್ಟ್ನಲ್ಲಿ ನಾವು ಟೆಕ್ಸ್ಟ್ ಬುಕ್ ಎಕ್ಸಾಂಪಲ್ಸನ್ನು ಎರಡು ಸ್ಟಡಿ ಮಾಡೋಣ ಕ್ವಿಕ್ ಆಗಿ. When we consider the textbook examples with regard to temperature, ಈ ರಿಯಾಕ್ಷನ್ ಅನ್ನು ಕೊಟ್ಟಿರ್ತಾರೆ. NO2 gives rise to N2O4. ಈ ರಿಯಾಕ್ಷನ್ ನಲ್ಲಿ NO2 ಏನಿದೆ, ಇಟ್ ಈಸ್ ಅ ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ಗ್ಯಾಸ್ which is brown in color and it has unpaired electrons. Whereas N2O4 is a diamagnetic gas, colorless and paid electrons ಅದಾವೆ. ಯಾಕಂದರೆ NO2 ನಲ್ಲಿ ಒಂದು ಅನ್ಪೇಯ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೆ, ಅದಕ್ಕೆ ಆ ಕಾರಣದಿಂದ ಬ್ರೌನ್ ಕಲರ್ ಮತ್ತು ಅನ್ಪೇಯ್ಡ್ ನೇಚರ್ ಮತ್ತು ಪ್ಯಾರಾಮ್ಯಾಗ್ನೆಟಿಕ್ ನೇಚರ್ ಬರ್ತವೆ ಇದರಲ್ಲಿ. ಈಗ ಎರಡು ಎಕ್ಸೋಧರ್ಮಿಕ್ ಆಯಿತು ಅಂತ ಅನ್ಕೋ, ಡೆಲ್ಟಾ H ಇಸ್ ಮೈನಸ್ Q ಆ್ಯಕ್ಚುಲಿ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ಗೆ. ಈ ಗ್ಯಾಷಿಯಸ್ ಈಕ್ವಿಲಿಬ್ರಿಯಮನ್ನು ಒಂದು ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ನಲ್ಲಿ ತಗೋಬೇಕು. ಈ ಟೆಸ್ಟ್ ಟ್ಯೂಬನ್ನು ನಾವೇನು ಮಾಡ್ತಾ ಇದ್ವಿ ಅಂತಂದರೆ ಡಿಫ್ರೆಂಟ್ ಕಂಡೀಷನ್ಸ್ನಲ್ಲಿ ಇಡ್ತಾ ಇದ್ವಿ. ಫಸ್ಟ್ ಕಂಡೀಷನ್ ಎದರಲ್ಲಿ ಇಡ್ತಾ ಇದ್ವಿ, ಲೋ ಟೆಂಪರೇಚರ್ನಲ್ಲಿ ಐಸ್ ಕೋಲ್ಡ್ ವಾಟರ್ನಲ್ಲಿ ಇಡ್ತಾ ಇದ್ದೀನಿ. ಐಸ್ ಕೋಲ್ಡ್ ವಾಟರ್ನಲ್ಲಿ ಇಡೋದಂದ್ರೆ ಏನು, ಟೆಂಪರೇಚರ್ ಕಮ್ಮಿ ಮಾಡೋದು. ಟೆಂಪರೇಚರ್ ಕಮ್ಮಿ ಮಾಡಿದರೆ ಯಾವ ಡೈರೆಕ್ಷನ್ಗೆ ಹೋಗಬೇಕಿದು, ಎಕ್ಸೋಧರ್ಮಿಕ್ ರಿಯಾಕ್ಷನ್ ಅಲ್ವಾ. ಫಾರ್ವರ್ಡ್ ಈಸ್ ಎಕ್ಸೋಧರ್ಮಿಕ್, ಬ್ಯಾಕ್ವರ್ಡ್ ಈಸ್ ಎಂಡೋಧರ್ಮಿಕ್. ನಾನು ಟೆಂಪರೇಚರನ್ನು ಕಮ್ಮಿ ಮಾಡಿದ್ದೀನಿ, ವಿಚ್ ಫೇವರ್ಸ್ ದ ಫಾರ್ವರ್ಡ್ ರಿಯಾಕ್ಷನ್ ವಿಚ್ ಈಸ್ ಎಕ್ಸೋಧರ್ಮಿಕ್. ಹಾಗಾಗಿ ದ ಗ್ಯಾಸ್ ಬಿಕಮ್ಸ್ ಕಲರ್ಲೆಸ್. ಎರಡನೇ ಕಂಡೀಷನ್ ಏನಂತಂದರೆ ರೂಮ್ ಟೆಂಪರೇಚರ್ನಲ್ಲಿ ಇಟ್ಟಿದ್ದಾಗ, ರೂಮ್ ಟೆಂಪರೇಚರ್ನಲ್ಲಿ ನಾನು ಹೀಟ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಕೂಲ್ ಮಾಡ್ತಾ ಇಲ್ಲ, ಸೊ ಸಿಸ್ಟಮ್ ರಿಮೇನ್ಸ್ ಆಟ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ. ಒಂದು ವೇಳೆ ನಾನು ಹಾಟ್ ವಾಟರ್ ಇರುವ ಚೇಂಬರ್ನಲ್ಲಿ ಇಟ್ಟಿದರೆ, ಹಾಟ್ ವಾಟರ್ ಇರುವ ಚೇಂಬರ್ನಲ್ಲಿ ಏನಾಗುತ್ತೆ ಅಂತಂದರೆ, ಐ ಹ್ಯಾವ್ ಹೀಟೆಡ್ ದ ಸಿಸ್ಟಮ್. ಹೀಟ್ ಮಾಡಿದರೆ ಎಂಡೋಧರ್ಮಿಕ್ ಪ್ರಾಸೆಸ್ ಫೇವರ್ ಆಗುತ್ತೆ, ಅಂದರೆ ರಿಯಾಕ್ಷನ್ ಬ್ಯಾಕ್ವರ್ಡ್ ಬರುತ್ತೆ, ಅಂದರೆ ಟೆಸ್ಟ್ ಟ್ಯೂಬ್ನಲ್ಲಿ ಗ್ಯಾಸ್ ಎಲ್ಲ ಕೂಡ ಬ್ರೌನ್ ಕಲರ್ನಲ್ಲಿ ಇರುತ್ತೆ. ಇದು ನಾವು ಅರ್ಥ ಮಾಡಿಕೋಬೇಕು. ಸೊ ಹಿಯರ್ ವಿ ಶಿಲ್ ಸ್ಟಾಪ್ ಫಾರ್ ಟುಡೇ ಆ್ಯಂಡ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದ ರೆಸ್ಟ್ ಆಫ್ ದ ಪಾರ್ಟ್ ಆಫ್ ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಟುಮಾರೋ.
Good morning all of you students. So today topic semiconductors. This year like 2026 so 3 questions are given. Not only this year amma, every year amma semiconductors la minimum 3 questions are given. Minimum 3 questions. So that 3 questions are also very simple models. Very simple models. So before explanation of that problems, one point is you can remind them. Semiconductors are two types. One is intrinsic. I am not explaining the total concept, just important points. Okay, 5 minutes ra important points. After that, how to solve the models we can explain. Intrinsic semiconductor, other one is extrinsic semiconductor. Intrinsic semiconductor, other one is extrinsic semiconductor. Already we know that intrinsic semiconductor is nothing but pure semiconductors. Pure semiconductors like germanium and silicon. Germanium and silicon. Extrinsic semiconductors is nothing but impure semiconductors. Impure semiconductors. Now the pure semiconductors are used in electrical circuit, the conductivity is small. The conductivity is small. That's why these are not used in electrical circuit. So for more conductivity, we can use the extrinsic semiconductor. For more conductivity, we can use the extrinsic semiconductor, like impure semiconductors. These are two types. What is that? One is a p-type semiconductor, other one is n-type semiconductor. Right. How the p-type semiconductors are formed? The pure semiconductors is doped with trivalent impurities. Trivalent impurities. Now previous question amma, what are the trivalent impurities? Trivalent impurities means third group elements. What are the third group elements? Aluminium, gallium, indium and boron. Aluminium, gallium, indium, boron is nothing but a trivalent impurities. So these points like aluminium, gallium, indium, boron, these are the trivalent impurities. This type of question is given on the previous date. So this point is the important. For n-type semiconductor, pure semiconductor is doped with pentavalent impurities. Pentavalent impurities. Pure semiconductor is doped with pentavalent impurities. What are the pentavalent impurities? Like fifth group elements. What are the fifth group elements? Phosphorus, arsenic, antimony and bismuth. Phosphorus, arsenic, antimony, bismuth. That's why these 2 points are the important. Okay. In this topic, the main points are like these two. The pure semiconductors are doped with trivalent impurities. We get the p-type. What are the trivalent impurities? Aluminium, gallium, indium, boron. N-type semiconductor, pure semiconductor is doped with pentavalent impurities like phosphorus, arsenic, antimony, bismuth. Right. These are also known as p-type semiconductors are also known as what are the acceptors. These are also known as acceptors. These are also known as acceptors. N-type semiconductors also known as donors. Is also known as donors. Very important points. And also one of the important point. In p-type or n-type and anyone, the important point is Ni square is equal to Ne into Nh. Ni square is equal to Ne into Nh. What is the meaning of Ne? Number of the electrons per unit volume. Nh, number of the holes per unit volume. Number of the electrons per unit volume, number of the holes per unit volume. What is the meaning of Ni? Number of electrons and holes pair in purest form of semiconductor. purest form of semiconductor. So Ni square means number of electrons and holes in purest form of semiconductor, that is nothing but Ni square. Compulsory this value is given amma, only is asking the Na or NH. Na or NH is asking, but compulsory in any numerical Ni value is given. So this formula is the very very important. Ni square is equal to Ne into NH. Now one more point I can remind them, that point is nothing but conductivity. Next point, conductivity. Conductivity sigma is equal to mu Ne. Conductivity sigma is equal to mu Ne, where mu is known as mobility. Already we know that. You can revise the notes compulsory. Conductivity is equal to mu is nothing but mobility. N is nothing but number of the charged particles per unit volume. E is nothing but charge. For example, for p-type semiconductor, what are the majority charge carriers? Holes ga, like this one is holes. For p-type semiconductor. Right. For example, n-type semiconductor, what is the conductivity? Mu Ne. But n-type semiconductor, the majority charge carriers are electrons. That's why the conductivity in n-type semiconductor is mu Ne. Mu, mobility of the electrons. Ne, number of the electrons per unit volume. Charge of the electron, charge of the hole, both are same. Charge of the electron, charge of the hole, both are same. 1.6 into 10 power minus 19. Mu H, mobility of the holes. Mu E, mobility of the electrons. NH, number of the holes per unit volume, number of the electrons per unit volume. So these two are the important. This is only for p-type semiconductor. This is only for n-type semiconductor. For example, what is the conductivity for pure semiconductor? For pure semiconductor like this one. What is the conductivity for pure semiconductor? In pure semiconductor, number of the electrons, number of the holes both are same. That's why the sigma E plus sigma H. These two values are adding here. We get the conductivity for pure semiconductor. So note them, mama. These 3 points are the important. First point, note them. Ni square is equal to Ne into NH. Ne, number of the electrons per unit volume. NH, number of the holes per unit volume. Ni square, number of the electrons and holes in purest form of semiconductor. Next, conductivity in p-type semiconductor mu Ne. Conductivity in n-type semiconductor mu Ne. But here for electrons amma, here amma for holes amma. What is the conductivity in intrinsic semiconductor amma? Both. Because of in intrinsic semiconductor, number of the electrons and holes both are same. That's why the total conductivity sigma is equal to sigma E plus sigma H. Conductivity for electrons, conductivity for holes. So this why these 3 points are the important amma. Only we can note them formulas. And another point is p-type and n-type pure semiconductor is doped with trivalent. Examples are the important. And pure semiconductor is doped with pentavalent. Like examples are important. These are also known as acceptors. These are also known as donors. In p-type or n-type, the common formula like this. So 1, 2, 3, 4. That 4 formulas are the important amma, right? Okay, next. Just I am explaining some examples. Right, amma. This question is the important model amma in our NCERT textbook, one of the example. Now listen carefully. For example, silicon. I am taking the pure crystal like a pure semiconductor is silicon. In silicon has 5 into 10 power 28 atoms per centimeter cube. Atoms per centimeter cube. In pure silicon, 5 into 10 power 28 atoms per centimeter cube. It is doped by 1 ppm concentration. 1 ppm concentration of arsenic. 1 ppm concentration of arsenic. Then and Ni value is equal to is the clearly given 1.5 into 10 power 16 meter power minus 3. Then find number of electrons and holes. Then find number of electrons and holes. Very, very important model. Already this is the one of the clearly NCERT example model. In pure silicon has 5 into 10 power 28 atoms per centimeter cube. Atoms per centimeter cube. But this silicon and pure silicon, like pure semiconductor, it is doped by 1 ppm of arsenic. 1 ppm of arsenic. Ni value is given. Find the number of the electrons and holes. This one is also centimeter cube. How to solve that one? Now listen carefully. What is the meaning of 1 ppm? 1 ppm is nothing but 1 part per million. 1 part per million. 1 part per million of arsenic. And pure silicon is doped with arsenic. We can form what is the type of the semiconductor? Arsenic. Phosphorus, arsenic, antimony, bismuth is nothing but N-type semiconductor. We get the N-type semiconductor. In N-type semiconductor, what are the charge carriers? Majority charge carriers are holes. Therefore, number of electrons. Sorry, in N-type semiconductor, the majority charge carriers are electrons. Electrons. That number of electrons is equal to pure semiconductor is doped with arsenic to form the N-type semiconductor. In N-type semiconductor, what are the majority charge carriers? Electrons. That number of the electrons is equal to, now listen carefully. Totally silicon how many? 5 into 10 power 28. 5 into 10 power 28. Right. That is doped by 1 part per million. This can be doped by 1 part per means divide. Million means 10 power 6. Million means 10 power 6. 1 part per million. 1 part per million. Million means 10 power 6. That's why how much value we get? 5 into 10 power 21. 5 into 10 power 21. We get the 5 into 10 power 21 atoms per meter cube. Atoms per meter cube. This is nothing but atoms. This one is a centimeter cube, like atoms per centimeter cube. So the number of the electrons we get, number of the electrons is nothing but Ne nega. So in this problem, number of the electrons we get. How to solve the number of the holes? Already we know that Ni square is equal to Ne into Nh. Ni square is equal to Ne into Nh. What is the value of Ni square, Ni square is nothing but 1.5 into 1.5. 2.25 into 10 power 16 whole square, 10 power 32. Into Ne value is equal to how much, 10 power 5 into 10 power 21 into Nh. Where Nh is nothing but a number of the whole sega. Nh is nothing but a number of whole sega. Therefore, Nh is equal to 2.25 into 10 power 32 by 5 into 10 power 21. 10 power 21 means how much value we get? 10 power 11. This value how much? 0.45. So simply 4.5 into 10 power 11 centimeter cube per centimeter cube. So model is the important one amma, already in our NCERT lo one of the solved problem. So now again, in silicon having 5 into 10 power 28 atoms per centimeter cube. Now it is doped 1 ppm of arsenic. What is the meaning of ppm? Part per million. Part per million. So of arsenic amma, arsenic. But Ni value is given amma, then find the number of the electrons and holes. So number of the electrons is equal to arsenic amma. It is nothing but doped by arsenic is nothing but pentavalent. Pentavalent means n-type semiconductor. In n-type semiconductor means to form the number majority charge carriers are the electrons. So number of the electrons is equal to original value of 5 into 10 power 28. It is doped by 1 part per million. 1 part per million. Per means divided by million means 10 power 6. We get 5 into 10 power 21 centimeter cube. Centimeter power per centimeter cube. We get Ne. How to find the NH? Already we know that Ni square is equal to Ne into NH. Ni value given, Ne value we can finding, already NH value, we can how to find that one? NH value is equal to like this value by this value amma, we get this final value. So important model amma, just note it amma, this one. Now one more model amma in our NCERT textbook amma, one another model. What is the conductivity? What is the conductivity of a pure semiconductor? Pure semiconductor having electron concentration, how much? 5 into 10 power 18 meter power minus 3. And holes concentration 5 into 10 power plus 19 meter power minus 3. That one electron concentration, this one hole concentration is given. Next, the electron mobility. Electron mobility is nothing but 2 meter square volt power minus 1 s power minus 1, and holes mobility 0.01 meter square volt power minus 1 and second power minus 1. Right, that is the question. Now listen. Find the conductivity. Find the conductivity of the only given the semiconductor, like pure semiconductor. Find the conductivity of the pure semiconductor having the electron concentration given, holes concentration given. Mobility of the electrons given, mobility of the holes value given. What is the conductivity? Now what is the conductivity? One more model amma, NCERT model, like important one. How to solve this one amma? Already we know that conductivity is equal to pure semiconductor. They are having the electrons and the holes. Conductivity of electrons and holes. What is the formula? Mu Ne. Mu Ne. This one electrons. This one holes. Electrons and holes ke charge value same ga. That's why this value take them common. This value take them common. What is the charge of the electron? 1.6 into 10 power minus 19. What is the mu E, mobility of the electron? Like 2. Into number of the electrons concentration, like 5 into 10 power 8, plus mu H, mobility of the holes, 0.01. What is the value of holes concentration? 5 into 10 power 19. 1.6 into 10 power minus 19. Here 10 power plus 19 is common. 5 into 2, 10. 10 into 10 power 18. 10 power 19 ga. That total 10 power 19 common ga. Only 1a. Here already 10 power 19 is common. How much value we get? 0.01 into 5. But these two values are cancelled. 1.6 into 1.05. 1.6 into 1.05, we get 1.68. 1.68. So this is another important model, amma. So copy them, amma. Just 5 minutes you can revise this model. Find the conductivity of the semiconductor. Here only given the semiconductor is nothing but pure semiconductor. Having the electron concentration given, holes concentration given. Mobility of the electrons given, mobility of the holes value given. What is the conductivity? Conductivity in pure semiconductor, conductivity for electrons, conductivity for holes. Therefore, mu Ne, both having the same charge gamma, that's why charge value is common. These values are substituting here. Here 10 power minus plus 19 is common, and simplify them, we get 1.68 conductivity. Note this concept, important model, just you can revise the model. Right, amma. Now another important model, amma. Actually, in a NEET exam, 4 days are there now, we can explain some important models, amma. Some students are there now in campus. That time we can explain the number of the models. The same models are is given, like one of the example, amma. These models I am explaining the minimum 5 to 10 models are explained. Same model is given, amma. Like what is the model? This is this one is 10 volts, amma. Here 5 ohms, 2 ohms, here 3 ohms, and this 4 ohms. What is the current in the circuit as shown? What is the current in the circuit? Here current I is started. What is the current in the circuit? This type of the models minimum I am explaining the 5 to 10 models I am explained, amma. Same model like how to solve this one, amma. This one plus or minus gamma. Here this one plus. But actually here is what is the P. This is the N, this is the P. So this diode is in reverse bias. In a reverse bias, no use. And this total term is leave it. This one plus or minus forward bias. Here minus or plus. And this positive key connected to the negative terminal and reverse bias. So this positive key positive and negative gamma. That's why it is the forward bias. This one is the forward bias, so this one is the forward bias. So these two are in a reverse bias. So these two terminals are removed. What is the remaining one? This is the only 4 ohm. This is the only 2 ohm. This is the battery 10 volts. Is asking the current. So these are the reverse bias. In case of the reverse bias, there is no current flow. That's why these two are is removed. Then what is the current, amma? First, these two are in parallel. What is the effective resistance? R1, R2 by R1 plus R2. 4 2s are 8, 4 plus 2 6, like 4 by 3. Therefore, I is equal to V by R effective. V value 10 ohm. Effective resistance 4 by 3 means into 3. Like 30 by 4, 15 by 2 amperes. 15 by 2 amperes. So this question is the given, amma, May 3rd exam, amma. Simple model, amma. Right. Now another one more example, amma. all of you try this model, amma. Note this model. All of you note this model, students, amma, in a rough notebook. Open the rough notebook and copy this model. All of you try this one. Again, same model. What is the current in the circuit? Same model, student. What is the current in the circuit? Copy that circuit, amma. Copy that circuit in a rough notebook. Here, one more value, 10 ohms. 10 ohms, 5, 10, 5, 20. Here I am 5 ohms. Here I am battery 9 volts. Is asking, find the current in the circuit. Like through battery started some current I ga. Battery now can start the some current I. What is the value of current? Is asking the what is the value of current? Right. How to solve this one? Now listen. This side I am plus amma. This side I am negative gara. Like this one I am plus. This one I am minus. Already we know that. Already here I am minus amma. This is the we can observe them diode ga. Diode lo straight line I am minus. This triangle shape I am plus. That's why I am plus side which terminal is there amma? Negative ga. And this is the reverse bias or forward bias? Reverse bias. That's why this total term is remove it. Next amma. In this side amma negative. Negative side what is that? Plus ega. Triangle ante plus ega. And negative ki plus. And again it is the reverse bias ga. This one is remove it. So these two diodes are in a reverse bias amma. That's why these two are is remove it. What is the remaining circuit amma? Current is started like this one. Like this. Here I am a reverse bias ga. There is no current ga. And directly passing through 10 ohm. Next, this is the reverse bias ga. No current ga. That current is passing through 5 ohm. That current passing through the 10 ohm and reaches to the battery negative. That's why what you are observing here. This one I am 10 ohm. After them passing through 5 ohm. After them passing through 10 ohm. So in the below diagram, this one I am 5 ohm. This one I am 9 volts. What is the current? So the equivalent circuit is like this. So 10 ohm, 5 ohm, 10 ohm and this 9 ohm in a closed loop all are in series. In a series, what is the effective resistance amma? 5 ohm plus 10 ohm, 15 ohm, 15 plus 5, 20, 20 plus 10, 30. What is the effective resistance? 30. Therefore, current I is equal to V by R effective. What is the voltage amma? 9. By what is the effective resistance? 30. So 3 table amma, 3 3s are, 3 10s are. So 0.3 amperes. 0.3 amperes. So this is this type of the model summa may be compulsory amma one possibility question. So right, note this summa. Same model ra. I am giving the one more one. After copy this one amma, all of you note this model. Five microfarad capacitor, 10 microfarad capacitor. Here I am 30 volts. Is asking find charge on each capacitor. Find charge on each capacitor. Find charge on each capacitor. Now one more model amma, important model. Here I am taking the resistor values amma. Here I am taking the resistor values. Sometimes is the given capacitors. That's why what is the charge on each capacitor? What is the charge on each capacitor? Note that for diagram. Take the rough notebook amma, compulsory you can copy the circuit amma, I will explain them and we can copy that one and one time we can practice on evening time. Compulsory amma, because of this semiconductors 3 questions are is given every year amma. So this year also given 3 questions. Maybe on coming exam re-NEET is also possibility minimum 3 questions. Same model amma. Re-NEET exam means whatever may be the given 45 questions, same model is repeat amma. So that's why same models means in the previous question amma resistors are given amma, sometimes amma capacitors are given, like that one amma. How to solve that one? So which one is the forward bias and reverse bias amma? This is the plus, so this is the minus amma, and this is the plus gara, and this side is the minus ga. This is the plus amma, this is the plus, and forward bias. This is the plus amma, here am minus, so this p type gara plus, and negative ki plus, positive ki negative, and reverse bias. So this is the reverse bias amma. So the diode is removed. This is the forward bias gamma. Current will be flow ga. Current will be flow means like one straight line we can take it. That's why what is the circuit amma? Here am 5. Like this is the straight line. This is the another one is 10. 10. Like this is the one. This is the battery. This is the 30 volts. Right. So what is asking amma? Charge on each capacitor. Charge on each capacitor. How to find them? These two are connected in a series or parallel amma? Series. These two are connected in a series. In a series lo charge value same. Already we know that. For a resistors current value same amma. In capacitors charge value same. So the charge on the first capacitor is equal to charge on the second capacitor. How to find that one? First these two are in series. In series, what is the effective capacitance? 1 by C is equal to 1 by C1 plus 1 by C2. Or C is equal to C1 C2 by C1 plus C2. 5 into 10 by 5 plus 10. 50 by 15. So 5 table amma 5 tens, so 5 threes. This is the effective capacitance. Effective capacitance. What is the charge amma? 30 volts. Therefore, charge Q is equal to CV. What is the value of C amma? 10 by 3 into, what is the voltage amma? 30. 3 10 times. 10 into 10, 100. So, 100 microcoulombs. This one 100 microcoulombs, this one also 100 microcoulombs. Because of these two are in series amma. In series amma, charge same. So charge on the first one is equal to charge on the second one. That value amma 100 microcoulombs. So one more model amma like this. So previous one amma resistors. Here amma capacitors. Model same amma. So forward bias we can forward bias take them wire. Reverse bias amma we can remove. Resistors form amma series amma R1 R2. Capacitors amma like C1 C2 by C1 plus C2. Like amma, this is the one of the important model. Now last model amma in this one. Here am 21 volts. Here am silicon. Five kilo ohms. This one is the silicon. This one is the germanium. That's why what is the current through 5 kilo ohm resistor? Find current through 5 kilo ohm resistor. Find the current through 5 kilo ohm resistor. One more model amma like. Actually in the previous problem amma we can use the diodes gamma diodes that are nothing but ideal diodes. That are nothing but ideal diodes. Ideal diodes amma in forward bias amma resistance emo 0. In reverse bias amma, resistance infinity. Resistance infinity ni gamma, that's why you can remove them. Forward bias lo diode is there gara. Zero resistance means like a wire. That is nothing but for ideal diodes. But here clearly given, they are the silicon and the germanium. So that's why these two are not ideal diodes. That type of the model how to solve the current. How to solve the current. Now listen carefully. Here 21 volts. So here it is not the ideal diode, silicon. This side plus and minus. Plus and minus. Here also plus and minus. Here also one resistor. This is the ground. This is the, what is that silicon. Already we know that for silicon what is the barrier voltage What is the barrier voltage? 0.7 volts. Already we know that. The barrier voltage of silicon is 0.7. For germanium 0.3. Very important points. For barrier voltage of silicon 0.7, for germanium 0.3. Right. So for in case of the ideal means take a one wire. But here silicon and germanium given for silicon 0.7, for germanium 0.3. That is the important point in this problem. How to solve that one Current is starting from high voltage to low voltage. Current is started I. This is the I. Already we know that current electricity problem. Here high voltage 21. Here battery charging. Here battery charging. In case of the charging minus 0.7. In case of charging minus 0.3. Here current I minus IR. 5 kilo means 10 Q is equal to what is that ground like 0. Ground connection like 0. This type of the models we can solve in current electricity. Like 21 minus these two values are adding minus 1 like 20. This value taken another side. I into 5 into 10 cube. 5 here how many times 4 times. So 4. This value take them in this side 10 power minus 3 milli. So 4 milliamperes. The current through the resistor is 4 milliamperes. Right, one of the important point is here. For example, here silicon and germanium is not given. In case of the not given means take them one straight wire. But clearly given silicon and germanium. For silicon barrier voltage 0.7, for germanium 0.3. That's why we can take them minus 0.7 or minus 0.3. In this problem, these points are the important. So copy this one of the important model. Right. Now one basic point. Now listen carefully. This is the battery. This is the battery. But here open. Here that one is open. Here 20 volts. Here 10 ohms. What is the voltage drop across AB? What is the voltage drop across AB? Is 0 na? Very good. Because of AB and open circuit here is the current is started In case of the closed circuit what happened current is started like flowing this one. In this one open circuit in open circuit current is not flowing. That's why here current value is equal to how much 0. What is the voltage drop across this one? V is equal to IR I value 0 and the voltage drop is equal to how much? 0. Because of there is no current flowing, what is the voltage drop across 10 ohm is 0 ne. But I am asking the voltage drop across AB. What is the voltage drop across AB? That is the one of the important point. That point is based, one question is given on May 3rd exam. Right. How to solve that one? Right, Amma. Now we can observe them. Here am VA. This one am VA. Now listen carefully. VA. Here am battery. Here am battery. Take them. VA like this one. Go to like this one. Assumption. Just assumption. Actually, positive to negative. But like this one. Like this, let us assume. VA, battery here charging minus 20. Next, here there is no current flowing. There is no current flowing. What is the drop? 0. That value, final value is equal to how much? VB. Therefore, VA minus VB is equal to how much? 20. That is the important point. So here, when your battery is there, here is open. Here is open. When open circuit is there, there is no current flowing is 0. That's where what is the voltage drop across AB? Here whatever may be the voltage is given, same voltage is there across A and B. This point is the given on 2026 May 3rd question. Now that model I will explain. Now that model is this is the AC source, here diode, here one resistor, here the positive pulse plus and minus like input voltage like this one. This is the resistor R, this is the diode, here A and this is the VD, voltage across the diode. So, in the given question, the options are VD is the given, clearly given VD. This is the T. First graph, second graph, third graph. This is the fourth graph. VD and time graph. VD, voltage across the diode and time graphs are is given like this. That's why which one is the correct? Now listen. Very, very important point is, for example, already we know that in a given question, sometimes is the given voltage across the resistor and time. First listen, this total options are is removed. First you can leave them. First, what is the voltage across the resistor? And like output voltage. Output voltage or voltage across the resistor, both are same. Right. This concept already we know that it is, how many diodes are there? Only one diode. Only one diode is nothing but full wave, half wave, like half wave rectifier. Right. First started, what is the positive pulse kadamma? Like positive pulse means this is the plus, so this is the minus. Plus, so this is the minus. This is the reverse bias, forward bias. Reverse bias. Reverse bias gamma, there is no current flow like 0. Next, negative pulse. Negative pulse ante minus plus. And this is the forward bias. Forward bias la current flowing like this. Next positive pulse like this one. Next negative pulse like this one. Already this model is over in our concept of full wave rectifier and half wave rectifier. Across the resistor, that's where this is the graph, important one. But in a given question, is asking the across the diode. Across the diode. Here this concept across the resistor. Already we know that. Here across the diode. That is the important one. Now listen carefully. First, what is the concept? First one, what is the started? Positive pulse. Ante plus minus plus minus. That's why this diode is forward bias or reverse bias. Already we know that reverse bias. In a reverse bias, what is the current flowing in the circuit? 0. Already we know that current flowing in the circuit is 0. That's why what is the voltage across the diode? This diagram is similar to like this. This diagram, total one is similar to this one. What are you observing? This diode, like this one AB. Here is resistor, amma. Here also resistor. Here is source, amma. Here also source. What is the voltage across AB? Amma? Open circuit. Open circuit, the voltage across AB is equal to 20. Because of there is no current flowing open circuit. Here also this diode in reverse bias. In a reverse bias, there is no current flowing. There is no current flowing. That's why what is the voltage across the diode? Whatever may be the voltage, same voltage is there across the diode. That's why what is the graph? Positive pulse. Because of 20 volts, here some voltage is given, positive pulse. Positive pulse. But in the reverse, and wrong, positive pulse. And for positive pulse, these three are correct. Next, what is the one is given? Negative pulse. Negative pulse. Negative pulse and minus plus minus plus minus plus is nothing but forward bias. Forward bias current is flowing. Current is flowing means current is flowing. In case of the current is flowing, they having the some voltage is ideal diode. For ideal diode means voltage drop 0 voltage drop is 0. Here some value is given wrong. Some value is given wrong. Is reverse gara totally wrong. So here value is not there and the correct one. So in case of the reverse bias like pulse is there in forward bias there is no voltage drop. I am explaining. In forward bias silicon and germanium are is given some drop is there. For ideal diode like a wire like a wire is nothing but what is the potential drop? 0 0 means like a straight line. That's why this is the correct one. So this point is the given on 2026 question. Important one. Now last point what is the another question is the given Now listen carefully. One more question is the given on two statements are given. Two statements are given. One is like voltage, current and voltage graph in forward bias like this one and reverse bias like this one right. When the forward biased voltage across the PN junction diode is increases above the certain threshold voltage, the current is increases significantly. Already we know that like this one graph. Certain voltage after certain voltage current value is linearly increases like the same point is given that is the correct one. At a certain threshold voltage the current value increases linearly, that is the correct one. This current is called reverse saturation current. This current is known as reverse saturation current, that is the wrong one. Reverse saturation current is known in reverse bias. In a reverse bias this current is known as reverse saturation current. But actually forward bias it is not reverse saturation current. That's why on the B statement wrong, A statement is the correct one. So that is the one of the important point. That three questions are given on the previous one. So important basic model set. These are all are nothing but current electricity model this one. So but is asking in semiconductors, right. Right, one example in forward bias and reverse bias, one example. Now listen carefully. Note this diagram. Again a possibility question This is the load resistor. Here input voltage is 10 sine 100 pi t. 100 pi t. Here 4 diodes are is connected. What is the frequency of the output voltage V0? Like this one. What is the frequency of the, is asking the load resistor amma, we take them output voltage. What is the frequency across the output voltage is asking like this one. First we can observe them amma. This circuit is the forward bias or reverse bias. First we can observe them forward bias or reverse bias. For example, this is the AC source. First we can start the positive pulse. Positive pulse and like this one plus, so this one minus. Plus and minus. Which one is the forward bias and reverse bias? Plus. And this is the plus. This is minus. Here is plus. This one is minus. Which one is the forward bias? This one is forward bias. This one is reverse bias. It is not working. Right. Plus. This one is minus. And reverse bias. These two are not working. What happens? Current is started passing through this one and through load resistor and passing through this one. That's why in a load resistor current is flowing. For a positive pulse current is flowing. For a negative pulse is started here minus. Here plus. Here minus this pulse. Which one is the forward bias or reverse bias? Minus and forward. Here plus and forward. These two diodes current flowing, these two diodes are not flowing. That's where what is the current flowing? Like this one. Like this one. So positive pulse is also current flowing through the load resistor. Negative pulse is also the current flowing through a load resistor. And both pulses is the rectified. Both pulses are rectified means full wave, half wave, full wave rectified. This is the full wave rectifier. In full wave rectifier, the input frequency is N. Input frequency is N. What is the output frequency? 2N. Now listen carefully. This is the one of the important point on the previous NEET question. Full wave rectifier, the input frequency is N, output frequency is 2N. Input frequency is N, output frequency is 2N. But it is the full wave rectifier. What is the frequency value? This is the, what is that? V is equal to V0 sin omega t. What is the value of omega value here? Omega value is 100 pi. Omega means 2 pi n. Omega is equal to pi n. Pi value cancel. Then what is the n value? 50. And the input frequency 50 Hz. That's why what is the output frequency? 2n ga? 2n means 100 Hz. So this is the answer. So the input frequency is 50, output frequency is 100 Hz. This is nothing but full wave rectifier. So this is the full wave rectifier, one of the important model. Now, same model, all of you try this one. Again, here also some source is there, that is the input voltage, 2 diodes are there, this is the load resistor, output voltage. What is the graph? What is the V0? What is the graph of V0 and time? What is the V0 and time? Same model, so same model like this one and this one both are same. Just circuit is the some little change. Now listen carefully. What is the pulse is started? Positive pulse. Positive pulse ante plus and minus. Plus and minus lo which one is the forward bias, reverse bias? This is the plus, this is the plus. What happened? Plus and plus gara forward bias. Here minus and plus gamma reverse bias. And the current is not flowing like this. And the current is flowing like this one. Positive 2, high potential 2, low potential means 0 ga. That's why the current is only flowing through a load resistor. And for positive pulse, current is flowing through a load resistor ga, like positive pulse. The pulse is like this one. Similarly, negative pulse, and here minus, this one plus ga. Here negative and here negative, this one positive, and is reverse bias. Here plus and forward bias. Now again current is flowing like this one, and a negative pulse is also a current flowing through a load resistor ga. That's why a negative pulse is also rectified ga, like this one. Again positive pulse, again negative pulse, like because of it is a full wave rectifier. It is a full wave rectifier. So that is the one of the model amma, same like this. So one question is the given on possibility of the full wave rectifier and half wave rectifier. For full wave rectifier amma, input frequency is NO, output frequency is 2N. For half wave rectifier, input frequency is NO, output is also NO. Input frequency is NO, output frequency is also NO. Because in full wave rectifier amma, two positive and a negative both pulses are is rectified. That's why the frequency is 2N. In half wave rectifier only one pulse is rectified. That's why the input and output both are same. So that is another important model, right? Not this one amma. That is another important model. Just note them on rough notebook. Next, one more last model. Here, one source is there. Here, Zener diode. This one is 1 kilo ohm. This one is 2 kilo ohm. Here, 50 volts. Here, 100 volts. That's why what is the value of IZ? What is the current flowing through the Zener diode? What is the current flowing through the Zener diode? Like simple model. Now listen carefully. This is the Zener diode is offers the 50 volts already clearly is given. This Zener diode and a load resistor both are parallel. Parallel means here 50 volts means here also 50 volts. Here also 50 volts. Overall in this one 50 volts is over. Total is how much 100. In 100 50 volts is over. What is the remaining Here also 50. Here also 50. For example here 30 and here also 30. 30 and 30 both are parallel voltage same and here 70. Okay but here 50 here also 50 both are parallel voltage same What is the remaining voltage? 50. Current is started I current is reaches to the junction. Here IZ, here IL, load resistor. That's why the total current I is equal to IZ plus IL. The total current I is equal to IL plus IZ per the Kirchhoff's first law. Right. First, how to find the IL, load resistor. Voltage and resistor value given and I is equal to V by R V by R value 2 kilo. Kilo means 10 cube. How much value? 25. 10 power minus 3 ante milli. 10 power minus 3 like milli. So here IL value you can complete. Next, what is the value of IM? Now again I is equal to V by R V by R. What is the voltage 50. By R value 1 kilo. 1 kilo. That is equal to 50, 10 power minus 3, take the numerator milli and 50 milliamperes. So IL value and I value, both values are came like this one. IZ is equal to I minus IL. I value 50 minus IL value 25. We get 25 milliamperes. So this is the one of the important model of previous question. So important model. Sometimes previous question. Here is a 50 volts is there gamma. What is the voltage across the load resistor? That is the one question. What is the voltage across the load resistor? Again 50 nega. Because of these two are parallel, voltage value same. That's where 50. That is the given one previous question. Okay. So sometimes the IZ value is asking like this model. Okay. Right. So remaining models we can try it right. So on tomorrow class, Friday and Saturday, on 2 days ray optics topic. So on ray optics lo, on tomorrow class lo, lenses and refraction on the plane surface. That are two models. One day name prism and optical instruments. Okay, on next class continue amma. Thank you.
Good morning, dear students. Today I will explain two more important critical concepts regarding human health and diseases. Human health and diseases. Yeah, from this chapter I will explain first one about drugs and second topic cancer. So first we will try to understand about drugs because recently in 2026 May question paper also we got a question from the topic drugs and their effects. Okay. First of all, what is drug abuse? Drug abuse means when a people are taken drugs for a purpose other than medicinal use. If the drugs are used for medicinal purpose, it is not bad, it is good only. So when people will consume, will intake a drugs for a purpose of other than medicinal use, that leads to impairment of either physical, physiological, psychological functions will be affected. So that all together constitute as a drug abuse. Then what are some generally abused drugs in the society? Means number one, opioids. First one, opioids. Here opioids are one type of drugs. Opioids are a type of drugs whenever the people will consume, will intake these opioid drugs, they will directly go and binds to the specific opioid receptors present in two places of our body. One is central nervous system, second one is gastrointestinal tract. See, for every medicine, for every drug, for every substance, a specialized unique receptors are present in our body. So ನಾವು ಏನು ಸಬ್ಸ್ಟೆನ್ಸ್ ತಗೊಂತೀರಿ ಅನ್ನೋದ್ರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಮಾಡಿಕೊಂಡು ಆ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಆ ಸ್ಪೆಸಿಫಿಕ್ ರೆಸೆಪ್ಟಾರ್ಸ್ಗೆ ಮಾತ್ರ ಹೋಗಿ ಬೈಂಡ್ ಆಗಿಬಿಟ್ಟು ಅದ್ರ ಫಂಕ್ಷನ್ನ ಪರ್ಫಾರ್ಮ್ ಮಾಡುತ್ತೆ. ಸೇಮ್ ಹಿಯರ್ ಆಲ್ಸೋ ವಾಟ್ ಆರ್ ಒಪಿಯಾಯ್ಡ್ಸ್ ಮೀನ್ಸ್ ಒಪಿಯಾಯ್ಡ್ಸ್ ಆರ್ ನಥಿಂಗ್ ಬಟ್ drugs, a kind of drugs. These drugs will go and binds to the specific opioid receptors. Opioid receptors present in two places. One is central nervous system, second one is gut, gastrointestinal tract. That means the people who can take these opioid drugs, these opioid drugs directly will go and binds to the specific receptors, specific opioid receptors. Opioids ಗೋಸ್ಕರ ಮಾತ್ರನೇ ಈ ರೆಸೆಪ್ಟಾರ್ಸ್ ಇರುತ್ತೆ. ಎಲ್ಲಿ? ಇನ್ ದ CNS and gastrointestinal tract, and after binding there they will show their effect in that particular person. Is it clear? Such type of drugs are collectively known as opioid drugs, we call it. So what are opioids means? Opioids are the drugs which are binds to the, which are interact with the specific opioid receptors present in the central nervous system and gastrointestinal tract. Gastrointestinal tract are collectively known as opioid drugs. Then what are the examples for opioid drugs? Some examples for opioid drugs. Number 1, morphine. Morphine is one of the opioid drug. And number 2, heroin. Heroin is also one of the opioid drug, etc. So what are the examples for opioid drugs means one is morphine and second one is heroin. Morphine and heroin both comes under the what type of drugs ma? Opioid drugs. These morphine and heroin drugs, when the people will abuse these drugs, will directly go and binds to the specific receptors present in the CNS and gut and they will perform their action. Understand? And first when we will talk about morphine, the drug morphine. Here morphine is a useful drug. It is a useful drug. Morphine is a useful drug. In what purpose the morphine drug is used means it is used as a painkiller, sedative and good sedative and painkiller. So morphine drug is generally used as a sedative and also painkiller during surgery, any kind of surgery in the patients to give reliefness against the pain and used like an anesthesia. Okay, so that's what morphine is not a harmful drug, it is a useful drug only. Morphine is one of the opioid, but it is used as a good sedative and painkiller during surgery. Hence it is called as a useful drug. Understand? And come to the second one, heroin. Before knowing about heroin, first of all, how that this morphine drug is obtained. How the morphine drug is obtained means morphine drug is obtained from latex, from the latex of poppy plant. Which plant ma? Latex of poppy plant. A white color milk like substance secreted, released from the poppy plant, scientifically known as Papaver somniferum. Papaver somniferum. Papaver is a genus name. Somniferum is a species name. Somniferum is a species name. So now tell me, opioid drugs means what? Morphine and heroin. In that especially, first we will extract a morphine drug. How a morphine drug is obtained means from the latex of poppy plant, scientifically known as Papaver somniferum. From this plant latex we prepare a morphine drug. You understand that? Okay. So after obtaining morphine, from the morphine we will prepare heroin. So now I am going to explain heroin. Here about heroin. First one, heroin is commonly known as smack. Heroin is commonly known as what ma? Smack. That means it give instant reflexes, instant effectiveness, hence we call it a smack. And chemically, heroin is chemically called as, heroin is chemically known as diacetyl morphine. Diacetyl morphine. That means heroin drug is obtained from acetylation of morphine drug. So when we do acetylation of morphine, as a result we get heroin. So heroin drug is obtained from the acetylation of morphine. That means simply we can say that what is heroin, chemically what it is made up of andre, very simple. So acetylation of morphine in the heroin form agutte andre, then heroin is nothing but diacetyl morphine. Two acetyl groups of morphine is nothing but heroin drug we call it. Then how it look like? What is the nature of heroin? Means this heroin will be look like white in color and also odorless. Odorless means what? It do not give any proper specific smell, okay, and also bitter crystalline compound. Yeah, bitter crystalline compound. It look like sugar particles. It look like a crystal forms. Sugar particles ಯಾವ ತರ ಇರುತ್ತೆ ಅದೇ ತರನೇ ಈ heroin drug ಅನ್ನೋದು ಇರುತ್ತೆ. So heroin is white color, powder like structure, it is odorless, do not give any specific flavor or smell, and also it is bitter, a crystalline compound structure, we can define it. Understand? Then this type of heroin drug, how can the people will abuse, will consume, the mode of intake andre one is by the snorting or injection, through injection or by snorting process they will intake this drug. Okay ma? I repeat once again, the heroin drug is abused by two methods, either by the snorting, okay, and and even injection also, through injection also they will take. Then what purpose they will take heroin? You know, heroin is one of the harmful drug. Why? Because when the people will consume, when the people will abuse, it will act as depressant. It causes depression in the particular individuals, and also slow down the body functions. These two events are not good for the persons. So absolutely intake of heroin is not good. It is harmful drug because it acts as depressant and slow down the body function. So what are the effects of heroin drug? Means number one, it acts as depressant and also slow down the body functions. Hence heroin is called harmful drug. Remember dear students, So, opioids are nothing but a type of drugs like morphine and heroin. When these drugs are abused by the people, these drugs will directly go and binds to the which receptors? Specific opioid receptors. Where specific opioid receptors present in our body? At one place, central nervous system. Second one, at gastrointestinal tract. Is it clear? First one, morphine. Morphine is a useful drug or a harmful drug? It is a useful drug. Why? Because it do not cause us any harm. It is used as a good sedative and painkiller during surgery patients. So, it is absolutely useful drug. Then, how can we obtain this morphine drug? Means from the latex of poppy plant. Common name is poppy plant. Scientific name is Papaver somniferum. So, ಈ Papaver somniferum ಅನ್ನೋ ಪ್ಲಾಂಟ್ ಲೇಟೆಕ್ಸ್ ಇಂದ ಈ ಮಾರ್ಫಿನ್ ಡ್ರಗ್ ನ ಪ್ರಿಪೇರ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ದಟ್ ಈಸ್ ಅಬೌಟ್ ಮಾರ್ಫಿನ್. ದೆನ್ ಕಮ್ ಟು ದ ಹೆರಾಯಿನ್. Heroin is commonly known as smack because of their high stimulant, effective stimulation. And second one, this heroin is chemically what it made up of means diacetyl morphine. Why? Because the heroin drug is obtained by the acetylation of morphine drug, hence it is chemically diacetyl morphine. And also it is white, odorless and bitter crystalline compound structure, and it is generally taken by the snorting, either through injection they will take it, and it acts as depressant and also slow down the body function. So, it is absolutely harmful drug. You got it, ma? So, this is about first drug, opioids. Clear? And the second drug is cannabinoids. Another drug is called cannabinoids. Here cannabinoids also not a single drug. Opioids means not one drug, ma. A group of drugs like morphine, heroin, brown sugar, so called. Similarly, cannabinoids also not one drug. It is a group of chemicals. What are cannabinoids? A group of chemicals. Then for these cannabinoid chemicals, cannabinoid group of chemicals also, there is one specific type of receptors in our body. So, whenever the people will consume or people will abuse these cannabinoid drugs, these cannabinoid drugs will go and interact or will go and binds with the specific cannabinoid receptors present in the brain of an individual. So, these cannabinoid drugs also will go and binds with the receptors, specific cannabinoid receptors present in the brain region. So, a group of chemicals which go and binds to the specific cannabinoid receptors. Where they present, ma? Present in the brain. So, cannabinoid receptors present in the brain, opioid receptors present in the central nervous system and gastrointestinal tract. ಯಾವ ಡ್ರಗ್ಸ್ ಎಲ್ಲೋಗ್ಬಿಟ್ಟು ಬೈಂಡ್ ಆಗುತ್ತೆ ಅನ್ನೋದ್ರ ಮೇಲೆ ಆ ಡ್ರಗ್ ಎಫೆಕ್ಟ್ಸ್ ಡಿಪೆಂಡ್ಸ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಸಿಮಿಲರ್ಲಿ here also what are cannabinoids means cannabinoids are the group of drugs or a group of chemicals which go and interact or which go and binds with the specific cannabinoid receptors present in the brain only. Such type of a group of chemicals or drugs are collectively known as cannabinoids ಅಂತ ಕರೀತಾರೆ. ಓಕೆಮಾ? ಮತ್ತೆ ಈ cannabinoid drugs ಅನ್ನೋದು ಯಾವ ಪ್ಲಾಂಟ್ ಇಂದ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತೀರಿ? ವಾಟ್ ಈಸ್ ದ ಸೋರ್ಸ್ ಆಫ್ cannabinoid drugs? What is the source of cannabinoid drugs? Cannabinoid drugs are obtained from a plant name is called cannabis sativa. What is the plant name? Cannabis sativa, the commonly known as Indian hemp plant. Then which part of the cannabis sativa plant it will give cannabinoids means inflorescence of Indian hemp plant, scientifically known as cannabis sativa. Cannabis is a genus name, sativa is the species name. So I repeat once again, dear students, cannabinoid drugs are obtained from which plant andre? So inflorescence or floral part of the Indian hemp plant name called cannabis sativa. Cannabis sativa ಅನ್ನೋ ಪ್ಲಾಂಟ್ ಇನ್ಫ್ಲೋರಸೆನ್ಸ್ ಇಂದ ಈ ಡ್ರಗ್ಸ್ ನ ಅಬ್ಟೈನ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಅಂಡ್ ದೆನ್ ಎಸ್ಪೆಷಲಿ ಫ್ರಮ್ ದಿಸ್ cannabis sativa plant, like you can take floral tops or flower tops and also leaves and also resins. Resins means, dear students, a gum like substance secreted from the cannabis sativa plants. You normally ಈ ಕೆಲವು ಪ್ಲಾಂಟ್ಸ್ ಅಲ್ಲಿ ಲೈಕ್ ಅಕೇಶಿಯಾ ಪ್ಲಾಂಟ್ ಲೈಕ್ ಜಾಲಿ ಮರ ಅಂತಾರಲ್ವಾ, ಸೊ ಈ ಥರ ಮರಗಳಿಗೆ ಒಂಥರ ಗಮ್ ಲೈಕ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಊಸಸ್ ಔಟ್ ಆಗಿರುತ್ತೆ. ಓಕೆ, ಸೊ ಅ ಕೈಂಡ್ ಆಫ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಈಸ್ ಕಾಲ್ಡ್ ರೆಸಿನ್ಸ್. ದೀಸ್ ರೆಸಿನ್ಸ್ ಆಗಿರ್ಬೋದು, ಆರ್ ಫ್ರಮ್ ದ ಲೀವ್ಸ್ ಆಗಿರ್ಬೋದು, ಆರ್ ಫ್ರಮ್ ದ ಫ್ಲೋರಲ್ ಟಾಪ್ಸ್ ಆಫ್ cannabis plant in various combinations. We can produce different types of cannabinoid drugs. Among them, number 1, marijuana. Number 2, hashish. Number 3, kharas. Number 4, ganja. Dear students, examples for cannabinoid drugs: marijuana, hashish, kharas, ganja. These are the types of cannabinoid drugs. How these types of cannabinoid drugs we obtained means from the various combinations of flower tops and leaves and resins of cannabis plant. ಈ 3 parts, flower tops ಇಂದ ಆಗಿರ್ಬೋದು, leaves ಇಂದ ಆಗಿರ್ಬೋದು, resins, various combinations, 2 combinations, 3 combinations, ಈ ಥರ ಡಿಫರೆಂಟ್ ಕಾಂಬಿನೇಷನ್ಸ್ ಯೂಸ್ ಮಾಡಿ ಈ ಥರ ವೆರೈಟಿ ಆಫ್ cannabinoid ಡ್ರಗ್ಸ್ನ ಅಬ್ಟೈನ್ ಮಾಡ್ತಾರೆ. ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾ? ದೆನ್ ವಾಟ್ ಆರ್ ದ ಎಫೆಕ್ಟ್ಸ್ ಆಫ್ ದಿಸ್ cannabinoid drugs? If the people will consume, will abuse, will intake these cannabinoid drugs, what will happen means they will effects on cardiovascular system. Their effects on the cardiovascular system. That means these drugs will affect on the heart functions. So cardiovascular system mele idi effect madutte. This is one of the major effect from the cannabinoid drugs. So these cannabinoid drugs are recently present days many sports persons are abused. Very important. Very important. Okay. So present days alli which drug is abused by the half only by the sports persons andre cannabinoids. So the drug cannabinoids are abused by sports persons. Remaining drugs are also abused, but especially recently cannabinoid drugs are abused by the sports persons. You know, when the sports persons will abuse such type of drugs like cannabinoids agirbodu, some other drugs agirbodu like analgesic, narcotic analgesics, diuretics and anabolic steroids, ಈ ಥರ ಡಿಫ್ರೆಂಟ್ ಡ್ರಗ್ಸ್ ಈ ಸ್ಪೋರ್ಟ್ಸ್ ಪರ್ಸನ್ಸ್ ಅಬ್ಯೂಸ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ. ಏನಕ್ಕೋಸ್ಕರ ಅಂದರೆ, ಸೊ ಬೈ ಟೇಕಿಂಗ್ ದೀಸ್ ಡ್ರಗ್ಸ್ ಇನ್ ಸ್ಪೋರ್ಟ್ಸ್ ಪರ್ಸನ್ಸ್ increases muscle strength, one benefit. Second one, it will promotes aggressiveness in the game, in the athlete. Okay, so aggressiveness na tagobarutte, and also it will improves and increases overall athlete performance. Okay, normal athlete inda agdiro activities ಈ ಡ್ರಗ್ ಅಬ್ಯೂಸ್ ಮಾಡಿರೋ ಪರ್ಸನ್ನು ಅಬ್ನಾರ್ಮಲ್ ಆಗಿ ಆಟ ಆಡ್ತಾರೆ. ಅಂದರೆ ಬೇಗ ಸುಸ್ತಾಗ್ದಿರ ಹೈ ಎನರ್ಜಿ ಲೆವೆಲ್ಸಿಂದ ಜಾಸ್ತಿ ಹೊತ್ತು ಎಫೆಕ್ಟಿವ್ ಆಗಿ ಆ ಆಟ ಆಡೋದಕ್ಕೆ, ಆ ಪರ್ಫಾರ್ಮೆನ್ಸ್ನ ಇನ್ಕ್ರೀಸ್ ಮಾಡೋದಕ್ಕೆ ಈ ಡ್ರಗ್ಸ್ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. ಅದಕ್ಕೆ ಆಫನ್ಲಿ ಸಮ್ ಸ್ಪೋರ್ಟ್ಸ್ ಪರ್ಸನ್ಸ್ ಅಬ್ಯೂಸ್ಡ್ ಸಚ್ ಕೈಂಡ್ ಆಫ್ ಡ್ರಗ್ಸ್. ಓಕೆಮಾ, ಸೊ ಬಿ ಕೇರ್ಫುಲ್. What is the effect of cannabinoid drugs ma? It will affect on the cardiovascular system. And which drug is recently abused by the sports persons? Cannabinoid drugs. Cannabinoid receptors present in which part of our body? The brain region. Give me some examples for cannabinoid drugs. Marijuana, hashish, karas, ganja. How these different types of cannabinoid drugs are obtained? By the various combinations of flower tops, leaves and resins of cannabis plant. And tell me, cannabinoid drugs are obtained from which plant? Inflorescence of Indian hemp plant name called cannabis sativa. So this is the second drug commonly abused by the peoples. Understand ma? Yeah. And the next drug is third one, cocaine, also known as coca alkaloid. Tomorrow I will not take class ma, so called today I was taken Srinivas sir class. Okay, yeah. So cocaine and coca alkaloids. Here cocaine and coca alkaloids are obtained obtained from a plant name called coca plant. Coca plant is the common name. Coca plant is a common name, and the scientific name of the coca plant is Erythroxylum coca. What is the plant? We obtained from this plant, we obtained cocaine ma? Erythroxylum coca. So coca alkaloids or cocaine drug is obtained from coca plant. Coca plant scientific name Erythroxylum coca. Erythroxylum is the genus name, coca is the species name. Erythroxylum coca ಅನ್ನೋ ಪ್ಲಾಂಟ್ ಇಂದ ಈ ಕೊಕೈನ್ ಆರ್ ಕೋಕಾ ಆಲ್ಕಲೈಡ್ ಅನ್ನೋ ಡ್ರಗ್ ನ ಎಕ್ಸ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಾರೆ, ಅಬ್ಟೈನ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ದೆನ್ ದಿಸ್ ಕೊಕೈನ್ ಈಸ್ commonly called as, commonly known as coke or crack. Coke or crack, because the people who will abuse this drug will behave like this. Okay, so commonly we use the term coke, and the people who will abuse and intake this drug will behave like a crack. Okay, so they are in the euphoria mode, and they lost sense of reality. Okay, in such conditions ಅಲ್ಲಿ ಇರ್ತಾರೆ ಅವರು, ಅದಕ್ಕೆ ಇದನ್ನ coke or crack ಅಂತನೂ ಕರೀತಾರೆ. Okay, so the coca alkaloid or cocaine is obtained from the plant, coca plant name called what ma? Erythroxylum coca. Erythroxylum coca is commonly known as what ma? Coke or crack anta karitare. Then what are the effects of this coca plant? Coca alkaloid ಈ ಡ್ರಗ್ನ ಅಬ್ಯೂಸ್ ಮಾಡಿದ್ರೆ ಹ್ಯೂಮನ್ಸ್ ಅಲ್ಲಿ ಬರೋ ಎಫೆಕ್ಟ್ಸ್ ಏನು ನೋಡೋಣ. ಎಫೆಕ್ಟ್ಸ್, ಫಸ್ಟ್ ಒನ್, you know the cocaine is interferes with the transport of neurotransmitter dopamine. Dopamine is one of the neurotransmitter. It helps to transfer of impulses, nerve impulses from neuron to the muscle. Like you can recall acetylcholine during mechanism of muscle contraction. So acetylcholine plays very important role in the transmission of impulses from between neuron to muscle, that is called neuromuscular junction. Is it clear ma? It acts as neurotransmitters, andre neurons inda bandiro information na next part ge, next muscles ge transmit ಮಾಡೋದ್ರಲ್ಲಿ ಈ ಕೆಮಿಕಲ್ಸ್ ತುಂಬ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್ ಪ್ಲೇ ಮಾಡುತ್ತೆ. ಸೊ ಸೇಮ್ ಹಿಯರ್ ಆಲ್ಸೋ ಡೋಪಮೈನ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ದ ನ್ಯೂರೋಟ್ರಾನ್ಸ್ಮಿಟರ್ಸ್. In the activity, in the functions of neurotransmitter dopamine, this cocaine drug is interferes, ಅಂದರೆ ಅದ್ರ ಕೆಲಸ ಮಾಡಿದ್ರೆ ಸ್ಟಾಪ್ ಮಾಡುತ್ತೆ. ಅವಾಗ ಏನಾಗ್ತಾರೆ, ಪರ್ಸನ್ಸ್ ಅಲ್ಲಿ ಲಾಸ್ ಆಫ್ ಸೆನ್ಸ್ ಆಗುತ್ತೆ. ಐ ಮೀನ್ ದೇ ಕಾಂಟ್ ಏಬಲ್ ಟು ರೆಸ್ಪಾಂಡ್ to any kind of stimuli. Okay, yeah. So here first effect, cocaine, it interferes with transport of neurotransmitter name what ma? ಡೋಪಮೈನ್ ಅಂದರೆ ನ್ಯೂರೋ ಟ್ರಾನ್ಸ್ಮಿಟರ್ ಡೋಪಮೈನ್ ಮಾಡೋ ಕೆಲಸಗಳಲ್ಲಿ ಅದು ಟ್ರಾನ್ಸ್ಪೋರ್ಟೇಷನ್ಗೆ ಆಟಂಕವಾಗಿ ಇದಕ್ಕೆ ಅಡ್ಡ ಬರುತ್ತೆ. ಯಾವುದು? ಕೊಕೈನ್ ಡ್ರಗ್ ಅನ್ನೋದು. ಅದರಿಂದ ಸೊ ಡೋಪಮೈನ್ ಕೆನಾಟ್ ಏಬಲ್ ಟು ಡೂ their functions. This is one of the disadvantage or effect of the cocaine. Okay? And the second one is cocaine has potent stimulating effects on CNS, central nervous system. Cocaine has potent stimulating effect on the central nervous system. So, potent stimulation means it is a very high, it acts as very high stimulant on the central nervous system. right. Sorry for the interruption ma, small technical issues, the voice ಕೇಳಿಸಲಿ ಅಂತ ಗೊತ್ತಾಯಿತು. ಸೊ ಇಲ್ಲಿಂದ ನಾನು ಮತ್ತೆ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ತೀನಿ ನೋಡ್ರಿ ಒಂದ್ಸತಿ. ಸೊ ಹಿಯರ್ ಎಫೆಕ್ಟ್ಸ್ ಆಫ್ ಕೊಕೈನ್, ಫಸ್ಟ್ ಒನ್, cocaine interferes with the transport of neurotransmitters dopamine. So dopamine functionally cocaine interfere ಆಗೋದ್ರಿಂದ dopamine cannot transfer the impulses from neuron to muscle, leads to loss of sense. Next second effect, cocaine is having potent stimulating effect on the central nervous system, okay. And the third effect, cocaine causes sense of euphoria and increased energy. Sense of euphoria means it will create temporary feeling of happiness and also increased energy levels in the person who abused cocaine drug. And next one, excess doses of cocaine. When the people will abuse, excess dose leads to causes hallucination. Hallucination means they lost the sense of reality, they are in the false world. So such type of hallucination containing some other plants along with erythroxylum coca, number one Atropa belladonna and second one is datura. So Atropa belladonna, datura and even erythroxylum coca, these three plants will produce hallucination property drugs. Clear ma? And then come to the tobacco. So tobacco is another type of drug which has been used by the human beings since 400 years, and the tobacco is obtained from the plant name called Nicotiana tobaccum. Nicotiana tobaccum plant will produces tobacco. Tobacco contain a specific chemical called nicotine. This nicotine causes different types of effects, like suppose if the people will smoke a tobacco, that nicotine may causes lung cancer or urinary bladder cancer or emphysema and also bronchitis, CAD, congenital heart diseases and also gastric ulcers also. And when the people snuffed tobacco, it will causes oral cavity cancer. And when the people smoking tobacco will increases carbon monoxide content in the blood. So this carbon monoxide compete with the oxygen to the binding of hemoglobin. As a result, carbon monoxide 200 to 250 times higher affinity is having towards the hemoglobin when compared to the oxygen. So called carbon monoxide more binds to the hemoglobin. As a result, oxyhemoglobin percentage will be decreased. If oxyhemoglobin percentage is decreased, less supply of oxygen to the body, nothing but hypoxia we can see it. And also whenever these smoking done by the people, in such kind of people, the smoking contain nicotine. This nicotine will go and acts on the stimulates the adrenal gland to secretes two hormones, epinephrine and norepinephrine hormone. This epinephrine and norepinephrine hormone both will increases the heart rate, both will increases the rate of respiration and even cardiac output also, okay. So these are the major drugs. Remember carefully the drugs and their effect. Along with these, barbiturates, amphetamines, benzodiazepines, combinations of these drugs also use it to treat mental illness like insomnia and also depression patients, okay. And in the next class we'll continue a cancer topic, okay. Thank you. తిట్టుకుంటారమ్మ పిల్లలని.
right? Good morning all of you, amma. Right. Today, now I am going to start the hydrocarbons part. Already yesterday we discussed some part. Now remaining part I am going to discuss. Again same as it is yesterday what we have done, like that only we have to do now. So again alkynes and benzene chapter, what are the important concepts are they, how they are asking the questions, like that only I will ask now, I will write on the board, then we have to do some questions now simultaneously, observe clearly. First one of the method is what? From calcium carbide, this is called calcium carbide. Calcium carbide and hydrolysis, adding of water, then what I can get the product. What I can get the product means here, how many carbons are there? 2 carbons are there. These 2 carbons are using, these 2 carbons if we take 2 hydrogens, you will get C2H2, remaining calcium with remaining hydrogens and water, oxygen molecule will combine to form calcium hydroxide. This is called our byproduct. Our requirement product is this one. What is this? C2H2. That is called ethene. That is called ethane, not ethene. That is called ethane. That is also called acetylene. Acetylene. Sometimes they will say the common name. That also you have to know. Ethane also called acetylene. Next one, very very important. Next one, observe here. I am taking this one, that is called ethyl chloride, also called chloroethane. Is reacting with alcoholic KOH. What is the use of the alcoholic KOH? This role you should know first. Alcoholic KOH is dehydrohalogenation, that is called dehydrohalogenating agent. Dehydrohalogenating means, D means removal. Removal means that is called compulsory elimination. Elimination means most of in our syllabus that is called beta elimination. Observe here, beta elimination. This is called substituent. Substituent attached first carbon is called alpha. The next carbon is called what? Beta. Hydrogen atom is eliminated from beta carbon. Halogen atom is eliminated from alpha carbon. So main role is your hydrogen atom. Hydrogen atom is eliminated from beta carbon, that is called beta elimination. Then what I can get the product? CH2 double bond CH2, that is called what? Alkene. This is alkene. Observe here. So what happened here? Very very important point here. That is I am getting alkene. Okay. So why I am getting alkene? Hydrogen atom is eliminated from which carbon? Beta carbon. Halogen atom from which carbon? That is called alpha carbon. So this is alpha also you are removing, beta also you are removing. So main role is which one? Beta. That's why hydrogen atom is eliminated from beta carbon. That's why this is called as beta elimination. You are getting what? Alkene. Right. Next. Some other point observe here. I am taking this one. What is this? 1,2 dichloroethane. That is also called geminal or vicinal. This is called vicinal dihalide. 2 halogens are adjacent to each other. That's why that is called vicinal dihalide. This is treating with, first one, treatment with alcoholic KOH. Same role, alcoholic KOH, what is the role here? Dehydrohalogenation. Dehydrohalogenation means what you call elimination. That is what, which elimination? Beta elimination. Same. In these two, any one carbon is alpha. For example, this is alpha, this is beta. Sir, why sir this is alpha? I will consider alpha this one. Okay, you can, this is called alpha, this is beta. And again, what you have to remove? Hydrogen from here, halogen from here. Then what I can get? CH2 double bond, CHCl double bond with CH2. Halogen from here, hydrogen from here. So I am getting, this is the intermediate product that is called vinyl This is called vinyl halide, that is called vinyl chloride. Already you know, vinyl is highly unstable. That's why to get stability, it is again reacting with another mole of alcoholic KOH. Otherwise, you can use this one also. What this one? What do you call this one? Sodamide. NaNH2. That is called sodamide. Sodamide use also same thing, same role as alcoholic KOH. What the role? Sodamide role is dehydrohalogenating agent only. That's what. Again, dehydrohalogenating means beta elimination only. Now in this, which one is alpha? This is called alpha. This is called beta. Hydrogen from beta, halogen from alpha carbon. Then what I am getting now? CH triple bond CH. This is our requirement product. Our requirement product is called alkyne. That is called ethine. That is also called acetylene. This is another one. Another method of preparation of ethine. Next one. Some other questions. I am taking this one very important. Observe here. CH3, C triple bond CH. That is called one of the property. That is called prop-1-ine, otherwise propine. Addition of HBr. Addition of HBr. Yesterday I told. This is called symmetrical or unsymmetrical. That is called unsymmetrical only. Unsymmetrical alkyne here. There yesterday I told unsymmetrical alkene. Unsymmetrical alkyne addition of HBr follows which rule? Markovnikov's rule. Markovnikov's rule. Why Markovnikov rule means already I told yesterday, that is based on addition reaction totally based on intermediate. Intermediate, which intermediate is from carbocation. So based on stability of carbocation, which one is the major product, which one is the minor product, I told yesterday. Same like this as it is. Now here HBr addition, it follows Markovnikov rule. Markovnikov rule means negative part where we have to add carbon containing less number of hydrogens. Observe here. So one bond I removed, that C double bond CH. Here middle carbon I have to add Br because carbon contain less number of hydrogen. Here I have to add hydrogen. So what I am getting now? This one, that is called 2-bromo, 1, 2, 3, 1 to the 2-bromo prop-1-ene. This is the one of the product. So in this is one of the product is, it is somewhat unstable. So again it is reacting with another mole of HBr. Another mole of HBr. Another mole of HBr means here also same thing. Another mole of HBr means are again here H plus and Br minus is forms are. Here where we have to attach the Br, same as it is. First bromine atom where we are attached, there only we have to attach the next bromine also. Why? Observe clearly. CH3, that means here this is called electrophilic addition reaction. That means intermediate is carbocation. Here two possibilities are there. Bond is shifting like this, bond is shifting like this. Two possibilities. Bond is shifting like this means one time you are getting here carbocation. That means CH2Br. Now here intermediate. Two possibilities. Two possibilities means what is that now? Bond is shifting, bond is shifting. Two possibilities are because this is unsymmetrical alkene. Second mole of HBr means second equivalent. Second equivalent of HBr means Br where we have to add. That is the purpose I am saying to you. So here, in case of this one, in this case, first case here carbon getting positive charge, here also carbon getting positive charge. In these two carbons, two products, which one is the more stable? Because this is secondary carbocation, it is primary carbocation. In the secondary and primary carbocation, which carbocation is more stable? Secondary carbocation is more stable. That's why this is called more stable intermediate. More stable intermediate is major product. That means second mole of HBr means second mole of Br where we have to attach. Where we have to attach means where the intermediate is more stable, there only we have to add. That means observe clearly CH3, C, Br, here also Br. Then next what I can get here, hydrogen you have to add, what I can get, CH3. This is the major product, other one also you will get it, you wait, CH3, C, Br, here CH2 Br here hydrogen. Observe now here. This the product is 1, 2, 3. 2, 2 dibromopropane. This is called 1, 2 dibromopropane. Two products are formed here. This which one is the major product? This one is the major product. That means what is the observation here? Clearly, in this first mole, first equivalent of HBr, bromine where we are added, which carbon having the less number of hydrogen, there only we have to add. Based on which rule? Markovnikov rule. Second mole of HBr also where we have to add? First bromine where I added, second bromine also there only I added. That's so it is the major product. I told you clearly. Why means this is the explanation, because in case this is secondary carbocation, in case of this one primary carbocation, which carbocation is more stable? Secondary carbocation is more stable than primary. That's why intermediate is carbocation, more stable intermediate is the major product. That's why it is the major product. It is the main product is formed. Compared this is the major amount. This is the minimum amount, means minor amount, minor product. So in these two products, major one, this one only. So finally, final product is this one only. Observe clearly. Next one, very important. This is one of the time they ask NEET question. Alkyne, addition of water to alkyne. That means I am giving, for example, alkyne with water. What the product I can expect? What the product I can expect? But here I will not get any product. That means no product. Why? No product. Very important point. Listen here. Actually, our hydrocarbon that is called alkane, alkene, alkyne, these all are non-polar nature. These all are what? Non-polar nature. Compared to alkane, alkene, alkyne is a somewhat little bit polar. Why little bit polar? Observe here. Why little bit polar? This is a very important point. Why little bit polar? Little bit why it is polar? Because this carbon, which hybridization? sp hybridization. Next one, if you observe this one alkene, comparison I am saying now. This is alkane, this is alkene, this is alkene, this is alkane. This alkene is which hybridization? sp2. This alkane is which hybridization? sp3. In these three, this is sp, this is sp2, this is sp3. That means based on hybridization, using you can calculate percentage of S character. Which one is the percentage of S character is more? sp is the percentage of S character is more, because total 100% by 2, because 1 s orbital 2 p orbital, 100% by 2 means you will get 50%. sp is 50% S character. sp2 is 100 by 3. 100 by 3 means how much here? 33.3% of S character. In sp3 is percentage of S character total 100 by 4. Why it is 4? 1 s orbital, 3 p orbital, total 4. 100 by 4 means 25% of S character. In this which one is the more percentage of S character? sp. So percentage of S character, if you know, percentage of S character directly proportional to electronegativity. That's why which one is the more electronegativity in these three? Alkyne is the more electronegative than alkene than alkane. That's why electronegativity order, alkyne is greater than alkene than alkane. That's why it is more electronegativity. More electronegativity means there means somewhat electronegativity difference is there means you will get the charge separation. Charge separation you will get it means that is called polar. That's why it is little bit polar. Little bit polar means what we will think? Polar compounds are soluble in polar solvent. Here water is what? Polar solvent. This is also called polar, not complete polar. It is little bit polar. That's why it is little bit only soluble in water, but it is alkane also more soluble in non-polar solvent compared to water. That's why its reaction is not possible. That is the meaning. Finally, what I am going to say, alkynes are immiscible or not insoluble in water, little bit only soluble. That's why finally what you have to say, completely immiscible in water. Immiscible in water means it will not react with alkyne. So that's why alkyne with water there is no reaction. If it is want to reaction, it is in the presence of some external condition we have to take. What are those? In the presence of mercury sulfate and sulfuric acid, that time reaction will takes place by adding of water will be takes place. That means, so alkyne with water they are given no reaction. The reason is this is the reason only explanation. This want to react means what you have to say, what you have to add external agents. External agent means that is what meaning of HgSO4 and H2SO4, that meaning adding of water. This is called symmetrical alkyne, unsymmetrical alkyne. This is called symmetrical alkyne, adding of water. Observe here. So one of the bond I removed, I am adding water molecule. Here OH, otherwise here OH, here H, that means H2. This is the intermediate product, that is called intermediate product, that is called vinyl alcohol. This is also vinyl only. Vinyl alcohol is unstable again. So unstable means it undergo isomerization to get the stability. Actually this is called tautomerization. The tautomerization is not there in our concept. That's why instead of tautomerization I am saying isomerization. You know all of you isomerization means. What is isomerization? Same molecular formula, different structural arrangement. Different structural arrangement is called isomer, and that process is called as isomerization. That's why it undergo isomerization. Why it is undergo isomerization? To get the stability. Observe here. This bond shifting to this. This bond shifting to this. Then what happened? This hydrogen will move to this one. Then what I am getting? CH3 here with single bond. Here CH double bond O, that is called aldehyde. So that means alkynes with adding of water means alkyne with adding of water in the presence of mercury sulfate and H2SO4. What I am getting? Aldehyde, that is called ethanol. Now same question. Instead of this ethane I am giving propane with water. So instead of this water, what they will give in the question? Water they will not give. What they will give you? They will give in the presence of Hg plus 2 and H plus they will mention. That meaning what? That meaning is what? What is the meaning of this? Hg plus 2 and H plus means H plus is coming from H2SO4. Hg plus 2 is coming from HgSO4, mercury sulfate. That meaning here adding of water to the alkyne. So instead of water they will be like this. That means what you have to consider? Adding of water. Adding of water means this is what? Symmetrical alkyne, unsymmetrical alkyne you have to observe. This is called unsymmetrical alkyne. Unsymmetrical alkyne, addition of water follows which rule? Markovnikov's rule. So based on Markovnikov rule we are adding water. Then what I can get? CH3 here, CH double bond CH, and again what happened? H2O is there, H plus and OH minus means negative part here, hydrogen here, then you will get this one. What is this one? Again intermediate vinyl alcohol. So this is also unstable. It is also undergo isomerization. Again isomerization. Then what happened? This bond shifted to here. This bond is moving to this. This hydrogen come and adding here. Then what I am getting? CH3, C double bond O, CH3. What do you call this one? Ketone. This is called aldehyde. So what I have to conclude finally? In case of ethane with mercury sulfate, 2 carbon alkyne with mercury sulfate will get the aldehyde. Other than acetylene, any alkyne with mercury sulfate with sulfuric acid, you will get ketone. That is the final conclusion. Very, very, very important. Next, some other important point. Alkyne with red hot iron tube or copper tube. Red hot iron tube means it will supply high temperature. High temperature means how much temperature here? 873 Kelvin. That much temperature we need. Why we need that much temperature? Here carbon having how many bonds are there? 3 bonds are there. But 3 bonds means that 3 bonds we have to break. It required more energy. That more energy is supplied by high temperature. High temperature who is giving? Red hot iron tube or copper tube. Then what I can get? Red hot iron tube is there. Compulsory. We have to take 3 moles of alkyne. That is called polymerization. That is called cyclic polymerization. Cyclic polymerization means 3 moles of alkyne. The total how many carbons are there? 3 into 2, total 6 carbon. 6 carbon means you will get the 6 carbon cyclic ring. Cyclic polymerization. Cyclic ring is called what we call benzene. Our requirement product is benzene. I am getting benzene by using ethyl. That is called cyclic polymerization by using red hot iron tube. Next, some other questions. This is called but2 ion. This is also called but2 ion with H2 PDC, H2 sodium in liquid ammonia. Very important. So many times they ask the question this one only. Sodium in liquid ammonia, H2 PDC. Otherwise H2 PD BaSO4 in quinoline. Quinoline, this already know. H2 PD BaSO4 in quinoline is called Lindlar's catalyst. LC, Lindlar's catalyst. This Lindlar catalyst, this is also same H2 PDC, all this also called Lindlar catalyst. Lindlar catalyst means what happen? Partial reduction, that means mild reduction. Mild reduction means what will happen? Adding of hydrogen to this alkyne. Then what I can get? What I can get means, observe here. Alkyne is changes to alkene. Actually adding of hydrogen. Here observe clearly, this is not there, for example I am saying no, this is not there. What is not there? C is not there. H2PD or nickel, platinum is there. Then final product is alkane. Direct final product is alkane because it is a strong reducing agent. Which one? H2, PD, nickel or platinum, it is there. That is strong reducing agent. Final product alkane is converted into alkane. We don't want alkane. We want alkene means that reaction I want to stop. I want to control to alkene only now. That time what I have to do? Then I am adding H2PD by carbon, PDC, carbon, that is called charcoal. This is called charcoal. This is what is the use of this one? Reaction will be control. Reaction will be control up to, reaction will stop at alkene only. Otherwise, instead of that, this one you have to take H2PD, BaSO4 in quinoline. That means this is, it will stop. Carbon here, carbon and quinoline, barium sulfate will what? Further reduction will stop. Will stop the further reduction. That is the purpose we are adding carbon and quinoline. That's why it is called Lindlar catalyst. And what happened? Observe here clearly. These two hydrogen atoms are which side added? Same side of the double bond. That's why this is called as cis, also called syn. Syn. Cis also called syn. Cis also called syn. Syn alkene or cis alkene I am getting. When I am getting cis or syn alkene, H2PDC, that is called Lindlar catalyst. When Lindlar catalyst is there, cis alkene I am getting. Same H2 sodium in liquid ammonia. This also same. This also same. This is called partial reduction. That is called mild reducing agent. This also called mild reducing agent. That reduction. This reducing agent name is called as Birch catalyst. Birch, also called Birch reduction. Catalyst name is Birch. This catalyst name is Lindlar's. This Birch catalyst means adding of hydrogen also here also takes place. Here also same. Here also same. But here different is what? Very important, Amma. Here hydrogens are adding on the double bonds, both are opposite to the opposite side of the double bond. Opposite side of double bond means what you call trans, also called anti. Trans also called anti-alkene or trans-alkene. This is called cis-alkene. Sometimes cis also called, sometimes some other question paper they I observed one of the paper. Cis also called Z. Trans also called E. Sometimes Z to E they will mention. Don't get confused. Cis, sin, Z all are same. That means same side of the double bond. Means hydrogen atoms are adding on same side of the double bond. Trans or anti also called E. That means what? Hydrogens are adding on opposite side of the double bond. So when you are getting trans, when you are getting cis. When Lindlar catalyst is there, cis addition. When Birch catalyst is there or Birch reduction is there, trans addition. Very, very important. So many times they ask this is the question. Right. Some other important point here, acidic nature of alkynes, acidic nature of alkyne, CH, triple bond CH, CH2 double bond CH2, CH3 single bond CH3, that means acidic nature I am going to decide. So alkynes exhibiting acidic nature compared to alkene and alkane. Why it is exhibiting acidic nature? Already I explained some of the concept. This is the concept. Because this sp hybridization I told, this is sp2, this is sp3, right? Which hydrogen atom is attached to sp hybridized carbon? Sp hybridized carbon. That hydrogen is acidic hydrogen. What is in acidic? Tendency to loss of proton, tendency to loss of proton is called acid. Which one is tendency to loss of proton? Very easy compared to these three. In this one only now. Why? Same concept, same concept. What the concept here? These all are hybridization first, sp, sp2, sp3. Based on that you can say the percentage of S character. Already I told the percentage of S character. Percentage of S character is more, electronegativity is more. So in these three, which one is electronegativity is more? Electronegativity is alkane is more than alkene than alkane. More electronegativity means what happened here? That means carbon is more electronegative than hydrogen. That means electrons are moving towards carbon side. Why towards carbon side? Because electronegativity. Electronegativity means tendency to attract the electron towards that atom side only now. That's why carbon side. Then carbon getting which charge? Negative charge. Then hydrogen getting which charge? Positive charge. That means electrons are giving to that. Hydrogen is getting positive charge. That means positive charge means hydrogen in the positive charge. Positive charge means proton. Tendency to loss of proton is called acidic. Acidic. Here, that type of property. Here, that type of property we will not observe in alkene and alkane because compared to this, these two are less electronegativity. That's why in these three, which one is the more acidic? Alkyne is the more acidic than alkene than alkane. Very, very important. Next point. One of the time they ask the question. Next question. This is the question they ask one of the year. Ethine, CH3C triple bond CH, propine, CH3C triple bond C, CH3. That is called but2ine. These three are there. All are alkynes. What I told here in this, alkynes are acidic. Alkynes are acidic. But here one point I am going to say, all alkynes are not acidic nature. Not acidic nature. Right? Which alkyne having the sp hydrogens? Sp hydrogen means sp carbon containing hydrogens are, that is called acidic. So observe here. If this is sp, this is sp, 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 sp. But all are sp, spa. But here This carbon containing hydrogen is there, sp hydrogen is there, that is called acidic hydrogen. This is called acidic hydrogen. This is sp carbon, there is no acidic hydrogen. This sp carbon, here one acidic hydrogen is there, one acidic hydrogen is there. This is sp carbon, this is also sp carbon, but there is no sp hydrogen, that means acidic hydrogen, there is no acidic hydrogen. So acidic hydrogens are 0, here acidic hydrogens are 1, here acidic hydrogens are 2. So which one is more acidic? Finally, ethane is more acidic than propane than but2ine. More number of acidic hydrogen, more will be the acidic. Why more number of acidic hydrogen? It is attached to more sp hybridized carbon. That's why this is the order. One of the time this is the question they asked, one of the time this is the question they asked, one of the time these two questions they asked. Right. Related to benzene, I am writing some question to you. Observe here. I am taking, that is called, starting material is called phenol. Phenol to benzene, I want benzene. What I have to take the reagent. Some other one. I am taking benzoic acid. Benzoic acid to, I want benzene. What I have to do? I am taking this one, N2 plus Cl, that is called benzene diazonium chloride BDC. BDC to, I want benzene. What are the reagents? I want reagents in this benzene chapter. Right. If phenol is converted to benzene, what I have to take? Reagent is Zn, zinc followed by heating. Then what I can get? Benzene byproduct is zinc is removed as a oxygen ZnO. This hydrogen will attach, then I am getting benzene. That is one of the product. Now here, very important, this is one of the time they ask the question. Benzoic acid to benzene. First, this acid is treated with the sodium hydroxide. Acid is treated with the sodium hydroxide means what I can get? What I can get means salt I will get. Acid with base to form a salt. COONA. If I will take sodium hydroxide, you will get sodium. If I will take potassium hydroxide, I will get potassium. That is called sodium benzoate, also called potassium benzoate. If I will take potassium, then it is treated with salt of acid, treated with NaOH plus CaO, that is called soda lime. What is the soda lime use? Decarboxylation, yesterday I told, that is called decarboxylating agent. What I can remove? Na2CO3. Na2CO3, this H will be here and I am getting benzene. Very important. Next one, benzene diazonium chloride to benzene. How I will get benzene? By adding of reducing agent, very important reducing agent H3PO2 followed by hydrolysis. Then what I can get the observed product? H3PO2 is called hypophosphorus acid. Hypophosphorus acid is converted to H3PO3, phosphorus acid, H3PO3, H3PO2 and oxygen H3PO3. Still what is there here? Two hydrogens are there. These two hydrogens, one hydrogen with chlorine, HCl byproduct. Still one hydrogen is there here, N2 gas eliminate. Remaining what is there? This hydrogen will be added to this. What I am getting? Benzene. From here to here what happened? H3PO2 is converted to H3PO2. That means one oxygen added. Addition of oxygen is called oxidation. This process is oxidation. which is undergo oxidation, that is called as reducing agent. That means here H3PO, in case H3PO is acting as a reducing agent. One of the time they ask the question, this one only. H3PO acting as a reducing agent by using benzene diazonium chloride. Some other one also you can use, some other one reducing agent. This is what? This is called what? Alcohol. Alcohol means what? Ethanol with benzene, BDC only now. BDC with ethanol. BDC with H3PO2, ethanol. Then what will happen? Same. So you will get first product is benzene. How will get observe here? Then ethanol is converted to CH3CHO. What happened? Aldehyde. Ethanol is converted to aldehyde. Ethanol is oxidized to aldehyde. So what happened from here to here? Removal of hydrogen. There addition of oxygen. Removal of hydrogen means what you call oxidation. Which is undergo oxidation, that is called as reducing agent. That means in these two cases, in this case H3PO is acting as a reducing agent. Ethanol also acting as a reducing agent by using what? Benzene diazonium chloride. Then what happened? Is converted to CH3CHO. CH3CHO. CHO means here how many hydrogens are there? Still 2 hydrogens are there. 2 hydrogen means one hydrogen with Cl. HCl is a byproduct. Still one hydrogen is there. This one hydrogen will be added to here by replacing of N2 gas. And what I am getting? Remaining product is benzene. Very, very important. So many times they ask this is the question also. It's also one of the time they ask them match the following question. That means in these two cases H3PO2 and ethanol is acting as a reducing agents. Right. Some other question I am going to give. One of the year is also related to benzene chapter. Benzene treated with, but means here benzene and benzene derivatives undergo, you know all of you, undergo electrophilic substitution reactions. Total electrophilic substitution reaction we are having 5 types are there, already know. What are 5 types? Halogenation, that is called chlorination, nitration, sulfonation, Priddlecraft alkylation, Priddlecraft acylation. This one of the question is related to Priddlecraft alkylation. Observe clearly. With anhydrous AlCl3. What means? Benzene with 1-chloropropane with anhydrous AlCl3. This is called alkyl halide. Means alkyl halide with anhydrous AlCl3 with benzene. It is undergo electrophilic substitution reaction. Electrophilic substitution reaction, this is called Priddlecraft alkylation. Priddlecraft alkylation. This is a Priddlecraft alkylation reaction. Priddlecraft alkylation means intermediate is electrophile. What is electrophile? This is a what is called AlCl3, anhydrous AlCl3 is a Lewis acid. What is the role of Lewis acid here? Lewis acid role is to generation of electrophile. How it will generate electrophile? First one, CH3, CH2, CH2, Cl with AlCl3. This is Lewis acid. Lewis acid means electron pair acceptor. Then what happened? AlCl3 with AlCl. What I can get? AlCl4 minus. This minus means halogen is coming as a halide ion means carbon getting which charge? Positive charge. Carbon getting positive charge means what you call carbocation. This is the carbocation. Which carbocation here? Primary carbocation. Observe clearly. Any intermediate is carbocation is formed. This carbocation is able to rearrange. It is undergo rearrangement. Why it is able to undergo rearrangement? Observe clearly. If it is undergo rearrangement means this hydrogen is moved to here. Hydrogen move to here. Means hydrogen shift into here. Positive charge come to here. Then what I can get? CH3, CH plus and CH3. Now which carbocation I am getting now? Secondary carbocation. Before, after removal of halogen I am getting primary carbocation. After shifting of hydrogen to second carbon to prime first carbon, then I am getting secondary carbocation. This which carbocation is more stable? Secondary carbocation is more stable than primary carbocation. That is the purpose it is undergo rearrangement. Why it is undergo rearrangement? To get the stability. How to know, sir? How to know means first whatever the intermediate is formed, that intermediate you have to write first initially. So intermediate is carbocation is formed. Then we have to observe any possibility there or not. It is undergo rearrangement. If it is undergo rearrangement, so first primary carbocation I am getting. Next, if I will do the rearrangement, then I am getting secondary or tertiary or not. If I am not getting secondary and tertiary, that is only final. Here possibility is there. What is the possibility there? If it is undergo rearrangement, I am getting next other carbocation, secondary, some other possibility, some other doubt. What a doubt? Sir, the secondary carbocation, sir, still again I am doing the rearrangement, sir. Do that. After doing that, you will get the other than secondary, tertiary you will get, then you can take tertiary. Again if you are doing, you are getting primary only. If you do that now, you will get primary. So primary and secondary, which one is more stable? Secondary is the most stable. That's why secondary carbocation. This carbocation will be added to benzene ring. And what I am getting? This one, secondary carbocation will have to add the direct benzene. Then I am getting this one. What is this? Isopropyl benzene. Isopropyl benzene is called cumene. Cumene. Then cumene is reaction with O2 followed by H plus and hydrolysis. What I can get the product? Cumene with followed by adding of oxygen, that is called oxidation. Then what I can get? Intermediate product is cumene hydroperoxide. So oxygen will be added to the central carbon, that is called benzyl carbon, that is more stable. That's why there only we have to add the oxygen. You will get benzyl peroxide. Otherwise, sorry, not benzyl peroxide, cumene hydroperoxide is the product I am getting. Sir, why sir? There only we have to add middle only. Why not terminal carbon? Terminal carbon is the primary. This one is tertiary carbon, also called benzyl carbocation. So benzyl carbon is the more stable than primary. That's why there only we have to add oxygen. Then I am getting what I am getting. What I am getting now? This totally cumene. Cumene with OO bond is called peroxy bond. That's the name is called cumene hydroperoxide. Then followed by what? Acidification, hydrolysis. Then I am getting what? What I can get? Phenol. One of the product is phenol plus acetone. This is our final product. This is one of the time they ask the question. Next, this year, latest NEET, 2026 NEET, one of the question they asked. What is the question? Observe here. What I told, benzene and benzene derivatives undergo electrophilic substitution reaction. But under special condition, it is also undergo addition reaction. So observe here. Under special condition means compulsory condition. Condition I told. Condition means either catalyst or temperature, high pressure, otherwise UV, sunlight. That is called special condition. What is this one? Benzene. Benzene with H2 in the presence of nickel or palladium or platinum. This is the special condition. That time, this is instead of electrophilic substitution reaction, it is undergo addition reaction. Adding of hydrogen. Hydrogen means you have to remove the double bond. If you remove the double bond, one double bond you have to remove, two hydrogens you have to add. Then what I can get? Answer is total three double bonds are there. That three double bonds you have to remove. Then what I can get? This is the product that is called cyclohexane. That is called addition reaction. Next one. One of the question, this is very, very important. This is the only question they asked. Light. This is the question. This year they asked. Observe here. Benzene with 3 moles of chlorine in the presence of sunlight. In the presence of sunlight means that is called addition reaction. In the presence of anhydrous AlCl3, also called dark, also called cold. Sometimes they will mention. Dark or cold condition, it is undergo electrophilic substitution reaction. In case of sunlight, in case of UV light and high temperature, temperature also you have to mention around 500 Kelvin or 800 or 700 Kelvin. Okay, temperature simply. Then what is undergo? It is undergo addition reaction. Very, very important. Right? Then what is the product I can get? What is the product I can get here? That means your addition reaction means the total 3 bonds you have to remove. Total 3 bonds you have to remove. 1 bond you have to remove. How many chlorines I have to add? 3 chlorines. 1 bond I have to remove. 2 chlorines I have to add. 3 bonds I have to remove. I have to add 6 chlorines. That means chlorine, 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 chlorine. That means here carbon having the tetravalency itself having the hydrogen, 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 hydrogen. This is the one of the product. When benzene with 3 moles of chlorine with which one? Condition, that is called sunlight. That time it is undergo addition reaction. The triple bond, that all bonds are, 5 bonds are removed by adding of chlorine. But in case of this one means excess. How many moles of chlorine here? So this is not there, for example, leave it now. 6 is not there. Chlorine in the presence of anhydrous AlCl3 with benzene, it is undergo what? Electrophilic substitution reaction. Electrophilic substitution reaction means what I can get the product? I can get the product is chlorobenzene. When? Only 1 chlorine. But I am taking, instead of 1 chlorine, I am taking how many chlorines? 6 chlorines. 6 chlorine means excess of chlorine. That means all 6 carbons on the 6 hydrogens are replaced by 6 chlorine. Then what I can get? Cl, 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 Cl. Total how many chlorine? 12 chlorines are there. But 6 chlorines are substituted by hydrogen. That means 6 hydrogens with remaining 6 chlorine. What I can get the byproduct? 6 moles of HCl. That means your benzene having hydrogen, 6 hydrogens are there. The 6 hydrogens are replaced by 6 chlorines. Means substituted by 6 chlorine. This is the product, one of the product. This is called electrophilic substitution reaction. This is called addition reaction. What is the name this one? This is called BHC. This is called hexachlorobenzene. Hexachloro, how many chlorine? 6 chlorine. Hexachlorobenzene. This is called BHC. What is BHC? Benzene hexachloride. Benzene hexachloride. Also called gamma-hexane. Gamma-hexane uses to killing the insects. That is called, it is insecticide. Insecticide. Gamma-hexane, also called 666, also called lindane. These are the names, different names. One is BHC, benzene hexachloride, also called benzene hexachloride, also called gamma-hexane. This is called gamma-hexane. Gamma-hexane used to killing of the insects. Also called 666. What is the name? 666. First 6 indicate number of carbon, 6 carbon. Second 6 indicate number of chlorine, 6 chlorine. Third 6 indicate number of hydrogen. That means 666. This other name is also called lindane. Lindane. This is the information. So the product they are given in this exam, in this last NEET. How many moles of chlorine we need in case of first case, in case of second case. In case of first case is how many moles we need? 3 mole. Second case is 6 mole. This is the answer. This is they ask the NEET question. Right? Now we will solve some questions. Now I am writing some question. pH, this one with carbon, double bond. Reagent. One is HBr. Second one is magnesium in dry ether. Third one is CO2 followed by H3O plus, that is what? A. Next one is SOCl2 CH3 NH2 B. This is the first question. First you solve this question, later move to next question. What is this one? This is the meaning of benzene. If you are not understanding like this, you have to write now. Right? That is called, this name is called styrene. With HBr addition. HBr addition follows Markovnikov rule because unsymmetrical alkene. Otherwise, intermediate is benzyl carbocation. Two possibilities. If it is moving, it is primary carbocation. It is moving, secondary carbocation, and also called benzyl carbocation. Benzyl carbocation is more stable. There only you have to add the Br. So here Br. Next to MgBr means this is called alkyl halide with magnesium in the presence of dry ether. What I can get? Grignard reagent. What I can get? Grignard reagent. MgBr like this. Then followed by what? Carbon dioxide followed by hydrolysis. Adding of carbon dioxide to the Grignard reagent. What I can get? This already you know. Carboxylic acid you will get it. Adding of carbon dioxide you will get carboxylic acid. COOH, carboxylic acid. Then followed by, this is the 1, 2, 3, that is called A. This is the A product. Reacting with carboxylic acid with SOCl2, that is called thionyl chloride. Thionyl chloride means here one of the OH is replaced by Cl, means OH is nucleophile, this also Cl is nucleophile. One of the nucleophile is replaced by another nucleophile is called nucleophilic substitution reaction. Then what I can get? C double bond O Cl. OH Cl, here H and Cl, HCl eliminate. Here O and S, SO2 is the byproduct. SO2 and HCl is the byproduct. Both are the gases evaporate. This is the byproduct, it is the main product I can get. This is reacting with B, what is that? CH3NH2, that is called amine, methanamine. Methanamine means what you have to remove. Here H and Cl, HCl you have to remove, then what I can get the product? C double bond O, NHCH3. This is called amide is the product, this is the final product, this is called B. One of the time they ask the question, conversion. Second question, an alkene an alkene A on react with O3Zn followed by hydrolysis. That means that is meaning of alkene on ozonolysis, that is the meaning. Gibbs is giving propanone and ethanol, mixture of propanol and ethanol. Mixture of propanol and ethanol. This on addition of, not this one, addition of HCl2, alkene A. This alkene I told, alkene A gives B is the major product, or B as the major product. Write the structure of the product, they are asking the question. Once observe clearly, once again I am saying now. They are given alkene is A, on ozonolysis you getting propanone and ethanol is the products, equimolar mixture I am getting. Then next followed by addition of HCl2 alkene, whatever the alkene is there, that alkene what I added HCl, I am getting B. B product, B as the major product. What is the major product they are asking now? First, in that question, this type of question compulsory they will give a hint. What they give a hint? This is only hint. Propanone and ethanol, which one? Ozonolysis. That means, for example, A, we don't know A. This one ozonolysis. O3, ZnH2O. This you know. If you know the alkene, then undergo ozonolysis means what you have to know. Wherever the double bond is there you have to break the bond, then you will get it the alkene. Now they are given alkene and they are given what you call product. The product using I am going to write the alkene. How to write? First propanone. This is the propanone. Like this you have to arrange double bonds. Ketones. That is ethanol. Ethanol and propanol like this you have to, that means keto groups you have to write like this arrangement. Then you remove the oxygen. Because alkene is there, what you have to do? Break the double bond, this side oxygen, that side oxygen I told. Like that, whatever the oxygen we are added, that oxygen we have to remove. Then you have to join that now. Both you have to join, both you have to combine. CH3, C, CH3, double bond, CH, CH. This is called our alkene, that is called A. Otherwise, sir, this alkene correct or not? What you have to do? Again you do that, this is called ozonolysis, this is A. Ozonolysis you do, what I told ozonolysis means, wherever the double bond is there, that you have to break down, that's this side oxygen I told, break down. I am getting CH3, C double bond O, CH3, that is called propanone. CH3, CHO, that is called ethanol. You are getting that product. That's why it is A, our requirement product A. A, that is called A, alkene. This alkene what you have to do? Addition of HCl. Alkene this one. Right? Addition of HCl. This is called unsymmetrical alkene. Unsymmetrical alkene means addition of HCl follows which rule? Markovnikov rule. So what you have to do? Cl we have to add here. So answer is CH3, CH3, here Cl, single bond, CH2 and CH3. This is our requirement product. This follows which rule? Markovnikov rule. That's all. Just 1 minute, one question I will give you and later I will stop. That question you have to solve in your home. Observe, just one question I will write and I will stop you. This textbook question only. CH3COOH conversion with NaOH. What is the product? A with soda lime. Product B. Product B is reacting with Cl2 with HNu, product C. Cyan reacting with sodium in dry ether, that is called Wood's reaction, D. Dione reacting with chlorine, Cl2, you will get E. Cyan in the presence of HNu, again E. E is reacting with alcoholic KOH, this is called dehydrogenation, F. Then reacting with Br2 in the presence of CCl4, that is what? G. This reacting with alcoholic KOH and NaNH2, this is 1 mole, this second one G, you will get H. H with red hot iron tube or copper tube, then I product I am saying now, I is benzene. That means this question is total alkane, alkene, alkyne and benzene. Our final product is benzene, I will get it now. Final product I am giving, starting metal I am giving. Now these are the products, all you will get it now. This is the conversion. So if you know this, you automatically all reagents are included here, alkane, alkene, alkyne and benzene also, right. This conversion you have to do in home, then you have to try it, compulsory you will get it, okay, okay Amma. Today I am going to stop the class. Tomorrow I will continue with remaining chapter, that is called chemical bonding chapter, right.
Yes, my dear students, good afternoon all of you. Today I am going to discuss Newton's laws of motion. In Newton's laws of motion, so what are the questions given on which topics? First one, laws of motion. Now these are laws of motion. This is Newton's laws of motion. Second one is a impulse. This is an impulse. Next, third one is a contact bodies. Contact bodies. Fourth one is a connected bodies. And fifth one is a pseudo force. And sixth one is a friction. So these are the topics covered in the Newton's laws of motion. But in Newton's laws of motion, these are among all the 6 topics here, most of the times these are, so Newton laws of motion 2 or 3 times asked this is. So only one time this asked here, a previous year, last year this question only one time is asked on the impulse. So last 10 years, contact bodies given 4 times and the connected bodies also 4 times, but this is given 8 to 9 times. This is pseudo force and friction combined question given 8 to 9 times question given on the this. So that among all the topics, so which one is important here? A pseudo force and friction, and also after that here connected bodies and this contact bodies. Because these are the here topics to be covered in the here Newton's laws of motion. First let us discuss the laws of motion. In laws of motion, most important is a Newton's second law. Now question only based on only here Newton's second law. First let us see the Newton's second law. The Newton's second law. What is the Newton's second law? The rate of change of momentum of the body is directly proportional to external force acting on the body. That is, F is equal to, this is F is equal to dP by dt, or F bar is equal to dP by dt. Or this external force acting on the body is equal to rate of change of momentum of the body. This is Newton's second law. In this Newton's second law, this P is what? Mass into momentum. Momentum is equal to what? Mass of the body into its velocity. But this also can be written as this d by dt of mass into velocity. Sometimes mass is changing, sometimes velocity is changing, sometimes both are changing. Suppose the velocity is changing here. From this here we can write mass of the body is constant. For rigid body only mass of the body is constant. So that this formula can be written as F is equal to what? M into dV by dt. So that F is equal to what? Mass into dV by dt, the rate of change of velocity. This is called acceleration. So F is equal to ma. Look at this, F is equal to ma can be applied for only rigid bodies. Mr. Mass of the body is constant. Next, and another formula from this here. Sometimes here mass is changing, velocity is constant. In that case, F is equal to this V into dm by dt. This is called variable mass system. For variable mass system, we can apply F is equal to V into dm by dt. This mass is changing, velocity is constant. Example, conveyor belt or escalator. Escalator moves with constant velocity, but mass on the escalator every time changing. That is variable mass. In that case, how much force is required to maintain the constant velocity? How to calculate that?
here F is using this formula, F is equal to what? V into dm by dt. So this is a conveyor belt, this is. So this is a conveyor belt is moving like this. This is a conveyor belt, this is. Okay, it moves here on this here, this mass is falling on this. This is a mass. Okay, it moves with constant velocity. So how much force is required to maintain constant velocity formula? F is equal to what? This is dm by dt, this is. Because constant velocity, so how much force is required to maintain constant velocity formula? F is equal to what? V into dm by dt. Like this we can apply this Newton's second law. And also in this here F is equal to ma, how to calculate acceleration of the body? We have different formulas for acceleration of the body. So in this here one problem here, suppose whenever force is acting, velocity changes from here u to v in t seconds to velocity after t seconds, v is equal to what? U plus at. From this acceleration is equal to what? V minus u by t. Suppose velocity of the body changes from u to v after displacement, then formula v square minus u square is equal to 2s. From this acceleration is equal to what? V square minus u square by 2s. Next. And displacement t seconds, s is equal to ut plus half at square. From this here we can calculate acceleration. Yes, sometimes here this net force, how to calculate net force? Then two or more force acting on the body, then how to calculate net force acting on the body according to paradigm vector addition. Suppose two force acting on the body, this here two force acting on the body like this. This is a body of mass here. This is F1 force. This is F2 force. Makes an angle theta. This is their net force. This net force acting on the body F is equal to what? This is magnitude of the net force. This is equal to F1 square plus F2 square 2 F1 F2 cos theta. This is net force of F1 and F2. Magnitude of net force of F1 and F2. In this here, suppose two forces same direction, F1, F2 same direction, theta is equal to 0 degrees. In that case, net force is equal to what? F1 plus F2. Suppose two forces opposite direction, theta is equal to 180 degrees. Then their net force how much here? Difference in forces. Like this we have to apply to this F is equal to ma formula. A can be calculated using these formulas. And suppose two or more forces are given, net force is equal to what? This formula F is equal to what? Root over F1 square plus F2 square plus 2 F1 F2 cos theta. Yes. Let us solve some questions or questions given in the previous year on this topic. This is. Yes. One question given 2023. 2023. On the Newton's laws of motion. A football player is moving southward and suddenly turns eastward with the same speed to avoid an opponent. The force that acts on the player while doing is option A along northward, option B along the northeast, along the southwest, along eastwards. This is a question. So now this so first of all write this is geographic north, this is geographic south, this is east, this is west. In this given football player is moving first of all southwards, towards southward, this is south. This is initial velocity. This is initial velocity. Initial velocity is equal to what? This is so initial velocity Vi is equal to what? V. Next, turn towards the eastwards. Because this is a final here, this eastward, this is a final velocity. Also same, initial velocity, final velocity is the same, direction is different. This is a final velocity. Okay, what the force acting on the player while turning it is. Okay, so basic formula is F bar. We know that your force is equal to what? Force is equal to this a rate of change of momentum. This is rate of change of momentum. In this here, player is a rigid body, so that mass of the body is constant. So that now this can be written as here, this here d by dt of mass into velocity. This is, so that this is equal to m into this dv by dt. Then f m. So dv by dt means a change in velocity. This is final velocity minus initial velocity divided by time interval. This is a time interval. So direction of the force. What is direction of the force? Direction of force in the direction of a change in velocity. Here remember, keep in mind, now this is direction of force in the direction of a change in velocity. Okay, so what is the direction of change in velocity in this here? So change in velocity means here final velocity minus here initial velocity. Okay, so Vf bar minus Va, we want minus Vi. If you take this resultant of these to this addition, this gives addition of two vectors. But we want here minus Vi, this is Vi, this is final velocity, this is minus Vi, this is. Because this addition of, final velocity plus initial velocity, this is delta V, this delta V is equal to what? Final velocity plus minus V, this is minus Vi. Because this is a direction of the force. So direction of force is what? Your northeast direction. Along the northeast direction, this is a direction of the force. So this question asked in the 2023. Okay, next. And also one more question. Okay, let us take so many questions asked like this here. So I will take next topic, contact bodies. So now contact bodies. Yes. How to approach contact, how to calculate where there are problems on the contact bodies. Yes, suppose two bodies are in contact like this. This is M1, this is M2 like this. The force is acting. Now this it moving, go with some, this is a smooth surface, this is. Go moving with some acceleration. Go moving like this. Now the question is, find the acceleration of each block, find the contact force between the M1 and M2, find the normal force or contact force between the M1 and M2. Yes, this acceleration. So remember one formula here, acceleration is equal to net pulling or pushing force divided by total mass. Suppose if you take a whole system, this whole system. You can write here acceleration is equal to what? This net pulling or pushing, this is divided by total mass of the system. Then A is equal to what? A is equal to F divided by M1 plus M2. Because this is one shortcut formula, this is. Okay? Whenever bodies are given, we can write like this, net pulling or pushing force divided by total mass. But how to calculate contact force between these two? Draw the free body diagram. If you draw the free body diagram of M1, this M1 and M2, this is M1 and M2. First of all, motion direction, this acceleration of each block, this is. So along the motion, water force acting, this is F. And between M1 and M2, your normal force acting like this. This normal force acting on this. This also normal force acting. Okay, this is a contact force between the M1 and M2 or normal force between M1 and M2. If you take this, easy to calculate. Okay, so F is equal to what? According to F is equal to MA formula. So this is N net force acting on this is what? N along the motion. So N is equal to mass into acceleration. Okay, this is equation number 1. This is equation number 2. This acceleration substitute there. You will get there normal force between the M1 and M2. This is equal to what? M2F divided by M1 plus M2. This normal force like this. Okay, this is the procedure to find out the problem. Now let us see the previous year questions on this topic, contact bodies. Okay, I'll give some examples. Yes. One question given in 2024. In this question given here, these are two bodies. These are 2 kg body. These are 4 kg body. This is A body. This is a B body. These are 10 Newton forces acting. This is F is equal to what? These are 10 Newtons. But question. Now horizontal 10 Newton applied. Masses of the blocks given. Force exerted by the block A on block B. Force exerted block A and block B. This is okay. First, let us find out the acceleration. This is consider whole system. This is a whole system moving with acceleration. With acceleration. This acceleration is equal to what? Net pulling force divided by total mass of the system. Means 10 divided by the 2 plus 4 is equal to what? 10 by 6 is equal to 5 by 3. This is 5 by 3 meter per second square. Or this is 10 by sir, this is 3. This is 3 kgs. So that this is 3. So this is 5 become this is 2 meter per second square. Okay. This is your acceleration. But now we want to calculate force acting on the here B due to A. This is we said normal force between these two. Draw the free body diagram of 2 kg. These are 2 kg. And also 3 kg. This is A block, this is B block. Both move with the same acceleration. Along the motion, what are force acting? About 10 Newtons. But force between these two normal force. This is normal force between here. The force are acting like this. This is a force acting on A, this force acting on B, normal force. Or this here N is equal to what? Here now apply F. If you take this one here, net force of these two. If you take only this here, only net force is only N. So apply F is equal to MA formula. Go mass into acceleration. F is what? N is equal to mass is a 3. Acceleration how much here? Here this are 2. So that N is equal to what? 6 Newtons. This is a force acting on B due to A. This also can be written as here force acting on B due to A, NBA. Okay? So this is here proceed to find out the problem. Next. This is 2024 question. This is. Next. So another question. In 2022, also asked one question. 2022 unconnected bodies. So diagram is given like this. These are 30 degrees. These are 3 bodies are given. First body, this second body, this is third body, this are 3 kg, this are 2 kg, this are 1 kg. This are 60 newtons. These are 18 newtons. F1 and F2. Okay. So find the normal reaction force between the 2 kg and 1 kg. Normal reaction between the 2 kg and 1 kg. This is. Okay. Yes. So how to calculate this problem? This is normal reaction between 2 kg and 1 kg. First of all, we have to decide body is moving down or up. But apart from these two forces, another force also acting, there is gravitational force. So whenever body is on the inclined plane like this, suppose this is inclined plane, this is inclined plane, this is theta. Okay, water force acting, gravitational force mg downwards, this is a normal force, this is. This side is theta, this also theta, this is. Mg can be resolved into 2 components. This component of weight along the inclined plane is a mg sin theta, because perpendicular to inclined plane mg cos theta. So this total weight along the inclined plane mg sin theta. So that here also same. This total mass of the system is how much? This 3 plus 2, 5 plus 6 kg. 6 kg. Because this here weight acts this direction to mg sin theta. Okay, means here 6g. This 6g sin 30 degrees. Means here this is equal to how much here? This value is equal to 60 into 1 by 2, 30 newtons. Okay, downward force. Downward force how much here? 30 newtons. 30 plus 18, 48. Upward force. So that here, so body's upward force is more, downward force is less. So that your body is moving up. So that acceleration is equal to how much here? Acceleration is equal to net force divided by total mass of the system. No? Net force, upward force how much here? 60 minus 30 minus 18 divided by total mass of the system is a 6. This is 6, this is. Okay, this is 60 minus 30. This is 30. 30 minus 18. Because this is equal to how much here? 12. This is. Okay, this is 12. This is 12 by 6. Which is equal to acceleration is equal to 2 meter per second square. This acceleration. So after that, so normal reaction. Normal reaction between these two. Along the motion, this is along the inclined plane. Go along the inclined plane. Because these are 2 kg, this is. These are 2 kg. These are 2 kg, this is. Because these are 1 kg. These are 1 kg. Okay, acceleration is upwards. Here also acceleration is upwards. Okay, normal force between these two is that this is a normal force. With this also normal force. Okay, on this here, your force is acting. And this is 18 newtons. This is 18 newtons. Okay, and this is a normal force. And weight of this mg sin theta also downwards. This mg sin theta. Mg sin theta means that this is equal to, so 1g sin 30 degrees. Okay, g 10 by 2. This is equal to how much here? 5 newtons. This is. Because g is at 10, so this is 30 degrees, 5 newtons. So that now this here we want to calculate n value. This is. So moving up. Okay, upward force is more. This is. Net force is equal to what? Here net force is equal to mass into acceleration. But in net force, this n minus. This is equal to how much here? Minus 5. Okay, with this minus. So minus 5 and also minus 18 is equal to mass into acceleration 1 into A this is. So that this is equal to n minus 18 of 5, these are 23, minus 23 is equal to 1 into A is equal to how much, how much you got here? 2. So that n minus 23 is equal to 2, so that n is equal to 25 newtons. Okay, like this we have to calculate. Okay, apply F is equal to MA formula for this here 1 kg, then you will get answer n is equal to what? 25 newtons. So like this here so many questions asked on the here contact bodies. Okay, next. So I will discuss the connected bodies. So how to calculate here connected bodies. Connected bodies. And this also so many times question asked on the connected bodies. But how to calculate connected bodies? Let us check. This is Atwood's mission. At Atwood's mission also we are so many times asked in the exam. This is Atwood's mission. This is a light pulley. This is a light string. This is a light string. This is M1 is the mass of the one block, M to the mass of the another block, this is. Or take this M1, this M2, this is. Take M2 greater than, this M2 greater than M1. Because two blocks are connected by, this is called connected bodies. This is a light pulley, light string, this is a light string, no friction anywhere. Whenever M2 is greater than M1, because now this is water force acting on this here, first of all, this is gravitational forces. This is M1G downwards, this also M2G downwards. So tension will be developed like this. So tension in the string is same. This string is same, no? Tension will be same. This is a light string. So the tension will be same at all points. Okay, as a M2 greater than M1 means M2G is greater than M1G, so that it moves. So like this, it moves up, it moves down with the same acceleration. So this is along the string. Displacements are equal, velocity is also equal, acceleration is also equal. Remember this along the string. So that the accelerations are equal. So moving down like this here. Now this question is find the acceleration of each block. Find the tension in the string. How to apply? Apply here also same. This is a rigid body. This is. We can apply F is equal to MA formula. This is F is equal to MA formula. Okay, net force of these two. Moving down now, this force is more than these two forces are acting opposite direction. So that net force can be written as M2G minus T is equal to M1 into A, equation number 1. Apply same F is equal to MA for this M1. Okay, sir, this is M2 this is. For M1, this is T minus, this is T minus M1G is equal to M1 into A, equation number 2. If you solve this, you will get acceleration is equal to what? Acceleration is equal to M2 minus M1 by M1 plus M2 into G. And tension also, acceleration substitute either first equation, if you add these two tension cancel now, you will get this formula. Because substitute acceleration either first equation or second equation, you will get tension. The tension formula, these are 2 M1, M2G divided by M1 plus M2. This is standard formula. This is. Both formulas are standard formulas for the Atwood's mission. Okay. But in this formula, acceleration also we can calculate by using shortcut formula. What is shortcut formula? Acceleration is equal to what? Net pulling or pushing divided by total mass of the system. In this here, pulling force, this is a pulling force. If it state both are opposite direction, so that M2G minus M1G divided by total mass of the system is M1 plus M2. So that this is equal to what? M2G minus M1G divided by total mass of the system. You will get same formula. Like this, by using shortcut also we can here calculate acceleration of each block. Okay. Now let us see the questions. Here questions asked on the these are connected bodies. Previous year questions asked on the connected bodies. I will give some examples. Yes. This are 2020. Given same Atwood's mission. This are Atwood's mission. This are 4 kg block. This are 6 kg block. Okay, question. Acceleration of the system is how much? A is equal to how much? This is a question. This is a 2020. This question asked in that 2020. Acceleration is equal to how much? Already told you. M1 is a less mass. M2 is a more mass. So that this M1 is less mass. This M2 is more mass. Direct you can apply formula. A is equal to what? Okay, this direct form this is a gravitational force, this is 4g, this is 6g. Okay, acceleration is equal to net pulling force, net unbalanced force also, this is 6g minus 4g divided by total mass of the system, 6 plus 4. This is equal to 2g divided by 10. Okay, this is equal to A is equal to what? Here 2g by 3. Or if g is equal to 10, then if g is equal to 10, acceleration A is equal to what? 2 meter per second square. Okay, like this here one question given in the 2020. Next, let us see the another questions also. Next, 2025. 2025. So 2025 questions. In this question given, a box of mass 5 kg is pulled by a cord like this. These are 30 degrees. These are 5 kg. These are 5 kg box pulled by cord up frictionless plane inclined 30 degrees with horizontal tension in the thread. This tension is given 30 newtons. This is a given tension. This is okay. The acceleration of the box is equal to how much? Acceleration blocks. This acceleration box A is equal to how much? How to calculate this problem? Motion is along the inclined plane. So that we need forces along the inclined plane. Already told you, gravitational force acting down. Component of the gravitational force along the inclined plane is what? mg sin theta. So that this is equal to 5g sin 30 degrees. Sin 30, 1 by 2. Okay, this is equal to here 25 Newton. This 25 Newtons. Okay, now this acceleration. So acceleration is equal to what? Acceleration is equal to net force of these two 30 minus 30 minus 25 divided by total mass of the system 5. This is equal to 5 divided by 5. So that A is equal to 1 meter per second square. This is acceleration of the block. Okay. So like this here, so many questions asked this connected bodies also. Next I am going to discuss pseudo force. Pseudo force. Generally, inertial frame of reference, non-inertial frame of reference. In non-inertial frame of reference, now sir, apart from all other forces, this is pseudo force is acting. This is a consider to apply the Newton's laws. In the non-inertial frame of reference, Newton's laws are valid. But non-inertial frame of reference Newton laws are not valid. To apply the Newton laws in the non-inertial frame of reference, additional force is required. That force is called pseudo force. Then what is meant by pseudo force? What a non-inertial frame of reference? Any accelerated frame of reference is a non-inertial frame of reference. Suppose car is moving with acceleration, that is called non-inertial frame of reference. Bus is moving with acceleration, that is a non-inertial frame of reference. Or lift is moving with acceleration, that is called non-inertial frame of reference. Suppose body in the non-inertial frame of reference, so this is a non-inertial frame of reference. This car is moving with certain acceleration. Like this. So car is moving with acceleration, this is. So body, suppose body in the car, m is the mass of the body in the car. Okay, what is direction of the pseudo force? Direction of the pseudo force always opposite to direction of acceleration of the car. Acceleration of the car is in this direction, so that your pseudo force direction this direction. What is magnitude of the pseudo force? Magnitude of pseudo force is equal to what? Mass of the body into acceleration of a car. This is a non-inertial frame of reference means m into a. Well, this is a pseudo force. Okay. So now let us see the problems on the pseudo force. So combined with the frictional force. Well, frictional force also. First, let us see the. I will give one question on this is pseudo force. After that, I will discuss here this is a frictional force. So one question, this is given, recent exam conducted, that is a 2026. 2026. Okay. In 2026, this question is asked. This is. Okay, in this 2026 here, this question is, a box of mass 15 kg is kept on a floor of a stationary trolley. The coefficient of starting friction with the box and the trolley is 0.12. Keeping the box stationary straight over the trolley. The maximum acceleration with which they can move horizontally. Okay. So in this question is given one box, this is a trolley, this is. This is a trolley. This is a trolley, this is. Trolley is moving with acceleration, certain acceleration, this is. One box is, so is in the trolley, this is a non-inertial frame of reference, this is a box, this is. M is the mass of the box, this mass is equal to how much here? This mass is given, it's 15 kg, this is 15 kg. And coefficient of friction is given, mu is equal to what? Mu is equal to 0.12, this is 0.12. Okay. So what is the maximum acceleration of the, what is here, maximum acceleration of the trolley, so that this block is at rest. Okay, for the block is at rest here, what is the maximum acceleration of the block? Okay. So now this is non-inertial frame of reference, so that experience is pseudo force. What is the direction of the pseudo force? Good direction of pseudo force is opposite direction of acceleration. This is equal to what? Magnitude how much here? Mass of the body into acceleration of this non-inertial frame of reference. So that it pulls back, so that your frictional force is developed in this opposite direction. Look at this frictional force how much here? This is equal to, rest means here maximum value of static friction. Because this is equal to mu s, because this is a maximum value of static friction, this is. Ms, limiting friction is acting. Because this is a limiting friction. This limiting friction is, rest means limiting friction. Okay, whenever box is rest means pseudo force is equal to this limiting friction. Because this MA is equal to what? Limiting friction. So that MA is equal to limiting friction is equal to what? Mu s into mg. Here mm cancel. So that this maximum acceleration is equal to mu s into g. Then acceleration is equal to how much here? Acceleration is equal to mu s. Mu s value how much here? 0.12 into 10 is equal to 1.2. Acceleration is equal to 1.2 meter per second square. So like this here we can apply pseudo force. Yes, let us discuss the first of all, let us go to the friction. On friction, so many questions asked here. Most important topic is friction. Okay. Friction. So before going to discuss the friction, let's discuss the contact force. What is the contact force? Suppose two bodies are in contact. Net force acting on one body due to another body is a contact force. Suppose this is one body, this another body, this is A body, this is a B body, this is, or upper body, this is a lower body. This lower body exerts some force on the upper body. This is a contact force. Upper body also exerts some force at the lower body. This is also contact force. If you draw this your free body diagram of A and also free body diagram of your B, lower body. This contact force, this is a contact force. This contact force can be resolved into two components. This is a component of the contact force parallel to the surface. This is a component of the contact force perpendicular to the surface. This is a component of the contact force perpendicular to the surface. On the lower body also, this is a contact force. It can be resolved into two components. This is a component of the contact force parallel to the surface. This is a component of the contact force perpendicular to the surface. Component of the contact force parallel to the surface is known as frictional force. Component of the contact force perpendicular to the surface is known as normal force. This also frictional force. This is a normal force. This is normal force. Okay. Now, so contact force is what? Contact force is the resultant of these two forces. So now this contact force is equal to root over n square plus f square. But frictional force, F is known as frictional force. If frictional force is direct proportional to normal force, or F is equal to what? Mu into n, where mu is a coefficient of friction. So that contact force is equal to how much? Root over n square plus f square. F square means mu square n square. So that contact force is equal to n common root over 1 plus mu square. This is a contact force is equal to n into root over 1 plus mu square. Okay? But this is a contact force. If you observe, frictional force always action-reaction pair. Whenever two bodies are in contact here, this is an action-reaction pair. This is because this is a frictional force. Friction force always tangent to the surface, which always sometimes which opposes the motion, which supports the motion also. The frictional force. Okay. Yes. Now this frictional force are basically three types. There is a static friction and a kinetic friction and also rolling friction. First, let us talk about this magnitude and direction of the different types of frictions. Yes. Basically, frictions are three types. Static friction. Second one is a kinetic friction. Third one is a rolling friction. Rolling friction. Static friction. So, static friction, it has no direct formula. The self-adjusting force. Suppose a body is on the surface, this rough surface. It is a pulling force, this is a pulling force. If the pulling force 0, this is at rest, this is, body is at rest. The pulling force 0, body is at rest. So if the pulling force increases, static friction force, the static friction force, this is the static friction force. The pulling force 0, static friction force 0. First condition. The pulling force 0, static friction force is 0. This is. The static friction force is 0. The static friction force is 0. If the pulling force increases, static friction force also increases. When the body ready to move, static friction force becomes maximum. This maximum value of static friction is called limiting friction. This is equal to how much? This is equal to, it has formula mu s into n, where mu s is the coefficient of static friction. But in this condition is, if a pulling force is less than this limiting friction, in that case, frictional force how much here? Frictional force is equal to, body is at rest, then that is, this is equal to this a pulling force. Next, if the pulling force, this pulling force is more than limiting friction, then the body comes into motion. Whenever body comes into motion, whenever body moves like this, this pulling force, this frictional force is known as kinetic friction, moves with certain acceleration. Okay, now this is equal to kinetic friction. Kinetic friction is equal to what? Mu k into n. This is. Okay, so now mu k. Like this here. Whenever f is less than fl, then f is equal to what? Fs. Whenever f is more than, pulling force is more than limiting friction, body comes into motion, then kinetic frictional force is acting. That formula is what? Fk is equal to mu k into n. Next one, rolling friction. So whenever body rolls on the surface, go like this. When a body rolls on the surface, this linear velocity, this angular velocity, this rolling body, this is. When a body rolls like this here, now so frictional force acts, this slipping takes place at the point of contact, so that frictional force acts like this, a rolling friction. Rolling friction is equal to how much? Rolling friction is equal to mu r into n. This rolling friction. This is the direction of the rolling friction. But direction, what is the direction of static friction? Direction of static friction always opposite to net force acting on the body. Suppose net force acting on the body this direction, right side, here this frictional force is the left side here. So direction of static friction always opposite to net force acting on the body. Direction of kinetic friction always opposite to motion of the body. So body is moving right side, the direction of kinetic friction is left side. The body is moving left side, direction of frictional force is there right side. So this is the direction of your kinetic friction. Okay, yes. Let us solve some problems on the friction. So many times your question asked on the your friction. Yes, I'll give some examples from the previous year. Yes. One question 2025. In 2025 given in this problem here, one the smooth inclined plane. This is a smooth inclined plane, this is. This is a smooth inclined plane. One body is sliding down like this. This is a smooth inclined plane. This is a rough inclined plane. This is a rough inclined plane, identical this is. This is a rough inclined plane. The body is sliding down. Sliding down. But now, time taken on the rough inclined plane, this is. Time taken, length is the same, identical. But to slide down on the rough inclined plane, now which one is more? On the rough inclined plane, it takes more time. How much time here this on the rough inclined plane, this is equal to n times on the smooth inclined plane. In this here formula is, if you find the coefficient of kinetic friction. Coefficient of kinetic friction is equal to formula, direct shortcut formula 1 minus 1 by n square tan theta. This is a concept, this is. This is a question concept, this is. This it has one shortcut formula. But in this question is given what? There are two inclined surface equal length of same angle of inclination. Theta is equal to given 45 degrees. So theta is equal to 45 degrees. Given body takes 2 times much time to slide down the rough surface. Given T on the rough surface is equal to 2 times the on the smooth surface. Means here n is equal to given, n value is 2, this is. Okay, find the coefficient of kinetic friction, nu k is equal to how much? We can use shortcut formula, this is shortcut formula, ready-made formula, that is 1 minus 1 by n square tan theta. So that mu k is equal to what? 1 minus 1 by 2 square into tan 45 degrees. Okay, this is equal to 1 minus 1 by 4. This is a tan 45 1. 1 minus 1 by 4 is equal to 3 by 4 is equal to 0.75. This is a coefficient of kinetic friction. This question asked in the 2025 this is. Okay, next. Yes, one more question. 2023. A block of mass 2 kg is placed on the inclined surface of coefficient of friction mu. Mu is equal to 1 by root 3 given. Mu is equal to 1 by root 3. The net force on the block is. One inclined plane is given like this. This angle of inclination 30 degrees. This is a body. This is. What is the net force? What is the net force acting on the block? Mass of the body also given. Mass of the body is given. These are 2 kg. Okay, what is the net force? So, body is moving along the inclined plane. Along the inclined plane, water force acting. First component of the weight along the inclined plane is a mg sin theta. Mg sin theta means here 2g sin 30 degrees. Okay, so now this is a pulling force. So that frictional force acting opposite direction. This is equal to what? Mu into n. N is equal to what? Mg cos theta. This is a mu mg cos theta. Okay, this is a mu mg cos theta. This is a frictional force. This is. Okay, first we have to find out this force. This force is equal to how much here? 2g. The 2g sin 30 degrees is equal to 2 into g into 10 sin 30. Sin 30 is equal to 1 by 2. Go 2 to cancel 10 Newton. This is. But mu mg sin mu mg cos theta is equal to how much? Mu is equal to 1 by root 3 and m is equal to g value 10. Cos 30 is equal to how much here? Root 3 by 2. Root 3 cancel 10 cancel. This is equal to 10 Newtons. This here, this force is equal to how much here? 10 Newtons. Upward force also 10 Newtons. So that net force will be 0. Upward force, downward force is same. So the net force will be 0. Net force acting on the body along the inclined plane will be 0. Okay. So this your answer is a 0. Okay. Now time is over. Thank you. Have a nice day.
Okay. Good afternoon, dear students. And now I will explain one more topic from human health and disease, that is cancer. Cancer. So, study of cancer is called oncology. What we call it, ma? Oncology. Study of cancer is called oncology. Actually, what happens in the cancer? How cancer actually comes to the human beings, to the peoples, means very simple process. First, you can take any normal cell. In every human beings, in the cells consist cancer causing viruses, or maybe cancer causing genes are present, but they are in the inactive mode. Under certain conditions in the sense, in the presence of carcinogens, that may be physical carcinogens or chemical carcinogens or biological carcinogens. These normal cells containing inactivated genes becomes inactivated. As a result, that normal cells transformed into oncogenic cells, also known as neoplastic cells. Such type of neoplastic cells or oncogenic cells will undergoes uncontrolled cell division. As a result, masses of cells together forms into tumors. That is actually called as cancer. Okay, ma? So, cancer means very simple. The normal cells in the presence of mutation by maybe carcinogens. As a result, uncontrolled cell division. Uncontrolled cell division occurs. You all know that if cell division is controlled, the number of cells are also controlled, right, in a tissues. When the cell division is uncontrolled, leads to what happens? Masses of cells are formed. Masses of cells. Uncontrolled cell division resulting. What happens, ma? Formation of masses of cells. These masses of cells together forms into tumors. So this is called cancer. Okay na? So cancer ಹೇಗೆ ಬರುತ್ತೆ? Different types of cancers ಯಾಕೆ ಆಗುತ್ತೆ ಅಂದರೆ, ನಾರ್ಮಲ್ ಸೆಲ್ಸ್ ಯಾವಾಗ ಕಾರ್ಸಿನೋಜನ್ಸ್ಗೆ ಎಕ್ಸ್ಪೋಸ್ ಆಗುತ್ತೋ, ಅದು ಫಿಸಿಕಲ್ ಆಗಿರ್ಬೋದು, ಕೆಮಿಕಲ್ ಆಗಿರ್ಬೋದು, ಬಯೋಲಾಜಿಕಲ್ ಆಗಿರ್ಬೋದು, those physical, chemical and biological carcinogens causes mutation. That means damaging of DNA, so called activity ಆಗೋದ್ರಿಂದ normal cells becomes cancer causing cells ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ. Neoplastic transformation ಆಗುತ್ತೆ. Those neoplastic or oncogenic transformed cells loses the property of cell division. As a result, these cells divides uncontrollably. As a result, masses of cells are formed. Masses of cells together forms into tumors. So that is called cancer. ಇದನ್ನೇ ನಾನು ಡಯಾಗ್ರಾಮ್ಯಾಟಿಕ್ ಫಾರ್ಮಲ್ಲಿ ನೀವು ತೋರಿಸ್ಬೇಕು ಅಂದರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿಮ್ಮ, ಫಸ್ಟ್ ಒಂದು ಸೆಲ್ ತಗೊಳ್ಳಿ, ಇದು ನಾರ್ಮಲ್ ಸೆಲ್ ಮಾ. ಯಾವ ಸೆಲ್ ಇದು? ನಾರ್ಮಲ್ ಸೆಲ್. ಒಂದು ವೇಳೆ ಈ ನಾರ್ಮಲ್ ಸೆಲ್ಗೆ ಏನಾದರೂ exposed to the radiations ಅನ್ಕೊಳ್ಳಿ, UV radiations, maybe X-ray or maybe gamma ray, or maybe you can take better example, UV rays from the sunlight. So when a normal cell exposed to the UV radiations, these UV radiations directly falls on our skin cells, right? These UV radiations comes under non-ionizing radiations. They are very dangerous and powerful rays, right? So that will cause us damaging of DNA. Nodi, ee cell inside iro DNA na damage madutte. This is one piece. This is another piece. So here the DNA is breakdown. That means here what happens ma? Mutation happens. Mutation occurs. When a normal cell exposed to the carcinogens, a physical, chemical or biological, here radiations comes under the physical carcinogens. Avaga ಏನಾಗುತ್ತೆ, ಈ ಸೆಲ್ ಒಳಗಡೆ ಇರೋ DNA ಡ್ಯಾಮೇಜ್ ಆಗುತ್ತೆ. As a result, the normal cells becomes, the normal cell white color, actually this is the color, right? Normal cells becomes cancer causing cells ಆಗುತ್ತೆ. ನೋಡಿ, this is called a cancer cell. Cancer cell. You know, normal cell, in normal cell, when it is not exposing to the carcinogens, the cell growth, the cell division and the cell differentiation is completely under control and regulated. Is it clear? But when the cell is exposed to the carcinogens like UV radiations, the DNA present in that normal cell becomes damaged. As a result, normal cell is transformed into cancer causing cells. Now, in this cancer causing cells, cell growth and cell division and cell differentiation is uncontrollable. That means the cell functions, cell divisions are not regulated. As a result, what happens, you know, these cancer cells undergoes rapid divisions and produces masses of cells into tumors. See, this is called tumor. So this is the formation of cancer in generally in every, in the cancer patients. Okay ma, very clear. The normal cells, when they are exposed to the carcinogens, that carcinogens may be physical or chemical or biological. As a result, this is one type of process. In some other cases maybe not only damaging of DNA, okay, that will leads to normal cells transformed into cancer cells. Cancer cells lost the property of cell division. Controlled cell division ಅನ್ನೋದು ಆಗಲ್ಲ. ಅದರಿಂದ ಈ ಕ್ಯಾನ್ಸರ್ ಸೆಲ್ಸ್ ಏನಾಗುತ್ತೆ ಅನ್ಕಂಟ್ರೋಲಬಲ್ ಡಿವಿಷನ್ ಸ್ಟಾರ್ಟ್ ಆಗಿಬಿಟ್ಟು ಮಾಸಸ್ ಆಫ್ ಸೆಲ್ಸ್ ಫಾರ್ಮ್ ಆಗಿ ಟ್ಯೂಮರ್ಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ, ಅದನ್ನೇ ಕ್ಯಾನ್ಸರ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ನೌ ದಿಸ್ ಕ್ಯಾನ್ಸರ್ ಈಸ್ ಒನ್ ಆಫ್ ದ ಮೋಸ್ಟ್ dreaded, fatal, non-infectious disease. Non-infectious disease. Cancer is one of the dreaded disease. Okay, right. So here cancer is one of the dreaded, nothing but dangerous, fatal means causes death, and non-infectious disease because cancer cannot spread from one person to another person in any medium. So it is called non-infectious disease. And also one more important thing about cancer, dear students, in every year nearly 1 million people are suffering from the cancer, suffer from the cancer. Among them many people are died. In every year nearly more than 1 million people are suffering from the cancer. Among them some people are cured, and majority of people among that 1 million will be died. Hence it is called one of the most dreaded, fatal, non-infectious diseases. Okay na? Now as per this statement we will see some differences between normal cells and cancer cells. Normal cells characters and cancer cells characters. Characteristics of normal cells and cancer cells. First one, you all know that in normal cells cell division, cell growth, cell differentiation is controlled and regulated. ಅಂದರೆ ನಾರ್ಮಲ್ ಸೆಲ್ಸಲ್ಲಿ ಯಾವಾಗ ಒಂದು ಸೆಲ್ ಡಿವೈಡ್ ಆಗಬೇಕು, ಎಷ್ಟು ಸತಿ ಡಿವೈಡ್ ಆಗಬೇಕು, ಎಷ್ಟುವರೆಗೂ ಗ್ರೋ ಆಗಬೇಕು, ಆ್ಯಂಡ್ ಯಾವಾಗ ಡಿಫ್ರೆನ್ಷಿಯೇಷನ್ ಆಗಬೇಕು ಅನ್ನೋದು ಕಂಪ್ಲೀಟ್ಲಿ ಅಂಡರ್ ದ ಕಂಟ್ರೋಲ್ ಆ್ಯಂಡ್ ರೆಗ್ಯುಲೇಟ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಮಾಸಸ್ ಆಫ್ ಸೆಲ್ಸ್ ಲೀಡ್ಸ್ ಟು ಟ್ಯೂಮರ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗೋಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ ನಾರ್ಮಲ್ ಸೆಲ್ಸಲ್ಲಿ. ಬಟ್ ಇನ್ ದ ಕೇಸ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್ ಸೆಲ್ಸ್, ಯು ನೋ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ಬಿಕಾಸ್ ಆಫ್ ಮ್ಯುಟೇಷನ್ಸ್ ಆಗಿರ್ಬೋದು ಆರ್ ಬಿಕಾಸ್ ಆಫ್ ಎನಿ ಅದರ್ ಕಾರ್ಸಿನೋಜೆನಿಕ್ ಎಫೆಕ್ಟ್ಸ್ ಆಗಿರ್ಬೋದು, that the cancer cells cell division and cell growth and cell differentiation is uncontrolled and not regulated in the cancer cells. Cell growth, cell division and cell differentiation is completely out of control. Nothing but they can divide in their own style, because these cells are not regulated. Understand? This is one major difference between characteristics of normal cells and cancer cells. And the second one is Normal cells can show property of contact inhibition. Contact inhibition. Normal cells can show property of contact inhibition. Contact inhibition means when normal cells contact with other cells, they controls or they stops, they inhibits their uncontrolled growth. For example, because of some incident, 150 cells are lost from your body parts. ಅನ್ಕೊಳ್ಳಿ, ನಿಮ್ಮ ಬಾಡಿಯಲ್ಲಿ ಯಾವುದೋ ಒಂದು ಈ ಥರ ಶಾರ್ಪ್ ಆಬ್ಜೆಕ್ಟ್ಸ್ ಸೋಕಾಲ್ ತಡ್ಕೊಂಡು ಹೋಗೋದ್ರಿಂದ ಒಂದು 50 ಸೆಲ್ಸ್ ರಿಮೂವ್ ಆಗಿದೆ, ಲಾಸ್ ಆಗಿದೆ ಅಂದ್ಕೊಳ್ಳಿ. ಇವಾಗ ನೀವು ನೋಡ್ತಿರೋ ಈ ಬ್ರೌನ್ ಸೆಲ್ಸ್ ಎಲ್ಲ ಅದರ್ ಸೆಲ್ಸ್ ಅಂದರೆ ಓಲ್ಡ್ ಸೆಲ್ಸ್. ದೆನ್ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್? one of the normal cell will start division and produces new cells, 2 cells, 4 cells, 8, 10, 20, 30, 40, 50 cells are produced. If 50 cells are filled within that gap, automatically the normal new cells will contact with the other cells, no? Old cells, no? These other cells will inhibits, will stops the division of their uncontrolled division of new cells, normal cells. As a result, problem solved. 50 cells ಹೋಗಿದ್ರೆ 50 cells ರಿಪ್ಲೇಸ್ ಆಗುತ್ತೆ, ಯಾವ ಥರ ಟ್ಯೂಮರ್ ಫಾರ್ಮೇಷನ್ ಆಗಲ್ಲ. ಸೊ ಕಾಂಟ್ಯಾಕ್ಟ್ ಇನ್ಹಿಬಿಷನ್ ಅನ್ನೋದು ನಮ್ಮ ಬಾಡಿಯಲ್ಲಿ ಆ ಥರ ವರ್ಕ್ ಆಗುತ್ತೆ. ಕ್ಲಿಯರ್? ಬಟ್ in the case of cancer cells, what happens? They lost the property of contact inhibition. So in the cancer cells lost the property of contact inhibition. As a result, you know what happens? Even after 50 cells ಆದ್ಮೇಲೆ still they undergoes uncontrolled cell division into 1000, 2000, 3000, like masses of together forms into tumor formation takes place. When the cancer cells lost the property of contact inhibition, what happens? Cells keep multiply keep dividing rapidly, leads to formation of masses of cells. As a result, tumors are formed. So that is the main principle we can see in the cancer causing cells. Okay, this is the second difference. And the third difference is cancer cells do not show metastasis. Cancer cells do not show metastasis. Here metastasis means what? Spreading of cells or something, substances to the different parts of the body is called metastasis. So such type of spreading not takes place in the cancer cells. ನಮ್ಮ ಬಾಡಿಯಲ್ಲಿ ನಾರ್ಮಲ್ ಸೆಲ್ಸ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗುತ್ತೋ ಅದೇ ಆರ್ಗನಲ್ಲಿ ಅಲ್ಲೇ ಇರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಕಿಡ್ನಿ ಸೆಲ್ಸ್ ಲಿವರ್ಗೆ ಹೋಗಲ್ಲ, ಲಿವರ್ ಸೆಲ್ಸ್ ಲೆಫ್ಟ್ ಲೆಗ್ಗೆ ಹೋಗಲ್ಲ, ರೈಟ್ ಲೆಗ್ ಸೆಲ್ಸ್ ಹೆಡ್ಗೆ ಹೋಗಲ್ಲ. ಓಕೆನಾ? ಸೊ ನಾರ್ಮಲ್ ಸೆಲ್ಸ್ ಡು ನಾಟ್ ಸ್ಪ್ರೆಡ್ಸ್ ಟು ದ ಡಿಫ್ರೆಂಟ್ ಪಾರ್ಟ್ಸ್ ಆಫ್ ದ ಬಾಡಿ. ಸೊ ಸಚ್ ಕೈಂಡ್ ಆಫ್ ಮೆಟಾಸ್ಟಾಸಿಸ್ ಈಸ್ not available in the normal cells, but in the case of cancer causing cells show metastasis. Metastasis means what, dear students? Spreading of cancer cells, spreading of cancer cells to the different parts of the body. How these cancer cells or tumor cells spreads to the different parts of the body? By the blood. Blood is the transport medium for the spreading of tumor cells in the cancer patients. Understand? So this is the third difference between normal cells and cancer cells. And fourth difference is normal cells do not produce tumors. You know why? Because in the normal cells, cell division is under the control. So no chance to formation of tumors. But in the case of cancer cells, tumors are formed. Cancer cells forms tumors. You understand? So this is the main difference between normal cells and cancer causing cells. Okay ma? Based on the severity, there are two types of tumors we can see. Cancerous tumors we can see. So what are the types of tumors we'll see now. Types of tumors. One is benign tumors. Second one is malignant tumors. One is benign tumors. Second one is malignant tumors. Dear students, here benign tumors are confined to their original location. That means benign tumors cannot spread from one part of the body to another part of the body. A cancer patient alli ಈ ಟ್ಯೂಮರ್ಸ್ ಎಲ್ಲಿ ಫಾರ್ಮ್ ಆಗುತ್ತೋ ಅಲ್ಲೇ ರಿಸ್ಟ್ರಿಕ್ಟ್ ಆಗಿರುತ್ತೆ. ಬೇರೆ ಕಡೆ ಸ್ಪ್ರೆಡ್ ಆಗಿಬಿಟ್ಟು ಬೇರೆ ಬೇರೆ ಟ್ಯೂಮರ್ಸ್ ಫಾರ್ಮ್ ಮಾಡಲ್ಲ. ಸೋ ಕಾಲ್ಡ್ ದೇ ಆರ್ harmless tumors. They do not show any type of metastasis. Okay? So the benign tumors are confined to their original location. That means they do not spread from one part of the body to another part of the body. But in the case of malignant tumors, they show metastasis, means spreading of tumors to different parts of the body. Different parts of the body by blood. This process is called metastasis. We already discussed. Generally, which tumors do not show metastasis? Benign tumors. Why? Because they confine to their original location. Then which tumors show metastasis? Malignant tumors, because they can spread to the different parts of the body. And next point, they cause us less damage. You know why? Because they are not spreading to the different parts of the body. So they do not cause us much damage. So they must be causes less damage and less harmful also. They are less harmful. They can survive easily. You know one more thing, because of benign tumors, I mean they cannot spread to the different parts of the body. We can remove such type of tumors easily by the surgery. Okay, so benign tumors removed by the surgery. removed by the surgery. But in the case of malignant tumors, they cause us more damage. Why? Because if one tumor forms in one location, some of that cells, tumor cells, will spread to the another part, and where also one more tumor is formed. Likewise, different parts of the body, many tumors are formed. How many tumors we can remove by the surgery? Is it possible to remove all the tumors? If we remove one tumor by the surgery, in the next few days only one more tumor we got. So the cancer patients will get. So it is impossible, difficult to remove such type of malignant tumors with the help of surgery. So they obviously causes more damage and more harmful. And also we cannot remove by surgery. Now surgery ಮಾಡಿ remove ಮಾಡೋಕೆ ಆಗಲ್ಲ. Okay, so these are the two types of tumor cells, cancer tumor cells. Next, how generally cancer causes? In some peoples, in some human beings, how cancer causes? Causes of cancer. Causes of cancer. Dear students, cancer is caused by carcinogens. How cancer causes, Cancer caused by the carcinogens. What are carcinogens? Cancer causing agents are called carcinogens. The agents which can cause us cancer are called carcinogens. These carcinogens are three types. Maybe physical carcinogens, or maybe chemical carcinogens, or maybe biological carcinogens. Cancer is caused by carcinogens. What are carcinogens? Cancer causing agents are called carcinogens. How many types of cancers are there? Three types of carcinogens are there. How many types of carcinogens are there? Three types of carcinogens. Number one, physical carcinogens. Number two, chemical carcinogens. Number three, biological carcinogens. Here physical carcinogens means the agents physically causes, physical agents will cause us cancer. For example, physical carcinogens are two types. Ionizing, you must have clarity regarding this one. Ionizing carcinogens and also non-ionizing carcinogens. Physical carcinogens are again two types. Number one, ionizing carcinogens. Number two, non-ionizing carcinogens. Here, ionizing carcinogens includes two. One is X-rays. Number two, gamma rays. What are the examples for ionizing radiations? X-rays or gamma rays. Then non-ionizing radiations examples UV rays. ultraviolet. UV rays comes under the non-ionizing radiations. How these ionizing and non-ionizing radiations are also known as X-ray, UV ray, gamma ray causes cancer. Andre very simple, when the human body cells exposed to the X-ray, gamma ray or UV rays, as we discussed in the beginning of the topic, that will causes damages the DNA of the cell. As a result of damaging of the DNA of the cells, that normal cells becomes cancer causing cells. Cancer causing cells lost the property of cell division. As a result, they divides uncontrollably, leads to masses of cells and tumors formation takes place. That is the mode of causes of cancer. Okay, and then comes to the chemical carcinogens. Chemical carcinogens examples, tobacco smoke. Tobacco smoke. Still remaining chemicals are also there, but as per our topic, tobacco smoke is one of the chemical carcinogens. Dear students, chemical carcinogens example tobacco smoke, right? So the people, whenever they smoked tobacco or chewed or snuffed, as we discussed in the morning, by smoking or chewing or snuffing of tobacco may causes different types of cancers, right? But among all the cancers, the most common cancer caused by the chemical carcinogens is lung cancer. Lung cancer is one of the common cancer caused by the chemical carcinogens. Here skin cancer is one of the common cause of physical carcinogens. Understand ma? And last one come to the biological carcinogens. Very, very important ma. You may chance to get a question from this topic. Biological carcinogens includes number 1, oncogenic viruses. Oncogenic viruses. Here oncology means what you understand? Study of cancer. Then oncogenic viruses. Onco means what? Cancer. Genic means what? Causes. Viruses. So the viruses which causes cancer are known as oncogenic viruses anta karibodu, athava cancer causing viruses are called oncogenic viruses antanu heltiri. And then oncogenic viruses consist a genes called oncogenes. ಯಾಕೆಂದ್ರೆ ವೈರಸ್ ಅನ್ನೋದು ಒಂದು ಆರ್ಗಾನಿಸಮ್. ಆ ವೈರಸ್ ಒಳಗಡೆ ಇರೋ ಜೀನ್ಸ್ನ ನಾವೇನಂತ ಕರಿತೀರಿ? ಆಂಕೋಜೀನ್ಸ್ ಅಂತ ಕರಿತೀರಿ. ಆಂಕೋಜೀನ್ಸ್ ಅಂದರೆ ಏನಪ್ಪ? ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಜೀನ್ಸ್ನ ಆಂಕೋಜೀನ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಆಂಕೋಜೀನ್ಸ್ ಅಂದರೆ ಏನು? ದ ಜೀನ್ಸ್ ವಿಚ್ ಕಾಸಸ್ cancer or cancer causing genes are called oncogenes. This is one of the examples for biological carcinogens. Sir, ಇದು ಯಾವ ಥರ ಕ್ಯಾನ್ಸರ್ ಕಾಸ್ ಮಾಡುತ್ತೆ ಸರ್ ಅಂದರೆ, ನಾರ್ಮಲಿ ಈ ವೈರಸ್ ಇನ್ಆಕ್ಟಿವ್ ಸ್ಟೇಜಲ್ಲಿರೋ ಗಂಟ ಏನೂ ಆಗಲ್ಲ. ಸರ್ಟೈನ್ ಕಂಡೀಷನ್ಸಲ್ಲಿ ಮಾತ್ರನೇ ಈ ವೈರಸ್ ಏನು ಮಾಡುತ್ತೆ, ಅದರ ಜೆನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ನ ನಾರ್ಮಲ್ ಹೋಸ್ಟ್ ಸೆಲ್ ಒಳಗಡೆ ಇಂಜೆಕ್ಟ್ ಮಾಡುತ್ತೆ. ಈ ಜೆನೆಟಿಕ್ ಮೆಟೀರಿಯಲ್ ಫ್ರಮ್ ದ ಆಂಕೋಜೆನಿಕ್ ವೈರಸಸ್ ನಾರ್ಮಲ್ ಹೋಸ್ಟ್ ಸೆಲ್ಲಲ್ಲಿ ಇಂಜೆಕ್ಟ್ ಮಾಡಿದಾಗೆ ದಟ್ ನಾರ್ಮಲ್ ಸೆಲ್ಸ್ ಬಿಕಮ್ಸ್ ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಸೆಲ್ಸ್. ಸೊ ಲಾಸ್ ದ ಪ್ರಾಪರ್ಟಿ ಆಫ್ ಸೆಲ್ ಡಿವಿಷನ್. ಆಸ್ ಎ ರಿಸಲ್ಟ್ ಡಿವೈಡ್ಸ್ ರ್ಯಾಪಿಡ್ಲಿ and formed into masses of cells together into tumor formation takes place. And the second examples for biological carcinogens, cellular oncogenes. Cellular oncogenes also known as C-onc. Cellular oncogenes also known as C-onc. Here cellular oncogenes also known as C-onc and also proto-oncogenes. Proto-oncogenes. These are actually normal cells. Cancer causing genes present in the cells of every human being. These cancer causing genes present in the protoplasm of the cell or inside the cell also present, but they are in inactive mode. Under certain conditions, for example, when the cell is mutated because of physical, chemical or biological conditions, what will happen, sir? These inactive normal cellular oncogenes or C-onc or proto-oncogenes are transformed into neoplastic cells or cancer causing cells or oncogenic cells, leads to uncontrolled cell division, tumors formation, cancer causing takes place. Understand? So these are the three types of carcinogens, very very important ma, please note and follow it, okay na. And then I will go for the types of cancers. Types of cancers. Yeah, it is unofficial to our NCERT, but important. Sometimes we may get questions from this topic also. Types of cancers, first one, carcinoma. Carcinoma cancer. What is carcinoma cancer means? Cancer to the epithelial cells is called carcinoma. Andre ಒಂದು ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಅಲ್ಲಿ ಎಪಿಥೀಲಿಯಲ್ ಸೆಲ್ಸ್ಗೆ ಬರೋ ಕ್ಯಾನ್ಸರ್ನ ಕಾರ್ಸಿನೋಮಾ ಅಂತಾರೆ. ನಿಮ್ಮೆಲ್ರಿಗೂ ಗೊತ್ತು, ಯು ಆರ್ ವೆರಿ ವೆರಿ ಟ್ಯಾಲೆಂಟೆಡ್. ಎಪಿಥೀಲಿಯಲ್ ಸೆಲ್ಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಈಚ್ ಆ್ಯಂಡ್ ಎವ್ರಿ ಆರ್ಗಾನ್ಸ್ ಆಫ್ ದ ಆರ್ಗಾನಿಸಮ್, ಓಕೆನಾ. ಸೊ ನಮ್ಮ ಬಾಡಿ ಸ್ಕಿನ್ನಿಂದ ತಗೊಂಡು ಎಲ್ಲ ಆರ್ಗಾನ್ಸ್ ಎಕ್ಸ್ಟರ್ನಲಿ ಆ್ಯಂಡ್ ಇಂಟರ್ನಲಿ ಕವರ್ಡ್ ಬೈ epithelial cells, especially external surface of the organs, where there is a chance to cause of carcinoma. For example, for carcinoma cancers, you know, skin cancer, epithelial tissues, right? So skin cancer is example for carcinoma, and also breast cancer carcinoma, and also brain cancer is also comes under the carcinoma type, okay ma. And second one, sarcoma. Here carcinoma means cancer to the epithelial tissues. Example, skin cancer, brain cancer, breast cancer, etc. ಹೌದಾ? ಅದೇ ಥರ ಸಾರ್ಕೋಮಾ ಮೀನ್ಸ್ ಕ್ಯಾನ್ಸರ್ ಟು ದ mesodermal tissues. You know, each and every organ in our body developed from the any one of the three germ layers. Am I right? Ectoderm, endoderm, mesoderm. ಸೊ ಮೀಸೋಡರ್ಮಿಂದ ಏನೇನು ಟಿಶ್ಯೂಸ್ ನಮ್ಮ ಬಾಡಿಯಲ್ಲಿ ಹ್ಯೂಮನ್ಸಲ್ಲಿ ಫಾರ್ಮ್ ಆಗುತ್ತೋ ಆ ಮೀಸೋಡರ್ಮ್ ಲೇಯರಿಂದ ಫಾರ್ಮ್ ಆಗಿರೋ ಟಿಶ್ಯೂಸ್ಗೆ, ಆರ್ಗಾನ್ಸ್ಗೆ ಈ ಕ್ಯಾನ್ಸರ್ ಬರೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಏನು ಸರ್ ಅದು ಮೀಸೋಡರ್ಮಲ್ ಟಿಶ್ಯೂಸ್ ಅಂದರೆ? ಎಕ್ಸಾಂಪಲ್ಸ್, ಮಸಲ್ ಕ್ಯಾನ್ಸರ್ ಆ್ಯಂಡ್ bone cancer. Yeah, muscle and bones both are mesodermal origin tissues, okay. And third one, melanoma. Melanoma cancer. Here melanoma means, you know, melanin. Yeah, the cancer to the melanocytes. Melanocytes of the skin is called melanoma cancer anta karitare. Yavage ee physical radiations in the melanocytes present in the skin will be mutated. As a result, the cancer is called melanoma. So it is also one type of skin cancer anta helbodu. And next one, leukemia. Leukemia cancer. It is cancer to the white blood cells, WBC cells, also known as blood cancer antanu karitare alwa. So the cancer to the WBC cells is known as leukemia, we call it. And next one, lymphoma. Lymphoma cancer. Lymphoma cancer means cancer to the blood cells or lymphatic system or lymphatic cells. Cancer to the lymphatic system or blood cells. Blood cells andre enu? B lymphocytes, T lymphocytes are also part of lymphatic system, are also one type of blood cells only, right? ಈ ಥರ ಈ ಅಬ್ನಾರ್ಮಲ್ ಕೌಂಟ್ ಆಫ್ ಲಿಂಫ್ಯಾಟಿಕ್ ಸೆಲ್ಸ್ ಲೀಡ್ಸ್ ಟು ಲಿಂಫೋಮಾ ಕ್ಯಾನ್ಸರ್ ಅಂತ ಕರೀತಾರೆ. ಓಕೆ, ಇವು ಕೆಲವು ಟೈಪ್ಸ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್ಸ್ ಅಮ್ಮ. ಓಕೆ, ರೈಟ್. Okay, next diagnosis and detection of cancer. Detection and diagnosis. ಕ್ಯಾನ್ಸರ್. ಸೊ ನಾವು ಒಂದು ಪರ್ಸನ್ಗೆ ಕ್ಯಾನ್ಸರ್ ಇದೆ, ಕ್ಯಾನ್ಸರ್ ಬಂದಿದೆ ಅನ್ನೋ ವಿಷಯ ನಾವು ಹೇಗೆ ಯಾವ ಮೆಥಡ್ಸಿಂದ ತಿಳ್ಕೊತೀರಿ ಅನ್ನೋದೇ ಡಯಾಗ್ನೋಸಿಸ್ ಆ್ಯಂಡ್ ಡಿಟೆಕ್ಷನ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್. ಅದರಲ್ಲಿ ದ ಫಸ್ಟ್ ಮೆಥಡ್ ಈಸ್ ಬಯಾಪ್ಸಿ ಆ್ಯಂಡ್ histopathological study. Histopathological studies. It is the first method we use it to detect or diagnose the cancer in the patients, in the persons. So here what we do exactly in the biopsy method andre, a piece of suspected tissue, a piece of suspected tissue extracted and cut into very thin section that will be stained and observed under microscope with the help of pathologist. Here pathologist means the person who studied about pathogens. Here histopathological, histo andre study of tissues anta artha, histology andre tissues, pathological andre study of pathogens. Pathology means study of pathogens. Pathologist means the person who study about pathogens is called pathologist. So here ಒಂದು ಪರ್ಸನ್ಸಲ್ಲಿ ಕ್ಯಾನ್ಸರ್ ಇದೆಯಾ ಇಲ್ಲ ಅಂತ ಈ ಮೆಥಡಿಂದ ಹೆಂಗೆ ಗೊತ್ತಾಗುತ್ತಂದರೆ, ಆ ಪರ್ಸನ್ನಿಂದ ಒಂದು ಸ್ವಲ್ಪ ಟಿಶ್ಯೂಸ್ ತಗೊಂಡು ಅದನ್ನು ಒಂದು ಥಿನ್ ಸೆಕ್ಷನ್ ಆಗಿ ನಾವು ಸ್ಟೆಮ್ ಕಟಿಂಗ್ ಹೇಗೆ ಮಾಡ್ತೀರಿ, ರೂಟ್ ಟಿ ಎಸ್ ಆಫ್ ಸ್ಟೆಮ್ ಥರ. ಸೊ ಥಿನ್ ಸೆಕ್ಷನ್ ತೆಗೆದುಬಿಟ್ಟು ಅದಕ್ಕೊಂದು ಸ್ಟೇನ್ ಅಪ್ಲೈ ಮಾಡಿ ಅದನ್ನು ಮೈಕ್ರೋಸ್ಕೋಪಲ್ಲಿ ಪ್ಯಾಥಾಲಜಿಸ್ಟ್ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತಾರೆ. ಯಾಕಂದರೆ ಪ್ಯಾಥಾಲಜಿಸ್ಟ್ಗೆ ಗೊತ್ತು ಯಾವುದು ನಾರ್ಮಲ್ ಟಿಶ್ಯೂಸು, ಯಾವುದು ನಾರ್ಮಲ್ ಸೆಲ್ಸು. ಒಂದು ವೇಳೆ ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಜೀನ್ಸ್ ವೈರಸಸ್ ಇದ್ದರೆ ಯಾವ ಥರ ಅಬ್ನಾರ್ಮಲಿಟಿ ಇದೆ ಅನ್ನೋ ವಿಷಯ ಅವ್ರು ಡಿಟೆಕ್ಟ್ ಮಾಡೋ ಕ್ಯಾಪಬಿಲಿಟಿ ಅವ್ರಿಗಿರುತ್ತೆ. ಸೊ ಅವರು ಆ ಸೆಲ್ಸಲ್ಲಿ ವೆದರ್ ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಜೀನ್ಸ್ ಆರ್ ವೈರಸಸ್ ಆರ್ ಪ್ರೆಸೆಂಟ್ ಆರ್ ನಾಟ್ ಅನ್ನೋ ವಿಷಯ ಅವರು ಸ್ಟಡಿ ಮಾಡಿ ದೇ ವಿಲ್ ಕನ್ಫರ್ಮ್ ದ ಕ್ಯಾನ್ಸರ್. ಓಕೆ, ದಿಸ್ ಈಸ್ one type of method. Clear ma? So in the biopsy and histopathological study, a piece of tissue collected from the suspected person and cut into thin section and stained and observed microscope to detect the whether pathogenic or not with the help of pathologist. And the second method is blood and bone marrow test. Blood and bone marrow test. So in this method, either we will collect a small sample of blood from the suspected person, or we collect a small amount of bone marrow from the bone. In that they will study, they will detect they will count the approximate number of WBC cells, whether per 1 cubic millimeter of blood in the normal persons how many WBCs are present ma? 6,000 to 8,000, right? If more than that, that is abnormal condition. So increased WBC cells in the persons is indication of blood cancer, that is like leukemia. To detect leukemia cancer to the WBC cells detect ಮಾಡೋದಕ್ಕೆ ನಾವು ಈ ಮೆಥಡ್ನ ಯೂಸ್ ಮಾಡ್ತೀರಿ. By blood and bone marrow test, which cancer we can detect means leukemia or blood cancer. On what basis we can detect andre based on the WBC count, increased WBC count. Okay, and the third one is radiography. ರೇಡಿಯೋಗ್ರಫಿಯಲ್ಲಿ ಏನು ಮಾಡ್ತೀರಿ, ಡೈರೆಕ್ಟ್ಲಿ ವೆರಿ ಸಿಂಪಲ್ ಪ್ರಾಸೆಸ್, ವಿ ಯೂಸ್ ಎಕ್ಸ್-ರೇಸ್. ಯಾವ ಪರ್ಸನ್ಗೆ ಕ್ಯಾನ್ಸರ್ ಇದೆ ಅಂತ ಐಡೆಂಟಿಫೈ ಮಾಡಬೇಕು ಅಂದ್ಕೊಂಡಿರ್ತೀರೋ ಆ ಪರ್ಸನ್ಸ್ನ ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾರ್ಟ್, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲಂಗ್ ಕ್ಯಾನ್ಸರ್ ಮೇಲೆ ಡೌಟ್ ಇರುತ್ತೆ, ಈ ಥರ ಒಂದು ಸ್ಪೆಸಿಫಿಕ್ ಕ್ಯಾನ್ಸರ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋಕ್ಕೆ ಆ ಪಾರ್ಟ್ನ ಡೈರೆಕ್ಟ್ಲಿ ಎಕ್ಸ್-ರೇ ಯೂಸ್ ಮಾಡಿಬಿಟ್ಟು ಇಮೇಜ್ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಬೈ ಯೂಸಿಂಗ್ ಎಕ್ಸ್-ರೇ ದೇ ವಿಲ್ ಗೆಟ್ ಆ್ಯಂಡ್ ಅಬ್ಸರ್ವ್ ವೆದರ್ ಇಫ್ ಎನಿ ಟ್ಯೂಮರ್ ಫಾರ್ಮೇಷನ್ ಆರ್ ಇಫ್ ಎನಿ ಅಬ್ನಾರ್ಮಲಿಟೀಸ್ ಇನ್ ದ ಆರ್ಗನ್ ಅನ್ನೋ ವಿಷಯನ ಡಿಟೆಕ್ಟ್ ಮಾಡ್ಬೋದು ಬೈ ಯೂಸ್ ಮೇ ಬಿ ನೀವೆಲ್ಲರೂ ನೋಡೇ ಇರ್ತೀರಾ. ಸೊ ಎಕ್ಸ್-ರೇ ಪಿಕ್ಚರ್, ರೈಟ್? ಸೊ ಆ ಎಕ್ಸ್-ರೇ ಪಿಕ್ಚರಲ್ಲಿ ಏನು ಗೊತ್ತಾಗುತ್ತಂದರೆ ವೆದರ್ ಆರ್ಗನ್ಸ್ ಆರ್ ನಾರ್ಮಲಾ, ಐದರ್ ಎನಿ ಟ್ಯೂಮರ್ಸ್ ಆರ್ ಫಾರ್ಮ್ಡ್ ಆರ್ ನಾಟ್ ಅನ್ನೋ ವಿಷಯನ ತಿಳ್ಕೊಳ್ಳೋದಕ್ಕೆ ಕನ್ಫರ್ಮೇಷನ್ ಮಾಡೋದಕ್ಕೋಸ್ಕರ ಈ ರೇಡಿಯೋಗ್ರಫಿನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ರೇಡಿಯೋಗ್ರಫಿಯಲ್ಲಿ ಏನು ಯೂಸ್ ಮಾಡಿ ಕ್ಯಾನ್ಸರ್ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾರೆ ಅಂದರೆ ಎಕ್ಸ್-ರೇಸ್ನ ಯೂಸ್ ಮಾಡಿ. ಓಕೆ, ಯಾ. ನೆಕ್ಸ್ಟ್ ಒನ್, CT scan. CT scan, full form computed tomography, we call it. CT, full form what ma? Computed tomography. So in this method, what we do? We obtain, of course, in the CT scan also, we use X-rays. We use X-rays, thereby we get 3D image. 3-dimensional ಇಮೇಜ್ನ ನಾವು ಪಡಿಬೋದು. ಅಂದರೆ ಎಕ್ಸಾಕ್ಟಾಗಿ ನಮ್ಮ ಮುಂದೆ ಕಂಪ್ಯೂಟ್ರಲ್ಲಿ 3-dimensional ವ್ಯೂ ಆಫ್ ಇಮೇಜ್ ಸಿಗುತ್ತೆ. ಫ್ರಂಟ್, ಸೈಡ್ಸ್, ಬ್ಯಾಕ್, ಎಲ್ಲಿ ಎಕ್ಸಾಕ್ಟಾಗಿ ಯಾವ ಆರ್ಗನಲ್ಲಿ ಯಾವ ಥರ ಇದೆ, ವೆದರ್ ಎನಿ ಟ್ಯೂಮರ್ ಫಾರ್ಮೇಷನ್ ಅಕರ್ಸ್ ಇನ್ ದ ಬಾಡಿ ಆರ್ ನಾಟ್ ಅನ್ನೋ ವಿಷಯ ಕಂಪ್ಲೀಟಾಗಿ ಸ್ಟಡಿ ಮಾಡ್ಬೋದು. ಸೊ ದ್ಯಾಟ್ ಈಸ್ ಕಾಲ್ಡ್ CT scan. ಇನ್ ದ CT scan ಆಲ್ಸೋ ವಿ ಯೂಸ್ X-rays. By using X-ray we get 3-dimensional image. By this 3-dimensional image of internal organs we can study cancer of the internal organs. ಓಕೆ, ಇಂಟರ್ನಲ್ ಆರ್ಗಾನ್ಸ್ಗೆ ಯಾವುದಾದಕ್ಕೂ ಕ್ಯಾನ್ಸರ್ ಬಂದಿದೆಯಾ ಯಾವುದಾದ್ರೂ ಆರ್ಗಾನ್ಗೆ ಅನ್ನೋ ವಿಷಯನ ಫೈಂಡ್ ಔಟ್ ಮಾಡೋದಕ್ಕೆ CT ಸ್ಕ್ಯಾನ್ನ ಯೂಸ್ ಮಾಡ್ತೀರಿ. ರೇಡಿಯೋಗ್ರಫಿ ಆಲ್ಸೋ ವಿ ಯೂಸ್ ಇಟ್ ಟು ಡಿಟೆಕ್ಟ್ ಕ್ಯಾನ್ಸರ್ ಆಫ್ ಇಂಟರ್ನಲ್ ಆರ್ಗಾನ್ಸ್. CT scan also used to detect cancer of internal organs. And another one is MRI scan. MRI scan, full form magnetic and resonance image. MRI stands for magnetic and resonance image. Dear students, in this method we use highly magnetic fields, and also non-ionizing radiations, nothing but UV rays. Non-ionizing radiations are used. You know what? For what? By MRI scan they use highly magnified fields and non-ionizing radiations, and they will accurately detect the pathological and physiological changes in the living tissues. Okay, ಬಾಡಿಯಲ್ಲಿ ಟಿಶ್ಯೂಸಲ್ಲಿ ಎಲ್ಲಾದರೂ ಪ್ಯಾಥೊಲಾಜಿಕಲ್ ಎನಿ ಪ್ಯಾಥೋಜನ್ ಇನ್ಫೆಕ್ಷನ್ ಆಗಿದೆಯಾ, ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಪ್ಯಾಥೋಜನ್ಸ್ ಏನಾದರೂ ಇದೆಯಾ, ಆರ್ ಎನಿ ಚೇಂಜಸ್ ಇನ್ ದ ಫಿಸಿಯಲಾಜಿಕಲ್ ಆ್ಯಕ್ಟಿವಿಟಿ ಅನ್ನೋದನ್ನು ಫೈಂಡ್ ಔಟ್ ಮಾಡಿಬಿಟ್ಟು ಕ್ಯಾನ್ಸರ್ ಆಫ್ ಇಂಟರ್ನಲ್ ಆರ್ಗನ್ಸ್ ಕನ್ಫರ್ಮ್ ಮಾಡ್ತಾರೆ, ಡಿಟೆಕ್ಟ್ ಮಾಡ್ತಾರೆ. ಸೊ ದಿಸ್ ಮೆಥಡ್ ಈಸ್ ಆಲ್ಸೋ ಯೂಸ್ಫುಲ್ ಫಾರ್ ದ ಡಿಟೆಕ್ಷನ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್ ಆಫ್ ಇಂಟರ್ನಲ್ ಆರ್ಗನ್ಸ್. ಓಕೆ, ಆ್ಯಂಡ್ ನೆಕ್ಸ್ಟ್ ಒನ್, antibodies against cancer specific antigens. Yeah, so in this method what they do, how they detect cancer. For example, ಯಾರಾದರೂ ಪರ್ಸನ್ಸಲ್ಲಿ ಕ್ಯಾನ್ಸರ್ ಇದೆಯಾ ಇಲ್ಲ ಅಂತ ತಿಳ್ಕೋಬೇಕು ಅಂದ್ಕೊಳ್ಳಿ, ಆ ಪರ್ಸನ್ಗೆ ಸ್ಪೆಸಿಫಿಕ್ ಕ್ಯಾನ್ಸರ್ ಆ್ಯಂಟಿಬಾಡೀಸ್ನ ಇನ್ಸೆಟ್ ಮಾಡ್ತಾರೆ. ಇಫ್ ದೀಸ್ ಆ್ಯಂಟಿಬಾಡೀಸ್ ವಿಲ್ ಗೋ ಅಂಡ್ ಬೈಂಡ್ಸ್ ವಿತ್ ದ ಆ್ಯಂಟಿಜನ್ಸ್ ಆಫ್ ದಟ್ ಪರ್ಸನ್, ದಟ್ ಮೀನ್ಸ್ ಆ್ಯಂಟಿಜನ್ಸ್ ಇದೆ ಅಂದರೆ ಅವ್ರಿಗೆ ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಜೀನ್ಸ್ ಇದೆ, ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ವೈರಸಸ್ ಇದೆ ಅಂತ ಅರ್ಥ. ಅದನ್ನು ಆಟೋ ರೇಡಿಯೋಗ್ರಫಿಯಲ್ಲಿ ನೋಡಿಬಿಟ್ಟು ಕನ್ಫರ್ಮ್ ಮಾಡ್ತಾರೆ. ಓಕೆ, ಸೊ ಇಫ್ ನೋ ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಆ್ಯಂಟಿಜನ್ಸ್ ಅಂದ್ಕೊಳ್ಳಿ, ಆ್ಯಂಟಿಬಾಡೀಸ್ ಡು ನಾಟ್ ಬೈಂಡ್ಸ್, we can't see anything in the auto radiography. Okay, so this is the method also we use it to detect the cancer. And last one, techniques of molecular biology. Techniques of molecular biology. You all know that molecular biology techniques, right? Like PCR, ELISA. Okay, so by using these methods they will find out whether any cancer causing genes present in the persons or not. If they confirmed cancer causing genes are present in their body but they are in the inactive mode, ಆವಾಗ ಏನು ಮಾಡ್ತಾರೆ, ಅಂಥ ಪೀಪಲ್ಗೆ ಡಾಕ್ಟರ್ಸು ಸಜೆಸ್ಟ್ ಮಾಡ್ತಾರೆ, ನಿಮ್ಮಲ್ಲಿ ಆಲ್ರೆಡಿ ಕ್ಯಾನ್ಸರ್ ಕಾಸಿಂಗ್ ಜೀನ್ಸ್ ಇದೆ, ಯು ಮಸ್ಟ್ ಅವಾಯ್ಡ್ ಕಾರ್ಸಿನೋಜನ್ಸ್. ಅಂದರೆ ನೀವು ಈ ಥರ ಟೊಬ್ಯಾಕೋ, ನಿಕೋಟಿನ್, ಕೆಫಿನ್ ಈ ಥರ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ನೀವು ತಗೋಬಾರ್ದು. ತಗೊಂಡ್ರೆ ಅದು ಆಕ್ಟಿವೇಟ್ ಆಗಿಬಿಟ್ಟು ಕ್ಯಾನ್ಸರ್ ಬರೋಕ್ಕೆ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಅದೇ ಥರ ಈ ಥರ ಪರ್ಸನ್ಸ್ ಅವ್ರ ಮಕ್ಕಳಿಗೆ ನೆಕ್ಸ್ಟ್ ಇನ್ಹೆರಿಟೆನ್ಸ್ ಆಗುತ್ತಾ ಇಲ್ಲ, ಆಗೋಕ್ಕೆ ಎಷ್ಟು ಚಾನ್ಸಸ್ ಇದೆ ಅನ್ನೋ ವಿಷಯನೂ ನಾವು ಅವ್ರಿಗೆ ತಿಳಿಸ್ಬೋದು ಈ ಮೆಥಡ್ಸಿಂದ. ಓಕೆನಮ್ಮ? ಸೊ ದೀಸ್ ಆರ್ ಸಮ್ ಡಿಟೆಕ್ಷನ್ ಆ್ಯಂಡ್ ಡಯಾಗ್ನೋಸಿಸ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್. ಓಕೆ, ಆ್ಯಂಡ್ ದ ಲಾಸ್ಟ್ ಮೆಥಡ್ ಈಸ್ ಟ್ರೀಟ್ಮೆಂಟ್ ಆಫ್ ಕ್ಯಾನ್ಸರ್. ಇನ್ನು ನಿಮಗೆ ಪರ್ಸ್ನಲ್ ಆಗಿ ಯಾವುದಾದ್ರೂ ಕಾನ್ಸೆಪ್ಟ್ಸು ಡಿಫಿಕಲ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಇದೆ ಸರ್, ಈ ಕಾನ್ಸೆಪ್ಟ್ಸ್ ಬಗ್ಗೆ ನಮಗೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ ಅನ್ನೋ ನಿಮ್ಗೆ ಪರ್ಸ್ನಲ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಇದ್ದರೆ ನನಗೆ ಫೋನ್ ಮಾಡಿ ಹೇಳ್ರಿ ಅಮ್ಮ ಯಾರಾದರೂ. ಸೊ ಐ ವಿಲ್ ಟ್ರೈ ಟು explain those topics also. Okay, right. So next one, treatment of cancer. Treatment of cancer. Treatment of cancer, many types. In that, one of the common treatment is surgery. Yeah, it is very simple process, ma. Directly by doing surgery, they can remove tumor cells. It is one type of treatment. Second one, radiation therapy. Radiation therapy. In the radiation therapy, we use X-rays, ma. By using very strong X-rays, we irradiated lethally tumor cells. That means by using powerful X-rays, we can kill the tumor cells without damaging of normal surrounding cells. That is the method of radiation therapy. Okay, and the third one is chemotherapy. Chemotherapy. In the chemotherapy, you know that chemo andre chemical. Some therapeutic drugs. Some therapeutic drugs are given to the patients. Some therapeutic drugs are given to the patients, thereby the tumor cells will be killed. But there is some disadvantages, side effects in the chemotherapy. Adenu andre loss of hair loss agutte patient ge, mattu a kind of situations we can see it. I mean, these drugs are for one type of cancer, one type of specific drugs are available. We can't use the same therapeutic drugs to the all the chemotherapeutic treatment. Okay na? So specific cancers ge specific therapeutic drugs na maatrane ನಾವು ಇದರಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತೀರಿ. ಓಕೆ ಮಾ? ಸೊ ಆ್ಯಂಡ್ ಸೈಡ್ ಎಫೆಕ್ಟ್ಸ್ ಆಫ್ ಕೀಮೋಥೆರಪಿ ವಿ ಕ್ಯಾನ್ ಸೀನ್ ಇನ್ ಲೈಕ್ ಹೇರ್ ಲಾಸ್ ಆ್ಯಂಡ್ ಅನಿಮಿಯಾ ಅನ್ನೋದು ಕಾಮನ್ ಸಿಂಪ್ಟಮ್ಸ್. ಆ್ಯಂಡ್ ಲಾಸ್ಟ್ ಒನ್ and another one is called immunotherapy. Immunotherapy. In the immunotherapy, what we do? Just we are giving to the patients biological response modifiers. Biological response modifiers. You know very well, dear students, what are biological response modifiers? Example, alpha interferons. So in this treatment, Dr. Uncle's introduces alpha interferons to the patient. these alpha interferons will go and activates that cancer patient immune systems, make it powerful, and thereby that powerful immune system will go and destroy the tumor cells. This is the process of treatment. And you know one thing, majority of cancers are treated by combinations of surgery, radiation therapy, chemotherapy. ಈ 3 ಮೆಥಡ್ಸ್ನ ಯೂಸ್ ಮಾಡಿ ಆ ಕ್ಯಾನ್ಸರ್ಗೆ ಟ್ರೀಟ್ಮೆಂಟ್ ಕೊಡೋದಕ್ಕೆ ಪ್ರಯತ್ನ ಮಾಡ್ತಾರೆ. ಓಕೆಮ್ಮ, ಥ್ಯಾಂಕ್ ಯು ವೆರಿ ಮಚ್. ವಿಲ್ ಮೀಟ್ ಯು ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್. ಓಕೆ, ಸೈನ್ ಔಟ್.